see your links that you post. There you go. Let me look at that. Okay, so where are these other scientific methods that exist? That literally what you provided, all that says is that there are several versions of the scientific method, but it doesn't show what those other versions are. Like I'm asking you to provide these other variations of the scientific method. Surely they exist, right? Because you're saying they exist, right? So can you please provide the sources for these claims that other scientific methods exist? Let me rephrase that, because then you're just going to post something saying the same thing again. Not a paragraph saying that they exist. Provide the actual methods that they
They
are.
do have they may have variations on it, but notice how it was the scientific method because they all have key components, which would be observation of a natural phenomena, hypothesis and experiment. They're all going to have that at least. There might be other clerical things involved and shit, but other than that, those are going to be three key components of it.
Yeah, that's exactly what the source that he provided in that PDF says exactly what you just said. That they're not extreme variations. It literally says they all begin with identification.
Like you ask any of these professionals, they'll tell you, yeah, you got to have a natural observed phenomena, a hypothesis, and an experiment for it to be, considered doing science. Natural science. We're not counting computer science or whatever, what other goofy shit you got. So who was telling me it was extremicists? Were you telling me computer science is a real science or something? Or natural science? I
don't think
forgot.
I said that. Did I say
You
that?
said some crazy shit. You said some crazy shit one night.
I mean, astronomy is a natural science.
No, it's not. Stop playing.
According to every definition in every academic institution, publication, and individual, it is. So the only people that says it's not are flat earthers.
This is the conversation that led us down to you telling me computer science was natural science. This exact thing right here.
I'm not sure I said that, but I kind of vaguely remember this conversation. Yes.
Yeah.
Where's the experiment in astronomy?
Yeah, you're missing key components.
I'm not talking about the experiment. I'm just talking about the definition. The definition, there is not one contradiction, zero, absolutely none, in any scientific publication, institution, or individual that will say astronomy is not natural science, except flat earthers. They are the only ones that say that.
That's literally a whole appeal to authority fallacy right there. You're saying that because every textbook in the world and everywhere in the world says that astronomy is a science, therefore it is. That's an appeal to authority fallacy.
At what point does appeal to authority become acceptance of somebody smarter than you?
Because you're making a claim that because every authority, take the word authority, don't don't associate that just with government. That authority means a university, a college, a professor's publication. It means that you're appealing to something that is in this case higher in knowledge than us. That's what you're saying. So you're appealing to authority. You're appealing to people who are supposed to be quote unquote smarter than us, and saying that because these people publicize in their writings that astronomy is a science, therefore it is. That's what you're saying. That is an appeal to authority fallacy.
So, in general, you do appeal to people that are better at their profession, their trained profession, their area of expertise, what they study. You generally do appeal to those people rather than your own lack of experience, lack of education, lack of understanding. That only makes sense.
Still fallacious. It's still fallacious. I don't care if you do that.
No, it's common practice. It is what you do. Somebody trains for 10 years to learn something. You expect and understand that they are smarter in this area than you are.
No one.
So hold on.
In this area.
That's a false analogy, because I mean, or not an analogy, but it's a non sequitur, because anybody can study for anything and be an expert on that. Doesn't make it natural science.
I tell you what, you find one definition. It doesn't matter. One definition aside from flat Earth.
Definition: science is the systematic study of the structure and behavior of the physical and natural world through observation, experimentation, and the testing of the theories against the evidence obtained in the world. In other words, where is your experimentation in astronomy?
Hold on, let me finish my sentence. Hold on, I will answer your question, but I'm going to ask my question first, and then we'll find me one counter example where one scientific publication, institution, or individual says that astronomy is not natural science. Now, to answer your question, you can get natural science from something like, for instance, spectroscopy.
Right, there's experimentation, isn't it?
Wait, what?
Where's the experimentation in astronomy?
So, aside from astronomy, is spectroscopy natural science? As a general term, whether it's astronomical or not, in general, on Earth, is spectroscopy a natural science?
Why are you avoiding his question?
Because I'm going to keep going. Once he answers this question, we'll go to step 2.
Why don't you address this direct question?
I will say, fine, if you want me to answer, I'll just say spectroscopy. The spectrum of the light emitted from a star.
Yeah, what are you actually measuring? Is there stuff between you and the star?
No.
There isn't? So there isn't no atmosphere. There isn't whatever gas. How do you know there's nothing between you and the star?
Okay, let's take the exact opposite of this.
No.
Hold on.
Stop going. You keep doing this, man. You keep changing the subject when I ask you question.
Let me say this again.
Stop.
I'm going to answer your question.
I'm not going to understand you, bro. I'm not, because every time I ask you a question, I give you an answer. I give you a question about what you're asking me. You want to avoid it and go somewhere else.
So by me telling you I'm going to answer your question, that is me avoiding the question. I kept saying I'm going to answer your question. You kept telling me I'm avoiding the question and wouldn't stop talking to let me answer your question. I said it like 4 times. I'm going to answer your question. And you said I kept avoiding it. So I'm going to answer your question. Okay. Spectroscopy. If you do it on Earth in a laboratory environment, or it doesn't even have to be a laboratory environment. It could be any environment. It doesn't have to be controlled. It could be any environment. You take the spectrograph reading of some sort of light that emanates, and you get a particular spectrographic signal of the elements that make up that material. Now, you take up, and I mean, that material can have hydrogen and helium and whatever other elements in it. gases, and etc. Now, you take the spectrograph, and there's a particular wavelength that those gases are absorbed in. Whatever that, I think it's, I don't remember, but it's very signature wavelength, and it's very specific. Now, that is on Earth, okay? That happens on Earth. That, I mean, we both agree that that's accepted science, right? Do we agree on that? If it's on Earth, it is accepted science.
Accepted science.
Was that a yes or no?
I don't know. I don't like the term accepted science. What's accepted science?
So let me rephrase it. Is spectroscopy on Earth an accepted science?
Is it a natural science? I guess so. I think it is.
Okay, so we'll say yes.
I'm not too in depth in spectroscopy.
Okay, how about probably? We'll go with probably on that one. Okay. Now, to rephrase how it works, you get you take the spectrograph reading of a particular gas or whatever in a light passing through this gas emanates a particular spectrograph reading. There is particular wavelengths that are blocked out. There's a spectral line where that particular element absorbs that particular wavelength. I mean, it is exactly that wavelength. And I can't remember what hydrogen, helium, but they all have their particular wavelength. Now, this is on Earth, by the way. So this is on Earth, okay? Now, you take this to the stars. You do this, you point your little reading or whatever at a star, particular star, and like, hold on, let me look this up real quick. I'm going to look up the particular wavelength for hydrogen. I want to say it's something centimeters, but hold on.
Bro.
Why are we even entertaining this straw man? I just don't understand.
This is what we do. This is what we do. We let him play it out.
Oh, okay. I'll just shut up, man.
I mean, you can call out their fallacy, but we usually go all the way with it.
Well, I couldn't find it. But anyway, couldn't find it for something specific. But anyway, so let's say it's, just for the sake of argument, it's 950 nanometers, hydrogen. That's the spectrographic, that's the absorption line for hydrogen. 950 nanometers. Now that's on Earth, okay? Keep in mind, this is on Earth. So you do this little test on Earth, you get 950 nanometers, hydrogen absorption line tells you that that gas, whatever you're testing, consists of at least hydrogen, if not other gases. But at least one.
Do they do this out in the open, or do they actually have to enclose?
It's one of the most isolated systems in the fucking world.
That's what I'm trying to get to. I want to see.
I'm going somewhere with this.
All right.
So I'm going somewhere. So you know that particular gas has hydrogen. It can be in a lab environment. That's fine. It's controlled.
Why is it controlled?
Gas, hold on.
Why is it controlled?
Huh?
Why is it controlled? Why is it not just done in the open?
You're controlling for other outside, I don't know, whatever else that you want to control for. But anyway, so that 950 nanometers, that's hydrogen. Again, I don't know that that's the exact number, but we're going to go with it for now.
Right. Well, I'll give you leeway on that. Okay.
So now you take the spectrograph reading. Now, again, to reiterate, this is specific to a lab here in Earth. 950 nanometers. That gas or whatever you're testing has hydrogen in it. Okay. Now you do this for a particular star. Now that star's spectrograph reading also shows exactly 950 nanometer wavelength is absorbed. Now, the obvious conclusion is that star has hydrogen in it. Why would you not conclude that?
And this is
I'll tell you why.
And this, go ahead, Essay.
First of all, extremists. The question that you asked, if terrestrial spectroscopy is good, and I got to be brief because I'm busy, but I can't stand by and listen to this rubbish. Terrestrial spectroscopy is done in a closed environment where all the variables are controlled, and it's definitely 100% reliable. The spectroscopy that you're talking about, Extremis, is pie in the sky, millions of miles away with stuff in between you that you have no clue about. So sorry, bro. It doesn't work.
Let me ask you this question, Extremis. Is there hydrogen in the atmosphere? And I'm just using that term loosely.
There is some. And again, you're right. I mean, you're going to get a broad, you're going to get more than just hydrogen, 900. I mean, you're going to get several other elements, a number of elements on this. Yes.
So as far as you know, right, that's the gases on Earth. And now you're trying to measure stuff that it's cross vast on your model or on the model. I'm going to say yours. On the model that's way out there. You don't know there's anything between us. You don't know what's at all there. And you're going to make the assumption that, well, I got this reading, therefore that's what that is.
Yes, that's exactly what you do.
So but are you sure there's nothing in between us? I mean, there's already Earth atmosphere that you admitted that there is hydrogen. There's also carbon dioxide, neon, and all kinds of other stuff, nitrogen, oxygen. But you got a reading of whatever hydrogen, and that's your conclusion, bro?
Is this even science? This sounds like a measurement to me. You're just making a measurement of something.
Science is the science of spectroscopy in terms of why does hydrogen absorb 950 nanometer spectrum? And again, that's not the number, but why does it absorb that particular wavelength?
Bro, what's your natural observed phenomena in this? We'll start from the beginning, maybe.
Of what?
I might have missed it.
So
this whole science endeavor you're about to do.
So to be clear, are we talking about why this natural observed phenomenon, why spectroscopy works in general? Or, because that's a whole different thing from the spectrum of the sun. There's a difference between the spectrum of the sun and just spectroscopy in general.
I mean, spectroscopy is just a measure of, is practically the visible light in all bands of electromagnetic spectrum, right? So it's just a study of colors, right?
Well, there's a lot more to it. Again, going back to what I just said, why does hydrogen emit or absorb? And it's not just about, because there's also the emission spectroscopy. Why is there emission and absorption spectroscopy of these elements at these particular wavelengths? Why does hydrogen absorb at 950 nanometers, whatever it was?
Okay, this is supposed to be your natural science thing, right? That does the scientific method, the spectroscopy thing. Is that why we're doing this? Yes. I can always make you say computer science is natural science, so don't make me go there. I'm just fucking with you. Seriously though, is this supposed to be the natural science thing?
So I actually just found it, and in the visible part of the spectrum, hydrogen absorbs 410 nanometers, 434, 486, and 656 nanometers.
Okay, but did you observe anything to be like, oh, I need to investigate farther? Like, you must have saw something. This is also going to be your dependent variable in the hypothesis in your experiment.
Have you looked at the history of spectroscopy?
I don't, dude. I'm not interested.
Okay.
I just want to know what the fucking observed phenomena is.
The observed phenomenon is you shine a light through some gas, whatever gas you choose, and when you see the spectrum, you shine it, whatever, you're going to see some dark lines. Normally, you get a whole big, prism of all the visible spectrum. The observed phenomenon is there are certain black lines at very specific wavelengths. That is your natural phenomenon, natural observed phenomenon.
Really?
Yes. That's how it was found, actually. That's exactly how it was discovered, in that somebody was doing this, and they're like, wait, why are there black lines in this spectrum?
So they didn't observe it in nature, but all right, I'll give it to you. We'll play along.
It can. I mean,
right, we'll go all the way with them guys, or what? All right. So what was the actual thing we saw happen? Because we're going to look for the cause of it.
Okay. So the natural thing we observe is, so you have a spectrum. Normal, there are certain black lines at certain wavelengths. That's the naturally observed phenomenon.
What?
I mean, I don't know. I was going to give it to him if you want.
He's lucky I don't have time. He's lucky I don't have time.
You really should read on the history of...
Where did you observe this in nature, natural black lines?
I mean, light is a natural thing. Is a natural thing. I mean,
hold on.
No, I'm going to answer the question.
You said zebras. I take it.
So we agree that just shining a light through a prism and getting the rainbow of colors, like a rainbow, that is a natural phenomenon, right? That's perfectly natural. Right?
Rainbows. Hell yeah.
Okay, so we have this natural phenomenon spreading the light into the spectrum. What we observe if we do this through certain gases is that we get a particular black lines at certain wavelengths. Why is that not a natural phenomenon? Gases occur in nature.
I was willing to give it to you.
It's natural. Spreading it into a rainbow or a prism or whatever you want to say, those are all natural things. Why is that not a natural phenomenon?
Bro, I was willing to go on. Let's go on with the cause of it.
It seems a little silly to deny that it's a naturally occurring phenomenon. But we'll go with your answer, Jeremy. Okay. So now, what is the cause of that? Why does that happen?
Yep.
Okay. Again, I'm a little bit of a amateur on this. So, this is sort of a very high overview thing. But the simple answer is that at certain wavelengths, these absorption lines correspond to certain electron jumps in the atom as far as the energy absorption of it. That particular hydrogen, oxygen, helium, they absorb certain wavelengths when the electron jumps to different energy levels. So that's how that happens. Now, again, if you want a more detailed, I would suggest that you actually read up on the actual thing, because that's the end of my knowledge right there. Okay, that's it. That's all I know.
We could go with that. No, we could go with that one. So, the electrons that we don't even, are you sure they exist?
I mean, if they don't exist, you're going to have to rewrite the entire periodic table. Is the periodic table acceptable?
A lot of arguments for this electron not even existing. So, I don't know.
You can say that, but all of chemistry requires the electron to exist. All of chemistry. If you deny it, you're literally denying chemistry.
So, do we got like a picture of one, or do we, how do you know where it is?
Actually, that's the whole idea of quantum mechanics, is the location of the electron.
No shit.
Is not, it's a probability, it's a wave function.
You don't even know where it is.
Probability mechanics. But again, the entire idea of chemistry requires the electron to exist. So you can deny it, but if you're denying the electron, you're denying all of chemistry. Whatever.
That doesn't relate. Anyways.
I mean, the two go
I don't
hand
have
in
to. I
hand.
don't have to disbelieve chemistry for the electron not exist.
Yeah,
That's
you do.
ridiculous. Absolutely not. Anyways, whether this thing does or doesn't exist, you said that's causing the gases is causing the light
The
passing through
absorption
the
lines.
gases.
The absorption lines
Yeah.
are when the electrons change energy shells or energy levels. And that particular wavelength happens when the electrons jump at certain energy levels. They jump to different, at certain energy levels, they jump, let me say, hold on. They jump to different wavelengths. That's it. That's what I wanted to say. The electron, when it absorbs enough energy, it jumps and absorbs a different wavelength.
Okay, so what do you manipulate things in this experiment that you do? What do you manipulate? Hello? You're about to do this
To me, you're
experiment,
trying
right? What are you going to do?
I mean, you can manipulate the energy of the light, make it a stronger light. You can change the wavelength of the light. And these manipulations will change that absorption spectrum such that if you change the energy, you get a different absorption wavelength. And that's, I told you, I gave you the 3 or 4 different wavelengths that you see for hydrogen specifically.
Oh, no, that's dope. That's good. That's good. So what are you going to, okay, now we're going to do it in outer space one. What are you going to manipulate there?
You're going to, so before we go there,
What do you mean before we go there? We're there.
Hold on.
No,
I'm
we're
just
there.
Just recapping where we are at before we go to space. Okay. So we have this light went through some hydrogen gas. It shows an energy level or an absorption spectrum at 456 nanometers, whatever I said earlier. Or one of those. I gave you 4 of them. One of those. Okay. So that's here on Earth. So now we have the light coming in from a star, the sun, to start with. And this, we look at the spectrum of the sun's light, and we see an absorption line at 456 nanometers. Now, if we see that as hydrogen on Earth, to me, the logic, and then there's no problems. You know, that's light, that's energy. This is an absorption spectrum. The logical conclusion is that hydrogen is part of the sun. Now, hold on. Before you reply to that, so we look at a different star. Now we look at a different star, and it also shows hydrogen gas. And in fact, I think all of them, as far as I know, they all show different hydrogen spectrums for their different hydrogen absorption lines for their spectrum. I don't know of any that don't, but maybe there is a few.
So you're not manipulating anything then?
I mean, it's the experiment shows that spectroscopy works. So we've already done that. So now it's just
no. We're about to do this other. Hold on, bro. No, not and now that we already did the experiment. You're about to do this other experiment out in outer space.
At this point, it's just an observation. It's not an experiment, it's just an observation. Because we're not really manipulating. The only thing we're doing is looking at, for just the sun, we're only looking at the spectrum. We see the absorption line for that particular wavelength at that particular, that particular element, whatever it is. So we're only looking at the spectrum of the sun. Just an observation. We see the element 450 whatever nanometers that indicates hydrogen. That's all that we've done for this observation. There's not really an experiment here.
I thought this was your experiment. This was your natural science thing.
So
was this
that's
thing?
Just the sun. The experiment would be that we can look at different stars and see different spectrums. So now we're changing the dependent, whatever. What we're changing is now all of the other stars, not all of them, but dozens, whatever stars, we see that those different spectrums and those different absorption lines corresponding to different elements. Now, the different elements all have their different absorption lines. Okay? And
dude, this is the worst experiment ever. You didn't manipulate anything.
We changed the light. We're looking at a different star.
You didn't change the light.
We looking at a different star. How is that not changing something?
You're still just all you did was look at one thing, then you looked at another thing. You didn't manipulate anything.
I mean, what is that? How do you not understand that
You're observing
something else? We look at one star.
You made an observation, then you made a second observation.
But here's the difference.
You made it.
What?
You made one observation, and then you made another observation, and then you think you manipulated something.
We did. We changed, but and then we looked at something else. That's the changing. I mean, if you're conducting different wavelengths, you are changing the light that you're looking at. And it's, by the way, it's in different colors for the record. But anyway, so when you look at the spectrum of these other stars, they show different absorption lines. Now, most, like I said, I think they all have hydrogen, but some of them will have other elements in their spectrum in terms of their absorption lines. Helium will show up, carbon, oxygen, different elements. I'm going to throw this in there. This is not really part of anything. But
hold on.
Go ahead.
Would they change would you get different absorption lines if, say, there was a lot of hydrogen gas in between them? Or a lot of helium gas or a lot of nitrogen or something?
The problem with that idea is that if there is a lot of whatever gas in between us, then this gas has to feel the available volume, as you flat earthers are so fond of saying. So it would feel all of the distance between us and every direction of space. And if that were the case, every single spectrum would look the same because this gas, wherever it is, whatever it is, would fill all of the available space. And it would be in every direction. And that's not what we see. And by the way, I thought I was going to mention this here. They actually, so stars
cool
have,
story. Where's that curvature at?
Hold on. By the way, so stars have hydrogen and helium are the two most common elements. They actually call stars that have a high concentration of elements heavier than helium, they call them metal-rich stars. I thought you might want to know that. Metal-rich stars are actually elements heavier than helium.
Definitely didn't want to know that. You don't even know that. You think you know that. They think they know that. All right. Now, if you have a different amount of gases or something happening in between the star and us, you're going to get different readings.
No, I just explained why. If that was the case, and you had some sort of gas between us and the stars, this gas would fill all of the available space. In other words, it would expand outward and fill everything in every direction. And if that happened,
that's what you would think, right?
That's what you would think.
That's what you would think, right?
So we should go up. Law, by the way, that's your favorite natural law. Gas fills the available space. It should be in every direction. And if that was the case, every single spectrum would have the exact same thing.
That's what you would think, right? You would think it would fill the space, but apparently that doesn't happen. So now we gotta actually go investigate and see. Hold on, man. We gotta actually go investigate and see what's happening. You're making assumptions about this thing you're looking through, and you don't even know if those assumptions are true.
No assumption. I'm simply using
the
flat Earth version of natural law that gases fill the available space.
Flat Earth version. That's not even the flat Earth version.
Okay, you have no control. The real version of gases fill the available space. That is true. And therefore, if there is some sort of gas between us, they would fill all of the available space out there, and every spectrum would be the same.
Would it? Because there's a dynamic system, right?
We heard you.
Go ahead. Go.
I'll back out right after this. I gotta go. This is the worst experiment I've ever seen. You have no fucking controls. You're not manipulating anything. You don't know what's in between you and the star you're looking at. This is terrible. This is not good science right here.
So just to recap what we've done, we get this 450.
Bro, I just recapped it.
Okay, I'm going to recap it again.
You can
more specifically. Whatever. 450 nanometers. We do this experiment on Earth. We get this gas. That's hydrogen. That is acceptable. We look at the spectrum of the stars, and some stars we get this 450 nanometers. That's hydrogen. We look at another star, we get hydrogen, helium, oxygen. We look at another star in a different direction. In fact, not even a different direction. We're going to look at a star 1 arc second next to it. Okay, so we're looking at one star here. We're going to look at one right next to it, basically. That next to the star, right next to it, we get a completely different spectrum. So if you've got gas in between you to this star, why isn't it in between us to this star right next to
it? Even if this was all true, and you did know what was in between us and that other star, which you don't, you have no cause and effect relationship going on here. You've basically just taken a measurement of what the light is. What's your cause and effect with this?
Again, it's not, the whole point of this is to identify the makeup of the stars.
Bro, give me the hypothesis for this star thing.
Do what?
Okay, give me the hypothesis. Give me the hypothesis for this star thing.
What, here is the original hypothesis going back 150 years. What powers the stars? Why do they shine? What power mechanism allows the stars to give off energy?
That, sir, is not a hypothesis. Those are some good fucking questions. I will say those are some great questions. That is not by any means a hypothesis whatsoever.
That's the naturally observed phenomenon. The stars shine. The sun shines. Now, a couple of 100 years ago, we don't know why. Why does the sun shine? There's a lot of heat, a lot of light.
Still don't know why.
Various reasons, various observations. The sun shines. Not only does the sun shine, stars shine too. Why do the stars shine? Why does the sun shine? The stars were really a separate thing. Mainly is why does the sun shine?
Now, this is the horrible. You are a globe liability at this point.
Now, enter the atomic age. In other words, the atom model. And now we have an understanding. First of all, by the way, hold on, back up a step here. Before we really understood the whole model of the atom, we did this whole spectrum thing, and they figured out the spectrum. And they looked at the spectrum, figured out it's got hydrogen, and then eventually they figured out the whole protons, electrons, and all that. As also a side note, this whole spectrum thing, this is actually how they discovered helium. Helium was actually discovered in the spectrum of the sun. First, not even detected on Earth to begin with. Detected in the sun's spectrum first, before it ever was found on Earth.
In the meantime, listen, in the meantime, with this once upon a time story you're telling me, this spectroscopy thing you try to do in space is not science, bro. You're not following the scientific method.
I just want to be clear, spectroscopy on Earth is science. Spectroscopy of the stars is not science. Is that what you're saying?
If that's what you want to go, that's what you said basically just now, because you have no control variables. So you make two observations. You looked at one light in the sky and then looked at another light in the sky.
Okay.
You did not manipulate a thing.
So
you have no controls. You don't even know what's in between you and the thing you're looking at, which is definitely needed for this.
I'm not even doing it in the stars. Let's do it back on Earth. I am doing this in a lab. I do this. I take this helium gas or hydrogen gas, pass a light through it. I get this absorption line, 450 nanometers for hydrogen. Now, here's what I'm manipulating. I'm going to do a different gas. I'm going to pass a light through a different gas. This is what I'm manipulating, changing the gas. I change the gas to oxygen. We'll go with oxygen. And I don't know what the line is. Pass this light through oxygen, look at the spectrum. I now get a different absorption line for oxygen. So, this is in a lab setting, keep in mind. Is this acceptable science? That was a yes or no question.
So I missed everything you just said. Ask it again.
Okay. So, I'm going to do this in a lab setting, not in space, not with the stars and the sun. I'm doing this in a lab setting. I shine this light, I pass it through a gas of hydrogen gas. I look at the spectrum of this gas. I get a 450 nanometer reading. That's what I get for hydrogen. Okay? Done that. Now I'm going to change the gas. This is what I'm changing. This is what I'm manipulating. I am changing the gas. I'm going to do oxygen this time. Pass this light through a gas, oxygen gas, and now get a different spectrum, a different absorption line for oxygen. I don't know what it is, whatever it is. Now, I have done 2 different gases, and I could keep going. You can do all bunch of
This
them.
this sounds pretty scientific. I just have one question though.
Okay.
I just have one question though. For your control variable, what are you controlling in this?
Using the same light, the same color, the same white light or whatever.
All right.
I'm using the same white light from the same, light bulb or whatever you want to call. I'm not changing light bulbs, whatever.
Yeah.
Same
you're
light.
also controlling the environment the light's passing through. This
Right.
sounds very
Fair
highly
enough.
controlled. Highly
Okay.
controlled. All right,
Yes.
cool.
Okay.
It's not very scientific to me, yeah.
Okay. So this, we agree, is science. Okay, so we're in a lab. We agree this is science.
You're manipulating things. You got control variables. This shit is on point right here. No doubt, bro.
We have very specific wavelengths that we have discovered for all of these different elements. You pass a light through these different elements, you get these very specific wavelengths, okay, absorption. Now, if I look at the stars, the sun, and I get these exact same wavelengths that correspond to the elements on Earth, for instance, I do helium, hydrogen, carbon, oxygen. I do those for the sun. I get some of these same wavelengths. But let's say I'm looking for one in the sun of something a little bit heavier. I can't remember, but something a little bit heavier. I do not see that particular line for the spectrum of the sun. I then conclude that the sun does not have that element in it.
Or there's not something in between you giving you some kind of different reading than what you think's in between you and the sun.
That's fair.
Did you ever think of that?
Okay, that's fair.
Because that's why this sucks. You have no controls. You're not manipulating anything. Your hypothesis was a string of never-ending questions. Why do the sun shine? Why is this water wet?
So now I'm going to look at the spectrum of a star, and I get a particular spectrum, absorption lines, whatever. I look at the star right next to it on the right side, and I get a particular absorption line spectrum, something a little bit different. Maybe there's some carbon. The first one didn't have carbon. The second one does. So I get something a little bit different. Now, I look at a star to the left of that initial star. So I've looked at one to the right. Now I'm looking at one to the left. And now I get a third different spectrograph. And this one has oxygen in it. It shows an absorption line of oxygen. The first two, neither one of those showed oxygen. This one on the left does show oxygen. And so generally speaking, astronomers will conclude that left star has oxygen in it, the right one has carbon, I think I said, and the middle one has helium and hydrogen, among other elements. Now,
so you found out what something's made of. Like, what did you do here? What was your result of your experiment that you didn't do?
So in your attempt to debunk this, you're saying that there is some sort of... I
already did.
Well, but you're saying that there's some sort of gas between us and this star, okay? Now, the problem is that if that's true, and I'm looking at 3 stars that are basically right next to each other in the sky, I mean, very small separation, then why wouldn't I get 3 of the exact same results? If there's hydrogen, helium, oxygen, and carbon between us and that star, I should get hydrogen, oxygen, helium, and carbon on all 3 spectrographs if they're between us and that star, because they're all very close. So that gas should be in line with all 3 stars. But I don't get that.
And cool. If you found out what something's made of, that's no cause and effect relationship. That's not science. You just found out what something was made of. Like, you didn't really do science here. Even if I let all that other bullshit fly before that came before this.
Okay.
Whoop-de-doo. You found out what the fucking star's made of.
Well,
Great. You didn't do any cause and effect shit.
So
this is no cause and effect thing.
So just to be clear, we have or have not found what the stars are made of.
Even if I give this to you for this argument right now, if I give this to you, you still didn't do any science. I understand you're trying to trap me into some future thing. Yes.
No.
No, of course not.
Well, we've made an observation. We've drawn a conclusion from the observation that the stars are made of these elements. Now, if they're made of these elements, if we accept that conclusion, then we can, make some other conclusions, I should say. There's some other things that we can deduce from that.
Where's the cause and effect?
Irrelevant. Absolutely irrelevant.
For you, because you don't know what our conversation is about.
Go ahead,
Science is the study of the physical and natural world, and measuring it is, in fact, making observations and measuring things is the most part of science. Measuring the mass of a proton, measuring the speed of light, measuring what we're made from, measuring how our blood system works, observing it, how a plant structure is. Most of the things in science are observations. Science is the study of the physical and natural world, and that includes measuring, observing things. The cause and effect thing is just another part of science. How the hell you can think that knowing the mass of a proton is not science is just ridiculous. This is just QE nonsense. This is an idiot who knows nothing about science, and you're parroting his drivel.
Well, hold on, Rumpus.
I just want to say, Extremistus, you did much better than last time. Nice work. You're getting better.
Okay. But Rumpus, what we're specifically talking about is spectroscopy and how observing the absorption lines of the spectrum of the stars lets us determine what the stars are made of.
Exactly. It's a fantastically important thing. That's a study of the physical and natural world, and working out what a star is made of is a very important part of our knowledge of the physical and natural world. And that's a part of science. What else is it? It's not law. It's not medicine. It's science, and it's the study of the things around us, and that includes working out what they're made of. The fact that people are parroting a QE anti-science nonsense, low IQ drivel moron is just incredible.
Relax, bro. Holy shit.
The guy can barely do any maths.
Bro, he's a
science denier, and the fact that you're parroting his drivel is just extraordinary.
QE did not make this up. This
yes,
is well known.
He's unique in thinking that science is only about experiment. There's no one else in the world except his acolytes and parroters who thinks the same way.
Yeah, but listen, The QE didn't make this shit up, bro. This shit came from
He did.
universities,
He's the only person in
college,
the world who's defined
government.
science as working at cause and effect and nothing else. He made that up.
That's how the
and you're
scientific
parroting this
method.
drivel.
That's the scientific method. You got natural
Yes,
observed
but that's
phenomena,
something different. That's
cause and
part of
effect.
science is more than the scientific method. Science is about the study of the physical and natural world, and then cause and effect is a part of that, and you use the scientific method to do that. You can also apply the scientific method to observations, but it's normally referred to as part of experiments. But understanding the mass of a proton, the speed of light, and what things are made of is the majority of science.
No, if there's no cause and effect, you didn't follow the scientific method. If you didn't,
so you think
hold on, Rumpus.
So you think
Rumpus,
not
hold on, bro.
measuring,
This
you're
is
not
why
understanding
people
the
get
mass of
pissed.
what is that then?
I just started talking, bro.
Okay, go ahead.
Shit. I forgot what I was going to say. You
Well, at this
motherfucker.
point, so understanding what the world around us is made of is part of science. That does not involve cause and effect. And if you think that not understanding what is around us, what things are made of, the size of atoms, the mass of atoms, is not part of science, you've just lost.
Wait,
your brain is
remembered.
just not working properly.
Hold on. I remembered, right? When we know the scientific method, and we know what has to be done for those steps.
No, it doesn't.
A natural observed phenomena.
No, we don't.
Yeah, that's what you need for the scientific.
Size of the Earth. That's got nothing to do with cause and effect. It's measuring the mass of protons has got nothing to do with cause and effect. Measuring what things are made of has got nothing to do with
totally
cause
based
and
on
effect.
cause and effect.
No, it's not. Absolutely not. I observe the size of the universe. I observe the size of an atom. That's got nothing to do with cause and effect. It's a measurement operation. It's a pure observation.
Listen, if you don't follow the scientific method, you're doing pseudoscience. Straight up. We know
wrong.
that.
The scientific method is only about cause and effect. Observations, also, it is said that, in fact, observations are part of the scientific method. Normally it applies to experiments. Cause and effect is a small part of science. If you think that not understanding that what an atom is, the size of an atom...
I'm not dealing with this.
It's just ridiculous if you think that's not part of science. Or what stars are made of is not part of science. I mean, it's just ridiculous. I mean, it's not even a contest on that one.
Who wants a little rumpus time?
You've just you must break away from parroting QE nonsense, who can't do maths, who can't do calculations, who can't do science, and he doesn't even understand. He thinks that the Google Earth is a bloody flat Earth model. You've got to not let your brain be infected by drivel.
Just stop. It's not, QE did not come up with this shit, bro. This shit is in colleges, universities, teaching websites.
There's no university that says observations are not part of science. Not one. If you get a quote from QE, you can guarantee.
Where did that argument come from? I wasn't arguing that.
Well, you just said that universities were arguing against me. I think you were suggesting that universities did not agree with my position. Universities absolutely agree with what I'm saying, and you're just using QE quotes when, of course, QE is any quote from QE is guaranteed to be contradicted in the next paragraph or the paragraph after that. Every single thing that he makes a claim of that's contentious is contradicted by the next paragraph of anything.
That's not always true.
That's not absolutely always true. It's always true.
I'm going to bring you 30 things he's quoted, and you're going to bring them all back to me.
I'll be prepared to take it as a challenge.
How much?
I'm prepared to give it 1 out of 30. It might require more than one paragraph later. But normally, when I've tested any of his quotes, I've gone to them. Whenever he's made the presentation, I've gone to most of his quotes. And I have found within one paragraph or two, and Dr. Bob has also done the same thing. And he's done several videos
once or twice or something. Anyways, it was a citation. And they're saying, if they're saying contradictory things, I mean, who do you think is quoting these people?
No, it's because he misunderstands. No, he makes a citation, he misunderstands it, and for instance, he will do things like add in extra words, like he did on the. There's a book that he often refers to on, I think, on the science of oceanography. He uses quotes for relative motion and things. And if you just read the next paragraph, And I say, Dr. Bob has done videos on this, and it's just amazing. You wouldn't credit it was possible. It's just so funny that within one paragraph, it doesn't contradict itself. It contradicts his interpretation, which is in error. So the text is correct, but he will pick out a thing out of context, misunderstand it, cite it as a point, and then it becomes clearer when you see the rest of the context and the next few paragraphs explain the point further that he's got it wrong. And he does this every single. I mean, I can't think of a single example where he's quoted something and his interpretation has been what is as he believes it to be, and then it's been reinforced by what has been further in the citation. It's amazing. I mean, it's at least 98% that it's contradicted by a subsequent paragraph. His position.
I know, Robert. So we can just go straight to the sources of all these places that say what the scientific method is. All right, and then we can see.
Hold on, you've got confused. Science is more than the scientific method.
Pseudoscience is when you. And pseudoscience is when you don't do things in line with.
Observing the mass of a proton is pseudoscience, do you?
Is pseudoscience, if you're claiming you have science and you don't follow the scientific method, you now have pseudoscience, right?
Right. So are you saying that measuring the size
of the mass of a proton? Correct?
Hold on. Can you answer this question? Can you answer this question? Does measuring the mass of a proton, is that science?
I don't know. Are they claiming their science?
Yes, of course it's science.
Yeah, are they following the scientific method?
Study of the physical. No, because you've got confused between science.
Here's the problem. The
scientific method does not necessarily apply. Though some it depends. It's a bit of an opinion thing whether there's a scientific method that applies to observations. The scientific method is usually described in terms of experiments. But if you think that measuring the mass of a proton or measuring what a star's made of is not science, what do you think it is? The scientific community thinks measuring the mass of a proton and measuring what stars are made of is science.
Hold on. I want to say this. Science is a broad thing. The scientific method is part of science, but it's not all of science. There are things within science that are outside of the scientific method.
Science is
observations are part of that. You can make an observation. Hold on, Jeremy. Hold on. You can make an observation that is part of science, but doesn't follow the scientific method.
Okay, if you claim you have science and you're not following the scientific method, guess what we now have?
Do you think measuring the mass of a
proton? Just guess. Wait, guess. Hold on. Can anyone guess?
You're wrong, Jeremy. You're wrong.
Scientific method is about experiment. Well, it depends. I keep on telling you, you're obviously ignoring this. There is sometimes referred to as observations following the scientific method, but normally the scientific method is understood to be about cause and effect. But the science, the study of the physical natural world, there's more of it about observing the physical and natural world and measuring it and quantifying it and understanding what's going on around us in terms of observation.
Do you have to do an experiment?
No, you don't. You can observe the mass of a proton.
Then you're going again what Richard Feynman says. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. So if it's not being tested.
Listen, it is being tested. You observe the mass of a proton. So it's not contradicting an experiment.
How are you testing it?
Hold on. You're observing it. You can test your measurements. You can have several people test the mass of a proton in different ways, but that's not an experiment. Do you think measuring the mass of a proton is science?
Well, here's another simple thing, very simple thing. In ornithology, it's another example. Don't let me talk, Rumpus, goddammit.
When I asked you, where do you do the experiment?
There's no experiment
exactly.
involved. I'm measuring. There's more than science, because science is the study of the physical and natural world.
Unfortunately,
measuring the mass of a proton is not an experiment.
Okay, then. So it isn't science, because
yes, it is. Science is more than experiment.
It is. You're wrong, because Richard Feynman said you could do all the guess. You could.
Yes, but that's if you decide that there's a cause and effect, and it's you don't tend to understand what he was saying. This is you're doing a QE.
Oh, so
here.
now I'm not understand what
Exactly,
he's saying. That okay, yeah. Well, you don't understand what he's saying because if you're saying that I don't understand, it means that you don't understand because when you're trying to explain something you don't understand. How am I going to take your explanation of what you're going to tell me if you don't understand? If you don't understand, how are you explaining something?
Effect. If you make a claim about cause and effect in theory, let's for instance,
Settle down, guys. Settle down.
But if I lift up my left leg,
I'm just representing the reps.
If I raise my left leg and the star would change color, that's my hypothesis. No, right. So then I do an experiment. I raise my left leg and it doesn't happen. That's what Feynman says. So I have a hypothesis of cause and effect. Then I conduct an experiment to see if that's correct. And if it's invalidated by an experiment, that's correct. But that's an experiment. He's not talking about observations. If I measure the mass of a proton, that's not a cause and effect relationship. He wasn't talking about observations. He was talking about a hypothesis of cause and effect. And that has to be validated by experiment. And if it's contradicted by experiment, your hypothesis is bollocks. And that's perfectly correct. But he wasn't talking about observations. He was talking about cause and effect relationships. So his comments were not relevant to making an observation, to determining, say, the mass of a proton, which doesn't involve an experiment. It involves an observation. It's a very complicated observation, involves lots of equipment, but it's not an experiment. You're not looking for a cause and effect relationship. You're just saying, what's the mass of a proton? This is something we need to know. If you want to build an accelerator, or if you want to know how to do fusion, for instance, which is a very important thing in this current world, trying to create fusion, you need to know how to collide protons together. You need to know the mass of a proton. So then you need to measure it. You need that piece of information to do science about fusion reactions. Now, we discovered the mass of a proton about 100 years ago, but we've become, and in fact, it's become more, we keep on measuring it because we're getting better and better answers. We only know it to about 2% or so. That is science. So Feynman was not disagreeing about that. He was talking about if you're proposing a cause and effect relationship, you've then got to test it with an experiment. That's a completely different subject to saying, I'm now going to measure something, or let's, for instance, measure determine how a heart works, observe how a heart works, observe the immune system, how that behaves, observe how the anatomy of a tree. Those are all parts of science in the scientific literature. That's got nothing to do with cause and effect. It's not part of
fewer words. Okay. Fewer words.
Well, I have to keep on repeating myself because I've had someone here who's elbow. I've explained about 5 times and he didn't understand. So unfortunately, you have to repeat the point to get through the various layers of misunderstanding.
What is in natural science, though?
Yeah, natural science. Would you think understanding the behavior of a certain species of bird and discovering that behavior, you think that's natural science?
Is there a cause and effect relationship there?
No. I just want to understand the behavior, the feeding patterns, the breeding patterns, the nesting patterns of a particular species of bird. I'm going to sit up where I know these birds are for about a year and observe the behavior of these birds to draw some conclusions about their behavior. Would that be scientific?
Is that natural science?
Yeah, sure it is.
A watch birds.
Really?
So you're just going to sit in a chair.
It's called ornithology.
So you're sitting in a chair.
The weather, for instance,
like binoculars, and that's science. Is that science sitting in a chair with binoculars?
What the weather does, so I can make predictions about what's happening. Let's say there's a hurricane coming along. These are all observations, observational science. And then you work out from the patterns of observation what's going on. It's not an experiment.
So when he sits in his chair and he does absolutely nothing.
Who's he?
Anybody, any person sitting in a chair.
Okay, you don't say he. You say before
Rumpus,
you use the pronoun he.
Rumpus, dude. We let Rumpus. No, Rumpus. Look, I'm okay with you speaking. You spoke for 2 minutes.
Well,
I'm like, it's a long time.
Oh no, identify the thing you're talking about.
No, Rumpus.
It's a grammatical error.
No, Rumpus. No.
And then you can use the word he.
You have to stop talking. You have to stop.
Rumpus, Skylane brought up a specific scenario.
You gotta mute him. Right? Like Rumpus. Come on, man. We sat for like 2 minutes. I'm just trying that, and this is how you forget the point. But so like we're trying to figure out what science is, and all he's doing is just sitting in a chair. He's literally doing nothing. So you can say that doing nothing, sitting in a chair, is science, as long as you're looking at the world. That's a stretch of what science is, man.
No,
just
you're
left, right? I mean,
documenting. You're documenting the behavior. You're seeing its repetitive behavior over and over again, so you can make predictions about how that bird acts, how it nests, its mating habits, all these things that we know about in the natural world.
But don't you need to do something like, again, I'm not you know me, I'm not one of these big science guys. I don't really, but I would feel like you need to manipulate something at least, right?
Well,
so you could get kind of a baseline.
Yeah, in that case, though, if you manipulated anything, you would be interfering with the natural behavior of that bird. So you don't want to manipulate anything.
So it's strange how there's like two views on science. One is where you have to manipulate something to get a cause. And then there's this other side of, oh, wait, you can't manipulate anything because you might be messing up the observation. Those are kind of counterintuitive to each other.
Well, it's just you're talking about the cause and effect relationship where you do manipulate independent variables. It depends on what you're doing, but that's not the whole of science. That's just a cause and effect part of it. But there's a whole world of other things that are involved in science.
Yeah, and then we got this word pseudoscience, which means when you don't follow the scientific method yet claim you have science.
You got to be careful with that.
Another
that's
strange.
right.
Because like if science could be almost anything, right? Like an observation and documentation can be science. Manipulation through cause and effect can be science. So it's almost like, where does pseudoscience land when you can make an observation and have it be science? You could just, maybe take some numbers down. This is where it gets confusing, at least for me.
Nah, man, they made it crystal clear. If you're not following the scientific method, you're doing pseudoscience. If you claim you have science, if you say, hey, look, I got science, and then somebody checks you and you didn't follow the scientific method, you now have pseudoscience.
Well, the observation of the bird, you already know what the bird is.
Don't get me wrong, that other shit's useful. We get useful information from doing this other stuff, measuring atoms or whatever you guys want to, say you're doing. But like, I'm cool with that. It's great. It's just not.
I mean, and in the general term, it's just science. I mean, it is what is science? Knowledge, right? I mean, it is a knowledge. But when we're talking about experimentation, and we're talking about natural science.
I mean, how computer science is science, extremists. I feel like I dragged him into this. My bad, bro.
Yeah, I'm not going to fall for the bait.
Which is natural science is based on empirical evidence from observation and experimentation. Just observing something and then measuring it, that it's not natural science. You have to have experimentation with it. I mean, because what Richard Feynman said was, pretty much what they do is, they guess, something, right? They see a phenomenon, they guess what it does. They do a bunch of computation, but then they have to experiment. If they don't experiment, it doesn't agree with it, then it's wrong. Whatever prediction you did, whatever competition you did, doesn't matter what happens. If it doesn't go with the experimentation, then it's wrong.
So I just want to be clear. The example that was given about observing the mating habits of some bird, you set up for 6 months, you observe the mating habits of these birds, what particular, the male characteristics, the female characteristics, and after 6 months, you write your results up in a paper. That is not natural science. You're saying.
All right. So you're saying that you could observe porn for 6 months, write a paper on it, and then therefore you have science.
So to me, porn is not any part of nature, but whatever. I mean, I guess you could make that argument. It's sex. Whatever. Yes. I mean, it's kind of a stretch, but to me, mating habits of birds is firmly within natural phenomena, so to speak. So observing the mating habits of birds, a natural something within nature, but observation of their mating habits is not natural science.
But you only get into the
that's all
first
you ever
part.
got is step one.
Yeah, step one.
You only have.
Go ahead.
This is the same thing with my bad, Elbow. This is the same thing with the last thing you tried to do to me. You only have step one. You can't even go further than that. My bad, Elbow. Go ahead.
No. You were going to say exactly the same thing I was going to say. You're exactly right.
Yeah, all you have is scientific observations. You don't have the rest of the experiment, and when the stars are not tangible, all you have is step one.
Can we draw conclusions about the mating habits of a certain species of bird without doing experiments?
That's the thing. He says you could come up with all kinds of conclusions, but then you can come up with 100% a lot of conclusions. Now, to make your conclusion correct, to actually make them scientific, you have to experiment and test them out to see if they agree with your conclusion.
So that doesn't make any sense to me. What would you do? What kind of experiment would you conduct on a bird to determine their mating habits?
Maybe some things are outside experimentation, right? Like that's the whole idea.
Yeah,
it would be like, well,
that is it. That's right. Some of these things it's impossible to manipulate to draw your conclusions. It's like interfering with the bird, manipulating it in some way would interfere with the natural process. So you really can't manipulate anything. You have to just draw your conclusions based on your observation.
Right. So it falls out of the realm of science, right? And it's just some kind of a study. I mean, it's definitely a study. You could definitely study it. That doesn't take any. It doesn't take any of the validations of what you've concluded with your observation and your study, but it doesn't fall in the realm of science, natural science, where it has to be with an observation and experimentation, which there's a cause and there's an effect.
Well, they're observing the birds, and they're doing farts. What type of light experiment are you going to be able to see to tell what type of gas is coming out of their ass?
I mean, who gives a shit about that?
Let me switch sides here in the middle of the debate. I'll take the out. So, wouldn't an experiment technically be an observation? Right? Like so instead of like going to the outside in nature and sitting down and watching, you would like kind of set up some kind of contraption and then sit and watch it. So, there's a similarity between the observation of some event and then conclusions drawn at the end of it.
No, because in an experiment, the independent variable, what you think the cause is, has to be manipulated by the experimenter.
Well, yeah, but after that manipulation, you're just going to sit and watch, right? You know what I mean?
Yeah, but if
you do your manipulation and then you just sit and you're like, oh.
So you're just not observing, right? So you're manipulating something. That's the difference. You observe the reaction to see if it agrees with your prediction of the cause of what effect you're watching, but you still have to cause it with the manipulation. You just can't just observe it.
You could put some scales on a tree and you could find out how heavy the bird is when it sits on the scales. That type of thing is called natural science. But if you're not measuring anything, you're only observing and making conclusions from observing only, then you're only one part.
So measurements qualify as science? So like observing the birds, not good enough.
Yep. No, not good enough unless you're doing some type of variable manipulation. If you're checking how much it weighs when it stands on a scale, that would be science.
No, man, no, wouldn't it? You gotta have a cause and effect thing.
I don't know. Weighing a bird doesn't seem like science to me. But again, I don't.
I don't know where that came.
No, you gotta have a cause and effect thing for this whole scientific method to happen. Like, you need this to do the thing we're talking about. You got to do the scientific method. In order to do that, you got to have a bunch of things. Like, you got to have this experiment thing where you actually manipulate the cause of some effect. The whole thing's based on cause and effect, your hypothesis and everything. Even your natural observed phenomena is going to end up being part of your hypothesis.
Why are you quiet?
Oh, systematic observation. The fuck is that, dude? All right, so you can't just observe. You got to be there every day at the same time.
Yeah, sitting in that chair for 6 months, watching them birds.
Okay, Gem, left lane.
Yeah. Dude, you guys not hear what I said about the cause and effect thing that you don't have happening with this bird watching hobby?
Bro, Gem's got to watch something on the ground. He can't watch anything in the air with his fucking posture.
Let me ask you this.
Oh, the bird fucking. I forgot about that.
Can you have something as part of natural science? Can you have something outside of the scientific method, but it is still natural science?
Bro, if you claim you got science and then you don't have science, meaning following the scientific method, you now have pseudoscience. I asked somebody this earlier, and they never answered.
So let me ask my question again. Basically, what I'm asking is, are natural science and the scientific method, are they the exact same thing?
That's where the problem comes in. You guys haven't clarified terms. So science is the acquirement of knowledge, right? So you can observe birds all day long and acquire knowledge. You can call it science all you want.
Okay.
The cause and effect, to acquire empirical evidence, cause and effect, that's a whole different ballgame. It's simple.
So that's science. So now let's go with natural science. Can I have an observation and it be natural science, but not part of the scientific method? Just the observation.
Yeah, you can observe things all day long, bro.
Okay.
Yeah, sure.
That's where Jeremy differs.
Hold on, you said natural science?
That is not the case.
Not natural science. Natural science that means something, bro. Means the observation of natural events, right?
Right.
And you gotta
observation of natural events. So cause and effect is not necessarily.
But hold on. Is observation of natural phenomena and experiment?
So
both.
And
so you can have one without the other, or do you have to always have both?
Yeah. You have to have both.
Do you agree with that?
I disagree with that.
Yes, to do an empirical scientific cause and effect where you're testing your hypothesis, yes, you need both.
Hold on, but that's not the question that was asked, SE. It was not to do an empirical thing with that scientific, with a cause and effect. The question that was asked was, to have natural science, can I have just an observation without an experiment, or do I need an observation and an experiment for it to be natural science?
Yes, you need both. Yes.
Okay. And
As
that's
far as I'm aware, you need both.
So you cannot have, and we discussed that. I don't know if you were here earlier. We used an example of just observing the mating habits of birds as an observation. Is that or is that not natural science?
It is not natural science. Negative.
Okay.
Let me just say
Observing
this one more
birds
time.
is not natural science.
Okay.
Yeah, we know. Let me just say this one more time. If you claim you have science and you didn't follow the scientific method, you now have pseudoscience. Thanks.
But see, when I listen to what you're basically saying natural science and the scientific method are the same thing. And to me, you can have natural science that follows the scientific method with experiments, or you can just observe something in nature and draw conclusions based on what you observe, and that can also be natural science.
Okay, let me ask, do you think they define the word pseudoscience wrong?
In your the way you interpret it, yes, I do.
So this is from csus.edu. Science is the systematic study, and it has in parentheses observation and experience of the natural world.
That's science or natural science?
It says science.
Okay, so now what we were arguing earlier was we said, can you have within science, not natural science, just science, can you have an observation without an experiment that follows the scientific method? Just science, not natural science.
Yes, if you define science as the acquirement of knowledge, I told you before, yes.
Okay, now that kind of goes, based on what I heard, I think I heard this, that goes against what he just said in his definition. Because according to what he just said, science, not natural science, just science, is the observation and experimentation that follows the scientific method. Now that's his definition of science only, not natural science.
Yeah, but then what you're saying is like right and right are both contradictory, because the meaning of right could be you're correct, or it could be that you're turning to the right.
What?
Yeah.
Don't.
In other words, words have many meanings sometimes, right?
But I'm saying we're doing science,
right? So,
but not natural science. We're
right.
describing science, but not natural science.
So when you have to be clear when you're specifying. When we're speaking here, we're talking about science, and then when we mean science, we mean natural science, which is the systematic study. If you look for a dictionary, if you Google science definition, it says the systematic study of the structure and behavior of the physical and natural world through observation, experiments, and testing of the theories against the evidence obtained. Now, there's also science, right? It's also knowledge of any kind.
Okay, so you can have science either way, is what you're saying.
Right, but when we're talking about here, when we usually speak about here, we're actually talking about the testing and stuff. Now, if you want to be broad and just be general, yeah, science itself just actually means knowledge of anything. It just means knowledge.
Acquiring knowledge is science.
No, knowledge of anything. Knowledge of any kind. That's what it means. Knowledge of any kind.
Okay, well, whatever.
So you pooped, you have knowledge that you poop. You have science that you poop. But it doesn't mean when you come into physics or any kind of, when we're talking about here, usually is that it's a systematic study of the structure and behavior of the physical world through observation and experiment.
So you have to have both observation and experiment for it to be science.
Right. It's a systematic in that systematic study, that means that's the scientific method.
You don't follow the scientific method, you have pseudoscience. So if you're cool with that, then just say you got pseudoscience.
Okay, so going back to this whole thing about the bird, if I just observe these birds' mating habits, do I have science, pseudoscience, natural science, or none of the above?
Are you claiming it's science? Are you claiming it's science? That's an important part of this.
Whoops. I think it is science. What do you
You're
think?
gonna watch birds. You're gonna watch birds. Come back, tell me you got science. Then yes, I will say that's pseudoscience.
So to be clear, I'm watching for their mating habits and certain other things. Okay, I'm not just watching them to watch them. I'm watching them with a particular purpose to determine their mating habits. Maybe they're endangered. I want to try to make them less endangered and help them spread, whatever. So I am observing these birds' mating habits. So I claim that's science, and I also claim it's natural science, by the way. But my question is, do you claim it's science, natural science, pseudoscience, or none of the above?
So you just watched birds and took notes?
Yes.
Yeah,
For
so
their
what-
mating
and you-
habits,
and you-
be clear. For their mating habits.
Yeah, you took notes of their mating habits and you watched birds.
Okay,
You didn't do
yes.
anything else, right?
That's all I did, and drew some
Yeah,
conclusions.
you claimed, and then you said, "Oh, I got science."
I said, in my interpretation as a glober, that is both science and natural science.
Hey, if you come at me and say you got science with that, I'm going to tell you no, you have pseudoscience, because we're going to go through it and I'm going to find out you didn't follow scientific method.
And that is the root of this whole thing is, in your interpretation, to be science and or natural science, it has to follow the scientific method and have a cause and effect. If it doesn't have a cause and effect, according to you, which is where this is going.
I didn't make this up. Not according to me.
According to this interpretation, whoever made it up, then it is not science/natural science.
Okay,
that's
so
why
you
I asked you
observed
earlier.
some birds hunting. Okay, you observed some birds hunting. What did you learn?
You learned their particular preferences, maybe a particular coloring pattern, particular characteristics that will improve, make it more likely that these birds will repopulate in captivity, maybe their particular season, particular foods that they eat before they, reproduce, whatever, particular areas near water, away from water, wet sand, dry, whatever. You learned particular things that helped you determine what would be more likely to increase their chances of surviving and populating, growing the population.
All that by watching them hump. Wow, you're some kind of a scientist, bro.
For 6 months or a year or however long it took.
No, you watch what the male bird does. How does the male bird entice the female? All these birds have different things that they do. Some of them are pretty extravagant, pretty amazing stuff. Collecting rocks.
Sounds,
you can learn some awesome
the particular way they build the house, decorate the house, all kinds of stuff.
You collected some information and you acquired some knowledge, right? So if you want to call that science, that you acquired knowledge, fine. I'll give you that.
Negative, not fine.
But now, if you want to go into, sorry?
That's not cool.
Yeah, bro.
Jeremy doesn't like that.
The colloquial term of science is acquirement of knowledge, right?
Then if that's the case, everyone's doing that.
All day long and
but the problem is, Jeremy keeps saying it requires a cause and effect. It's not just about acquiring knowledge. It's about a cause and effect. You're looking for something
hypothesis.
That causes
What's
something
your hypothesis? What was your hypothesis?
I see. The problem is they've just watered it down so much that now every time a human's looking at something, they're doing science. So this no longer has any meaning to it.
Jeremy.
Yeah. That's called the fallacy of ad dictionarium, actually.
So to be clear, SC, I am not forming a hypothesis. I'm not testing anything. I'm not controlling
We're just looking at
variables.
stuff.
All I'm doing is
every human, every second of the day is doing science according to this. You cool with that? Yeah.
You did not.
So science has no.
Right. So I think this becomes a fallacy of ad dictionarium, right? So meaning that because it's written a certain way in a dictionary, therefore that's what it is. In other words, if the dictionary describes coffee made like so and so and so, but let's say someone comes and changes. Let's say coffee is with just beans grinded and made in with water that creates coffee. Now somebody changes the dictionary to mean that no, the coffee is the bark of whatever, yada 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 yada, that's how you have coffee. Does that change what coffee really is? How you make coffee?
Every according to this,
It doesn't.
Every second.
I was hoping you'd tell me, no, it doesn't change how coffee is really made, right? Because that's what this is kind of what it's alluding to. It's that science, it's watered down, like you said. They watered down what the definition of what science is to mean whatever. But
it's happening. They've made it worthless at this point because every human that's awake for every second of the day is now doing science.
Now the question then becomes, if what you're saying claiming is science, does it make it scientific? That's a different definition.
No, all we got to do is observe stuff and learn things about the world around us. So when I watch my cats or I watch whatever, you just be looking at stuff.
I watch
every time I look at a tree.
I watch TV for like 10 hours, 6 months a month, 6 months a day. I watched the trilogy of of the what's it called? The Twin Towers, or what's it called?
Well, I mean, it just boils down to gaining knowledge through observation. Is I think what it boils down to.
Well, then we have to ask: is it scientific? I mean, the question is, if you're claiming science, is it scientific? Because then the definition of scientific is based on characteristics by methods of principle of science, and also is a systematic, methodical. So are those things scientific? What you just claim is science?
So if I, picking a particular, I'm sorry.
Remember the beginning of this conversation was about the stars and spectroscopy, right? That was what we were talking about originally, and the problem with the experiment on the stars is that not all of the variables are taken into consideration. So it's a half an experiment, and I think that's
an observation. It doesn't
it's
have
an observation, and you can say that spectroscopy does have some merit, but
it has some knowledge.
Time, it's not a complete experiment because you haven't taken into consideration all of the variables.
Yeah, you get knowledge of something you just watched, and you could assume things based on what you just. Now, it isn't empirical because you can't test them, right? So that's where what my question becomes: is that scientific? Because it has to be based on some type of method or the principles of science, right? So, in principle of science is the scientific method. It has to be systematic, tested. I think when they start claiming, "Oh, this is science," we have to always ask, "Okay, is it scientific?" Because you can claim science to be knowledge of anything, whatever you want. Okay, fine, that's fine. But let's test it. Let's see if it's scientific. That this could be actual natural science, which is the testing of the natural.
There's two different types of science besides pseudoscience. There's experimental science and observational science. And when you have to do an experiment to get some knowledge, you need to make sure you have all the variables. And when you're looking at stars, it's impossible to do that.
I don't think there's a thing as observational science. That's just, I mean, I guess, like I said, if you want to water down science to be anything that you could just observe or measure or whatever, because it's knowledge.
Observational science. You can look at waves, the way that waves. But
is that scientific?
If it requires an experiment, then you would say it's experimental science.
Right? I mean, no, it's that scientific. I mean, is it scientific? It's my question. If you're saying that experimental science is science.
Science is a very broad term, but if it requires an experiment, then that's what it requires. You don't need any experiment looking at birds.
All right, so it isn't scientific.
It's science, but it's not experimental science, and you'd need to make some type of an experiment on a star to know all about it because it's not tangible. You already know what a bird is.
All right, so it isn't scientific.
Everything is science. There used to be journalists. There used to be,
Yes.
freelance,
Well, my question is
journalists. There used to be reporters. Now everybody's a reporter.
now my
Because everybody's got Instagram and Facebook and a phone in their hand. So things morph and change.
my question still stands: is observing something scientific?
Yes,
It isn't.
it is. It's a part of science.
What's the definition of scientific?
Gaining knowledge from observation and or experiment.
No, incorrect. The scientific is a definition based on characteristics by methods and principles of science, systematic, methodical.
Science has many factions. Science is broken up into all different parts.
Not the word scientific.
Experiments, and some of them don't.
But not the word scientific.
It does. It means the gaining of knowledge.
Google the definition of scientific.
Rumpus is right, but he's
not.
He's only half right because he doesn't acknowledge that the stars are not tangible. That's where we have a lot of half truths.
So we could gain as much knowledge as we possibly can within the means we have to obtain that knowledge.
Absolutely, but you could never come to a 100% true conclusion without having to do the required experiments properly.
Right. So that isn't scientific if they don't have any they didn't go through the method, the principles of science, which is the scientific method. If they don't go through that, it isn't scientific. It's knowledge. Okay, you got knowledge. That's fine. Getting knowledge of something is not entirely bad, because you can gain knowledge by just observing some nature, human nature, or the nature of the bird. I'm not disagreeing with that. You could get knowledge of that.
It's definitely more than philosophy. You'd have to say it's more than philosophy, yeah?
So, Elbow, I don't know if you can see the chat, but I put in a little Venn diagram within the chat. And basically, it's got natural science as a big circle. And then within natural science, you can have observations as part of it, but also experiments and the scientific method, which are separate from observations. And all of that falls, both of those separately fall within natural science. Would you agree with that?
You can observe something, but you can't have natural science without the experimentation.
Yes, you can, because some scientific observations do not require experiments. And when they do require an experiment, you can either have a complete experiment or a non-complete experiment. Looking at the stars can never be complete.
I think Richard Feynman says that without experimentation, it is just poetics. It's just poetry.
But the question is an observation without an experiment, just the observation, natural science?
It's just poetry.
So going back to what you're saying, you can gain knowledge through observation, but you're not doing natural science.
Like being a mechanic, right? You can get your hands greasy and dirty and you can get in there, remove the muffler, fix it, and repair it and put it back on. Or you could look at the muffler and you could just observe it and you can see maybe the timing's out or the mixture's too rich just by observation. Does that mean you're not a mechanic?
No. You're obviously a mechanic or you wouldn't have said that.
So you can see what I'm saying is like science does have many factions, and observation is science, but it's not complete if the object you're trying to observe is not tangible.
That's why words have meanings. And the colloquial term of science is the acquirement of knowledge. If you want to use that, fine, you can watch birds all day long. But if you want to do empirical science, cause and effect relationships, you have to have experimentation. Period. End of story. There's no arguing that. Sorry, guys.
Well, it's like in a hospital, you have nurses. They're on one level. They don't have the full knowledge of a brain surgeon. So you could call them a scientist, but they're not, what was that word you used, SE? Empirical. They don't have the full knowledge to do all of the experiments. They're still a scientist.
I think we're missing the point. That's why words have meanings and, definitions are very important. I think this is the main problem we're having here tonight.
So I think the conclusion that I'm going to draw is that none of the Globers agree with the interpretation that natural science requires the scientific method and cannot be observation only. None of the Globers will agree with that, I don't think. And
you can have the problem you brought up earlier on was about the stars, and you cannot base your observations purely. You cannot just have observations in spectroscopy to know what the star is and all the attributes about it and how far away it is and how big it is and all of those things. You're going to have to do more than just observe.
Okay, I mean I'm a little more broad than specifically regarding the stars. I'm trying to come to the conclusion about what is not science, natural science, the role observations play in either one or both of these categories, and where does the scientific method come in? Because what I'm basically getting is that Globers will not agree that natural science cannot be done with observation alone. I don't think that Globers will agree with that. And I also don't think that all flat earthers will agree with that. I think you will have some that will say it can and some that will say it can't.
Well, what is computer science?
Well, that's not here nor there.
They call it science, don't they?
I'm specifically referring to natural science in this particular case.
Just for the record, I did not tell him to say that.
Are the stars natural?
I think they are. Yes. Would you say they are?
Can you prove that the stars are natural? Because were you around when they were formed? How do you know they were?
What would be the other option if they're not natural? Supernatural? Are they supernatural?
Yeah, they could be, right? Now you're onto something.
So supernatural would be something like ghosts, witches, magic powers, those kind of things.
Maybe stars.
So you're saying, I mean, the problem with that is that if that's the case, what's the point of doing any observation of the heavens at all? Because the thing is, magic, I mean, I guess, does it have certain rules it has to follow? I mean, that's the question is, if they're supernatural, then what are the rules? Because they need to have rules. I mean, we use the stars for certain things, celestial navigation, obviously. The seasons are sort of star related. The moon, different phases of the moon. Those are kind of
how about people's personalities? People's personalities and characteristics can be based on the alignment of the stars in conjunction of certain stars. It's every minute of the day that they're different. And would you call that natural science or supernatural?
That is definitely, I would say that would be pseudoscience. What do you think that is?
Well, it's still a part of science, isn't it? Yeah, pseudoscience, you're getting that word wrong. Pseudoscience means you're not doing the science correctly, how it's supposed to be done.
So, okay, what does that mean in terms of...
It means if you're doing an experiment on the stars and all you do is spectroscopy and nothing else, then that's pseudoscience.
But that's not all you're doing. First of all, you're observing the different well, he left. Never mind. But going back to what I was saying about the whole, none of the Globers are going to agree that natural science excludes observation. And I think that's what Jeremy says. If you don't have scientific experiment and the method, you don't have natural science, which that interpretation would exclude observation.
You don't have science, period. Yo, if you didn't follow the scientific method, you don't have science. You got pseudoscience. So, you know how we know that?
Okay, how?
Do you know how we know that?
I don't know how.
Because have you ever checked the definition of pseudoscience?
We just went over that, yes.
Okay, and do you believe that it's true or?
No, tell me, what is the definition?
It's when you do something not in line with the scientific method.
Okay, so if you don't have the scientific method, you don't have science. Does that exclude observations?
Yep. You definitely have to have an observation to do natural science. Yep.
Right. But if you only have observations and nothing else, do you have natural science?
So you don't, because extremists. So when Richard Feynman says, you observe something, pretty much you take a guess. You come up with this nice theory or prediction, but then he says if it doesn't agree with experiments, it is wrong. So then after that he says, and that simple statement is the key to science.
Okay, so if I'm making an observation and I'm, going back to this whole mating habit in what we're doing, what with this disagrees with experiments? Does it agree, disagree, or really have no relevance to experiments? Does it disagree with experiments?
Do you have an experiment?
I do not. All I have is an observation.
Well, then what are we talking about?
The mating habits of the bird. Does it disagree with experiment?
You did a little piece of science. You didn't follow through with the whole thing. You haven't done it yet. You haven't done the whole thing yet because you need to do the whole scientific method to have some science.
But all I've done is observation. That's all I'm going to do. Not going to do an experiment. I'm only going to do observation.
Then you're never going to do the scientific method, and you're not going to have any science in that.
Okay, that's fine. So if I'm only going to do that, hold on. If I'm only going to do these observations, does that disagree with experiments based on what he just said about Richard Feynman?
Yeah, you have to. If you don't have any experiments, then you don't have the key to science, which is experimentation.
Okay, that's fine. So going back to what I said earlier, I am going to say that most Globers, I'm not going to say all, most will disagree with this and say that observations by themselves can be science. And also, based on what I just heard a few minutes ago, I think that guy was a flat earther. I don't know. I also think
Richard Feynman
flat earthers will disagree with that position as well.
Well, I mean, if you guys don't want to, if you guys think the definition of pseudoscience is wrong, whatever.
Not the definition, the interpretation. There's a difference.
I mean, I thought we just agreed on it. You just agreed with me like a minute ago that, yes, if you don't follow the scientific method, you don't have science.
But
did you not just agree with that?
I don't agree that that's the only way to have science. I don't agree with that statement.
No, we're talking about the definition of pseudoscience.
Then I disagree with it.
Well, I mean, maybe somebody can pull it off. I'm a little busy right now, but
I disagree with the assertion that the only way to have science is to follow the scientific method with experiments. I think you can have observations by themselves, draw conclusions based on those observations, and that would constitute science or natural science.
I think you'd have like a study or something. Maybe at best, you'd have a study or.
Yeah, pseudoscience, a collection of beliefs or practices mistakenly regarded as being based on scientific method.
Yeah, there we go. That's fucking perfect right there.
So now these observations that I have done, I haven't done an experiment. I haven't formulated a hypothesis yet. So all I've done is the observation and drawn some conclusions. So I have not followed the scientific method. Is that pseudoscience?
Sorry, what was that? I thought Elbow had this. What's up?
I've made some observations, drawn some conclusions based on those observations. I have not conducted any experiments. I don't have any variables. I have not followed the scientific method. Have I done science?
I mean, I could give you another quick quote from Richard Feynman, right? So, I mean, you're saying you made a conclusion, so you made a theory. So it says, it doesn't matter how beautiful your theory is. It doesn't matter how smart you are. If it doesn't agree with experiment, it's wrong.
I don't have a theory. All I'm doing is looking at the data, drawing some conclusions. I don't have a theory in terms of, I didn't make an idea or a theory beforehand. I'm drawing a conclusion from the data.
From your observation, are you claiming it is science?
I am claiming it is science.
And then it's called pseudoscience, because if you don't have an experiment.
Okay. See, and again, I think I've already said this 3 times.
Yeah, you did.
Globers will not agree with that. And I also I think there are some flat earthers that will disagree with that.
I mean, Richard Feynman was a glober, and he disagrees with you.
But no, I think you're misinterpreting what I think. If you flat out asked him, you can't really do it. I think if you flat out asked him, can you do observations and not have any experiment and just do an observation? I think he will absolutely say,
yeah, you can do that, but he calls that poetry.
It's only the small select group of anti-flat earthers that disagree with this shit.
I actually disagree with that. I think every single glober will say that if you have observations and draw a conclusion from that without an experiment, I think every glober, anti-flat earther, all of them, I don't know, you have to take a poll, I think most, if not all, will say that is science.
Yeah, your whole crew of anti-flat earthers is going to say, whatever, it's not science or whatever. Or it is science, whatever. We know. That's what I've been saying.
So the entire point of all of this is a fundamental disagreement on the nature of science. I think that is part of my whole thing right here is there's a fundamental disagreement between the two sides on what not, you can talk about definitions and all that stuff, all you want. There is a fundamental difference on what science truly means.
There's a fundamental difference, Jeremy. Hold on, Jeremy. There's a fundamental difference of what you think something is scientific or not.
It's only you guys that disagree with this. Like I don't even care anymore. You're the only people that disagree with this. Your own people, the real science people, they disagree with you. Where do you think we got this from?
I'm pretty sure if you survey actual scientists in the field, they will say you can have observations without science. Sorry, you can have observations without experiments, and that is science. I'm 99% sure.
I just gave you a physicist, which is called Richard Feynman.
And I said, if you specifically ask him, now you can interpret all what he just said all you want. If you specifically ask him this question, can you have experiments? Sorry, let me rephrase it. Can you have observations and not an experiment and call that science? If you specifically ask him that question, word for word, he will say absolutely.
No, you can't say that. No, let's not start speaking for Richard Feynman.
He will say that. He will say that. Now you can interpret all what you just said and read and all that stuff as you want.
Stop.
Can I jump in and
thoughts, please?
Can I just ask something? You see, one of the fundamental natural laws is hot always goes to cold, yeah? Everybody agrees that, yeah? That's just an observation. But yet it's a natural law.
Yeah, it's a law because you can't, it always happens and you can't experiment on it. So you'll never know the cause of it. That's why it's a law.
Yeah.
The theories you can experiment on and we know the cause of.
Yeah, but is natural law not still part of science?
Did you follow the scientific method?
This is what I'm asking you. Is the law that hot always goes to cold, which is always observed, and is that part of science? Or are you saying now? Are you saying now that hot always goes to cold, which can't be refuted? Is that now pseudoscience? Is that what you're telling me?
If you were to come at me and say, "Oh, we got the second law of thermodynamics right here. This is science," and I'd ask you where the experiment was, right off the jump, to find the cause of that effect. That's why they're called laws, because we don't know the causes of the effects. If we knew the cause of the effects, it'd be a theory.
So it's not science then.
Do you have an experiment where you found out the cause of the effect?
Personally, no, I don't.
No, then no.
So hot going to cold, as a natural law, it doesn't come under the umbrella of science.
No, in fact, if you went at somebody with that and told them you had science, and then they asked for the experiment and you didn't have one, they would be rightful to say you have pseudoscience there. Yeah, I didn't make the shit up. It's a definition of pseudoscience. Elbow read it out a second ago. You don't follow the scientific method, you got pseudoscience.
Okay, hold on. Okay,
I thought pseudoscience was someone trying to do science and claiming that it is science.
Yeah, it's when pseudoscience is when you claim to have science, but you don't follow the scientific method. That's what it is.
I propose this experiment, Jeremy. I propose this experiment. Now, science is a science, whatever. I propose that I look for some actual scientists, various professions, chemists, biologists, physicists, whatever, and I email them the question, can I have observations only and not an experiment, and will that still be considered science? I will ask these scientists that question, and I would like to see the answer. What do you think about that? What do you think their answer would be? Do you know? And second of all, if they come back and say that if you can only have experiments to be considered science and not observations only, I will concede I am wrong. But if I do this and these scientists come back and say you can have observations only and not have an experiment, and that will still be considered science, would you concede that you are wrong?
No, I don't live by my life on appeal to consensus fallacies. Thank you, though.
So basically, you're saying there's no way to convince you you're wrong.
This might be a different fallacy, actually. Hold on.
Basically, you can say it's an appeal to all. We have people that are actual scientists. They are experts in their field. They should know what science is. Don't you agree?
Hold on. Before you go any further, right? You say that it must follow the scientific method. Which scientific method are you talking about?
Now, I'm going to repeat my question because my question does not...
Are you talking about hypotheoretic deductive method? Are you talking about, I don't know, the inductive deductive method? Are you talking about the analytic synthetic method? Well, I mean, which scientific method are you deeming to be the master of all scientific methods?
To be clear, this question I'm asking
talking about
did
I
not
can't
mention
handle both of you
scientific
guys at
method.
once, man.
This question I'm asking. Do what?
I've been listening for half an hour here, or more, probably more, an hour. One of the problems I think we all face is that the semantics of science, or the terminology of science and scientific method and all the rest of it, is very happily weaponized by both sides of any argument. Okay, both sides will, one side will claim an absoluteness that's not justified because, as we've said, you can't go and touch a star and experiment with it. And the other side of the argument will hand wave away some information that's possibly, you know, real and genuine and useful because it doesn't strictly follow the scientific method. So that weaponization for the sake of
Hold on, I've never denied that we get some awesome information from this other stuff, from these studies and this other stuff that they're.
I know, man. I know. I just let me have a 30-second monologue and then I'll finish. This is my opinion. Is it? You've got the word science. See, to me, if some guy sits in a tree and watches blue-bellied woodpeckers for 5 years and then comes up with all this information about their mating patterns and whatever, for me, I don't have a better term for it than it's some sort of science, right? But at the same time, I get what you're saying, Jeremy. It's not scientific method. It hasn't proven anything. It's not cause and effect, whatever. To me, the word in inverted commas, science, is nuanced. And if everybody can recognize that it is nuanced and there are degrees of absoluteness to what's put forward as science, and some of it's a bit rubbery and some of it's a lot more solid because it has been, you know, validated through experimentation or whatever. I just think a lot of the shit could disappear from a lot of the discussions because, some of it's scientific method and some of it isn't. But how do you, like, bird watching and paleontology and computer technology? I mean, unless the English language is going to come up with a different word to insert in place of science, you're never going to get away from this. It's just going to be constant butting of heads that really doesn't serve much purpose. Thanks for listening.
All right. So I posted a few things, Shermis's, right? Which one is it says the scientific method distinguishes science from other forms of explanation because of its requirements of systematic experimentation. Right. The final arbiter of truth is science. It's experiment. Right. So that's another one from Lawrence Lewars. And then the only way things change in physics is experiments. Everything is based on experiment. That's the only way we change our minds.
I'm not arguing all of that. What I'm arguing is, I mean, all of that is fine. I don't have a problem with any of that stuff. My argument is specifically that science can be observation only and not experiment.
Well,
science.
The first one I quoted was the scientific method distinguishes science from other forms of explanation because of its requirements of systematic experimentation. So, in other words, if it isn't going through the scientific method, I mean, and you're calling it science, you're saying this is based on the scientific method because it has observation, then you're doing pseudoscience because you're regarding it as being science because of the scientific method, which you're saying only this observation part. You're using only the observation part, and pseudoscience says is regarded as being used as a scientific method. Then it's just called pseudoscience, bud.
Okay. So I'm going to propose to you the same experience.
Hold on, because he's saying it must follow the scientific method. Now, I asked a couple of minutes ago, which scientific method are you putting down as the one that must be followed? Because there is different types of scientific method. Now, I'm sure there's some of them out there that only require constant observations.
Can you give me different scientific method?
I rang off 3 earlier, but yeah, I'll give you 3 that I came up with. There's analytic synthetic method. There's inductive deductive method. Yeah. There's a hypothalatic deductive method.
Are those scientific methods?
There is the historical logical method. There's a genetic method. Do you want me to keep going? These are all scientifically approved scientific methods.
Can you show me those, please?
Yeah, there's an analogical method.
Yeah, can you show me those,
which
please?
Is relationships or consequences. There's the modeling method. The systematic functional method.
That's a different method. It's not the scientific method, is it?
Right. So these are not scientific methods, then, no?
No, the scientific method is the scientific method. There is not called the astrological method or the justification method.
Right. So all these scientific methods that people use in different branches of science, yeah, like one of them, the analytic synthetic method, which biologists and chemists use. Yeah, you're telling me that now biologists and chemists are now pseudoscientists because they're not following your definition of the scientific method.
I'm sorry. Can you show me a biology? A chemistry that doesn't follow the scientific method?
Can I show? You're asking me to show you a chemist or a biologist that doesn't use the scientific method. Why are you asking me that?
Because you're saying that they don't. You're saying that
no, you're saying they don't. I'm saying they do, and the scientific method they use, because it's not one you've approved, therefore they're pseudoscientists. Because it's not the scientific method that you claim to be the master scientific method that everyone must follow. Yeah?
So it's the scientific method, how chemists think. Make an observation, formulate a hypothesis, test a hypothesis through experimentation. Nah, I'm sorry. Can you tell me what other scientific method does the chemists use? You're saying that there are different scientific methods, and you're naming all different other types of method, not the scientific method. But I'm telling you, you're saying that chemists use different type of scientific method, and they don't. They use the same scientific method.
I'm saying that all these scientists use different versions of the scientific method. Yeah.
Do they?
And you're saying, no, there's only one fucking scientific method, and if you don't follow
what version does do chemists use that is different from any scientific method?
Well, a chemist wouldn't use historical and logical method, would they?
They would use the scientific method, which is they make an observation, they formulate a hypothesis, they test the hypothesis, and they either accept or modify the hypothesis to test another different cause or effect for the effect.
Right. So what you're saying is that the method that you just read out, if anyone deviates from that whatsoever, then it's not the scientific method.
When did I say that? I said if you're basing that just an observation and don't do the rest, which is test your observation or test your hypothesis, then you don't have an experiment, which is testing, which is the key to science. Just an observation, and writing what you believe is happening with something is not science.
Right. So if it deviates from what you said, then it's not science, yeah?
No, just having an observation is not science.
Right, but you just reiterated what you said the scientific method is.
Right.
Yeah. So if it's different from what you've just said, then it's
That's
not
not what
science. Yeah.
it's not what I said. It's what
Right. So why are you now saying that why did you say a couple of minutes ago when I read out that 4, 5, or 6 different versions of the scientific method, you said no, they're not the scientific method. The scientific method is this.
You just said they're different. You just named out different methods. You didn't name out the scientific methods. You said
they are scientific methods. They are just different versions of it.
Can you cite that? And don't just read them out. Cite them for me. And again, and this is from Rochester.edu, the scientific method distinguishes science from any other form of explanation because of its requirement of systematic experimentation.
Okay, so I proposed an idea earlier to Jeremy that I would find some different science professionals in different fields, biology, chemistry, physics, and I would email them the specific question: if I have observation only and not an experiment, do I have science? I would email them that very specific question and see what answers I get.
Well, here's one answer.
Well, I mean, the other gentleman said a minute ago that if he knew a guy that studied birds for 10, 15 years and knows all the information about their migration, their mating habits, their feeding habits, everything there is to know about these birds, he would say that was science. Yeah.
You have
all he did was observation. He never tested the birds in any way. He never went near them, never touched them, never created a hypothesis, nothing. But yet all he did was observe them, but that's classed as science.
Well, the definition of observational science is a field of science where controlled observations cannot be done in order to study cause and effect relationships. Scientific studies are simply done through observation of nature, taking its course and recording the findings over time.
So that is observational science, but is that natural science?
It's a branch of natural science, I think. I don't know about that.
I was going to say I proposed this question to Jeremy, and I've basically said I don't know if I'll do it or not, but let's say I did, and I got 10 or 20 or whatever, 5 answers back, and some of them, if they all said that no, you have to have experiment, that I would concede and say you are correct. And if I did 5 of them and they all came back and said no, if you have you have observation only, but not an experiment, you still have science. If they all 3 said yes, that is true, would you concede? And Jeremy said no, he would not.
I can explain to you why I think that might be the case. I guess I don't know if it's for Jeremy the case or not, but it's really simple why that wouldn't follow for him to do that. All that would mean is that there isn't a standard for the science, is what they're saying, that needs to be met. If science can simply be observation with nothing else attached to it, that's the only part of the standard, everybody, everywhere, at all times that can see things or observe things with other senses are doing science constantly, every second of their life. Everyone's a scientist. The word's now meaningless.
And I accept that is true. So, and again, I would be willing to work with it to phrase it in such a way, for instance, instead of saying, if I do an observation only and I document it and I have a particular purpose, I'm not just doing an observation for no reason. I have a purpose. And I mean, I'm willing to kind of adjust the phrasing so that we're very specific on this. That do I have science even if I don't have an experiment? So again, I've kind of, adjusted it. I have to have a purpose. I'm taking notes. I'm documenting. I'm perhaps preparing a paper or drawing some conclusions or something. I mean, there's a reason behind all this. I'm not just, oh, the sun is shining. That's an observation. Is that science? Oh, I see this bird flying. That's an observation. Is that science? I mean, I have a purpose to what I'm doing. I'm documenting it. I'm drawing conclusions, but I have not done an experiment. Have I done science? Do I have science? Again, I'm willing to kind of adjust the language. And like I said, now if I do 10 of these and get 5 yeses and 5 no's, I don't know what we can say about that. But if I get, maybe even 9 one way and 1 the other way, one way or the other, doesn't matter. If I get 9 out of 10 that say it's yes or no, then would the other side concede? And I said, yes, I would concede that you are correct. Jeremy came out and literally said, no, I don't appeal to consensus. And to be clear,
here's the thing: is that whether or not a thing is science or not, that would have to be consensus. That's the only way we can decide whether or not something. We have to agree that it's science, or agree that it's not science, or go our separate ways. There's no other way to determine what science is. Just a word that we use to describe something. It has to describe something. It's a word to describe something. So if the people come back and they indicate that standard doesn't exist, it makes the word science a worthless word that doesn't mean something. So even if you get back 5 answers that say yes, 5 answers that say no, all that would demonstrate is that there's no agreed upon standard among those people, at least, and probably more, that we don't have a standard for what science is.
I agree.
If they all say you have to have experiment, well, that shows that they agree that there's a standard. There needs to be experiment. That's at least one standard. If they all say you don't have to have experiment, that's just a lack of a standard. They're just saying that that's not one of the standards that need to be met for science. It still doesn't it doesn't tell us what science is. It just tells us for sure that they all agree what science is not, absolutely, which is needing to include an experiment.
But see, that's the whole point. The whole point of this entire idea is does science require an experiment? Yes or no? Can you have science and not have an experiment? Can I have observation only with a purpose, with documentation, and that be science? Now, the whole point of this whole thing, hold on. The whole point of what I'm trying to point out is, if I survey some actual experts, scientists, they know what they're doing, they are supposed to know what science is. We in this community, we're not scientists, most of us. Do we actually know what science consists of? I mean, we can say yes, but we're not experts. If the experts say yes or no, then should we accept their answer? If I am willing to do that.
Okay.
The question is, are you?
The thing I would want to know if you're willing to do, if they come back and they say you don't need the experiment, you just need to do what you said, which is observe, take notes, have a purpose. Is that science? And they all come back unanimously yes. Are you willing to admit then here on this show in front of everybody, anybody that does that then is automatically a scientist, and no one is allowed to tell them that they're not, honestly?
Oh, hold on. I personally think it all depends on the thing that you're observing, right? For example, right, if I sit with a notepad taking data, and I'm every single day I'm watching certain food items, right, and I'm recording, how much it deteriorates over time, and to the point eventually where it's completely gone. Right? I've got no hypothesis. I don't experiment on them. I just open the packet and put the food out. Right? and record the data to see how long it takes for it to completely rot away and disappear. Yeah. Now, some people would say, yeah, well, that is science, right? But yet, if I'm stood outside a fucking shoe shop and I'm recording how many people are putting on shoes every day, I wouldn't say that was science.
Again,
yeah, well, this seems arbitrary now, doesn't it?
What you're telling
Why don't you answer his
now,
question? Why don't you answer Bob's question, though, Extremistus? We missed you, Bob.
Again, what he specifically said. Now, what I'm saying is, if you have an experiment, you have science. No doubt about that, as long as it follows science. I don't disagree with that.
Answer Bob's question.
Hold on. What he specifically said was, if you have observation only and not science. And again, what I was specifically saying is, the observation has to have a point. You have to be collecting the data. You have to be documenting it, and there has to be a purpose to it. Then is that science? And I will say, if they all come back and say, yes, that is science, then I will say that if somebody is just, as long as they're doing that, they're doing science. If they're just making an observation without collecting data, like I said earlier, if they're just observing the sun shines, a bird flies, whatever, if they're observing that a bird flies and collecting the data on why birds fly, then yes, that is science. If they just observe a bird flying, that is not science.
Okay. Now, what I'm saying is, if you get back the responses that you say, and they agree with you that you don't need the experiment, you just need to do exactly what you just said just now, and you said you would agree that it's science, would you then also admit that anyone who engages in that is a scientist because they're doing the thing that you say qualifies as science?
And yes, if they are making observations, recording the data, analyzing the data, having a purpose to the data gathering, then they are all scientists. Then yes, that is true. If they're only making an observation without a purpose, that is not science.
So if it just so happened that the situation was someone were to get on here and say, here's the observations I made, here's the notes that I took, here's the purpose I was making the observations, here's all the data I have, and somebody else indicated that they were in any way not a scientist, or they were somehow a science denier, or that we can ignore them, you would defend them and say, no, look, they followed this thing here, and I got the news back from these other experts. This is science. He is a scientist. We should listen to what he has to say. You would do that then?
Yes. Now, to be clear, just because he's doing all this, it doesn't necessarily mean that he's drawing valid conclusions. So you can be a scientist and still do it wrong or draw the wrong conclusions or whatever, but you can still be a scientist. So, so that's clear.
I just want to make sure that
when you have a civil engineer working for the city council and they need to figure out their roading system and whether or not they need to put traffic lights, etc., they have such a thing called a helper, and all that person does is sit on the side of the road and on a hot day with a drink and a notepad, and he observes how many people in each car, all of these types of observations. But he's not a scientist; he's just a data collector, and then he passes that data on to the management, and then they will work out whether or not it's going to be useful data. That's all observation is.
See, I would agree. I would argue that he is a scientist. He is collecting data. He is writing it down.
He didn't go to school. He's not qualified. All he's doing is told to sit on the side of the road. He's like a half-wit. Like, all he knows is to do what he's told is to count the cars and how many people in each car and what color the cars were.
Okay. Just so you know, I mean, that's kind of a gray area. But the thing is, what?
I mean, because you could give the same guy instructions to do a scientific test, yeah? And now he's followed your scientific method, done the experiment, published the results, and is he still not a scientist because he's just a lackey that's followed your instructions?
Listen, extremists, just so you know, this thing Bob just got you to agree to, I do this for my job. Okay, so I'm a scientist now. You're really?
How do you do it?
I'm a scientist.
How? What data are you collecting?
Data,
what observations are you making? What conclusions are you drawing?
I write the data down. I observe things. I write the data down. I give them to my boss. She analyzes the data.
Okay, what data are you writing down?
There's a point to it. I'm writing down how much trash is in the urinals and the toilets every day.
Okay, I would say you are a scientist. I have no problem with that.
You are so deluded now.
You are recording the data. You are drawing conclusions. It has a purpose.
Yeah.
That sounds like science.
I'm a scientist.
I won't argue against you on that necessarily right now. I will say I think that you agreeing to that being qualification as a scientist, I think there's a lot of people who would disagree with you on that. I don't think they would like that the ease of access to the name of scientist. They would probably argue against you, and they would say, well, basically, they can't allow it to be that easy if they're going to continue making the arguments that they already make about people being things like science deniers. Well, if I can become a scientist, if I can be a scientist legitimately by meeting the standards that you just set, nobody here has a right to say that I'm not a scientist or that I'm somehow a science denier because I literally did the science.
So if anybody were to go out and do observations based on the how far you can see over water, write them down, collect the data, interpret the data, and present the data, I say, now the thing is, do you need a degree to be a scientist? I don't think so. I think you are. This is science. This passes as science. Now, are you a scientist? I mean, that is scientist. Are you a scientist? I mean, whatever. But that is science.
I'm not arguing against you. All I'm pointing out is that I think there's a lot of people who would argue against you on the basis of it can't be that easy. I'm not saying that I disagree or that I'm arguing. I'm not actually getting into that part of it. I'm just letting you know that I think there's a lot of people who would argue against that, and I think the reason is because they would think that that's too simple of a process to be called a scientist.
See, it's not. I mean, the example that we were specifically using earlier involved monitoring birds' mating habits over a period of time, taking the notes, doing all of these things over a fairly long period of time. This is not particularly easy. I mean, I don't know that you can call yourself a scientist if you go out and one day monitor the birds' mating habits, take the data, draw some conclusions, and present that. That to me,
what do you call someone that does science?
Where's the dividing line? What is long enough to be science?
What do you call someone that does science?
I mean, you can call them a scientist. That's fine. I mean, I was just sort of.
Okay, cool. Oh, yeah.
I mean, that's. I mean, are you a scientist if you have a degree in science, but you don't actually do science? I don't know.
I don't know. How are we defining? I would think a scientist is someone that does science.
Defining it is what got us in trouble in the first place.
Is a scientist not someone who does science? You need to actually do science.
Yes, I think so. But again,
So
what I was just saying is
scientist degree, and I'm more qualified because I am an actual scientist in my janitorial duties than he actually is.
I mean, to me, are you a scientist? Sure. Are you doing science? Sure. Is that guy that has a physics degree, is he a scientist? Sure. Is he doing science? I don't know.
No, he's not a scientist. He's not doing any science.
Okay, well, that's whatever.
I'm more of a scientist than the guy with the master's PhD, motherfucker.
I mean, what he asked is, and that was sort of a good point in that if you're going out and collecting data and you're drawing these conclusions, making these observations, but you're not doing the experiment, it's not that, quote, easy. I mean, this is not something that you can go out and collect data for a few hours or one day or whatever. I mean, this is
I'm a scientist. I do it every day.
This is an ongoing process for some period
I do it every day. I'm a scientist. Janitor science.
Now, what is the dividing line between long enough and not long enough to be science? I mean, to me, that's sort of ambiguous. Yes.
Yeah, but I'm a scientist, though, just for the future reference. I am a scientist.
I would disagree that because I don't think you know what science is.
You just told me I'm doing science every day.
I know that. And now I've reconsidered my position.
Bro, these conversations end in some weird places with you. I gotta tell you, this is exciting.
I think my idea of science is even simpler than yours. So like with my concept, it would be even easier to obtain the title of scientist. I don't think that the word scientist holds even remotely as much prestige as people like to think that it does. Not really, not in reality. I think it's something that they've built up and puffed up in their own minds and have now like basically done things like defer to quote unquote the science, and the scientists. And they've basically created this other class of people who are observing things and taking notes and trying to come to conclusions or whatever. Like, I don't think it's anything even remotely like an extra honor to be a scientist, but I think a lot of people do.
So I don't think you heard. You may not have heard the whole point of where this all conversation started, and where it started. Well, I mean, a long time ago was that in science can you do science with an observation only and without an experiment? Is that considered science? Without doing an experiment and only doing an observation?
According to you, I'm a scientist, so I mean, I
want to know
is
what
my
his
scientific opinion going to be more valuable?
What I think. I thought we agreed on this. I thought we agreed that the guy that watched the birds for years on end was doing science.
Listen, I'm a scientist, okay? So I'm going to give my professional opinion as a scientist on this. I'm going to say, I mean, what the fuck, guys?
So we did not agree on it because he specifically said no experiment is involved, therefore it's not science. We did not agree on
that. Say that. I didn't say that.
The other guy did.
Oh, okay.
Now, my question is, what do you think? I pose that question to you. What is your answer?
I don't mind telling you. I will say, before I tell you, I have no interest in arguing what I think science is. You're not going to convince me otherwise without presenting an extremely strong, thorough argument. So, like, I don't necessarily want to get into arguing with you about it. I'll just tell you.
You ain't got that.
Right now, my current conclusion on what science is observation with purpose.
Okay. So you don't necessarily need an experiment.
I don't think that you need an experiment to do science. No, not personally. Okay. I don't think
that's fine. I mean,
but I do.
We don't really have a right or wrong answer at this point. We have differing opinions.
I do want to say I do think that the established general idea of science would require that based on what they say, other people say, authorities say, whatever the scientific method is. I don't necessarily buy that. I don't necessarily live by that or think that that's the accurate description of what science is. But as far as I know, the I guess you'd call it maybe the scientific community at large, what they would say the science is, I don't necessarily agree with that. But I think that when they refer to the scientific method, they would require an experiment to be in that. Okay. I don't.
So to be clear, and I would say that you can have, my answer is you can have observation with purpose and not have science. And I also say that is the consensus of the broader scientific community in terms of actual chemists, physicists, biologists. I think, without having
the janitors, don't forget the janitors,
you can have observation and not have science. Now, what you just said about requiring an experiment and following the scientific method, to me, that is something that specifically Jeremy has said, and somebody else basically said the same thing, that to me is something that is a flat Earth requirement and not a broader scientific.
Extremist, let me ask: Are you a scientist?
I am not.
You're not doing these observations with purpose and analyzing data at all?
That is not part of my job requirement. No.
You don't do that at all, ever, anywhere?
No. I basically just, my job requirement is technically is an engineer. Most of my job requirement is order entry, project management type of stuff. I don't take data and analyze it and draw any conclusions from it. I actually use the data that has already been given to me, and the conclusions were already drawn and the data was already given to me.
Is there anyone else that's not a scientist here? Because from the way you just defined it, I feel like there's going to be a lot of fucking scientists.
I'm not a scientist.
You don't make observations, write things down, analyze it after?
Nope.
Anyone else not a scientist?
You know,
we got two people so far that aren't scientists in here.
Are doctors, are they scientists? I mean, kind of, I guess. Lawyers? I mean, maybe. Engineers? I would actually say engineers are typically not scientists, because usually engineers, they've already, like I said, for me specifically, they've already got the data and the conclusions given to them. They have to make use of the information already given to them, as opposed to they didn't collect the data themselves. Maybe
engineers are the reason.
But generally speaking, I would say engineers don't collect it. I mean, some of them may do and some of them may not. I guess it depends on the engineer.
Engineers are the reason that we know science tells us the truth and proves reality. Because if it wasn't for engineers taking, this applied science, where they take the science that's already been done and they make shit happen in the real world, these are the people this is the reason why we know science proves things.
Right. And see, that's the whole thing is the scientists make discovery. They take the information, they draw the conclusions, and they present the laws, theories, whatever you want to say. It's the engineers that make the practical use of the conclusions that the scientists come to.
Yeah, and if science didn't prove things, these guys couldn't make it work in reality.
I mean, you're going to science proving things. That's a whole philosophical thing.
If it didn't prove things, these engineers wouldn't be able to make this shit happen in the real world, would they?
That's not necessarily true. They can make use of something and it not be proven true. I mean, take gravity, for instance. I mean, even though you don't believe in it. I mean, they do gravity experiments. They don't know, is it, the whole thing about is Einstein's GR, is that true or provably true?
All they need to know about gravity is things fall at 9.8. It doesn't matter why, if it's space-time bending or what. They just need to know what's going on.
Right. And that's sort of my point is that provably is the idea behind the space-time bending, is that true? The engineers don't necessarily need to know that. Is that proven? So they can, even whether it's true or not, is irrelevant to the engineer. They know enough. Enough about it, true or false. They know enough about it to put it to practical use.
I'll give you that one. I still think science proves things, but.
Well, you changed the subject on us, by the way, but the whole point behind science proving or not proving things.
Bro, I'm the scientist here. Listen, I'm the scientist here. I'll change the subject to anything I want.
There are always the possibility of unknown variables that will affect the truth of something. And that's why we say science doesn't prove 100%. You've heard of the whole, I think it's 6 Sigma certainty thing. Have you ever heard of that?
What is it?
The idea of 6 Sigma confidence. Have you heard of that?
The p-value in an experiment?
No.
I don't know what you're talking about.
6 Sigma. Have you heard of that? I think it's 6 Sigma.
What is that?
So it's basically there's a confidence of 99.99996 decimal places that they're right. That is 6 sigma, 6 decimal points, 5, whatever it is, 5 sigma. There's a 5 decimal point confidence, and I think it actually has to do with standard deviation and such, and not actual straight decimal point. But anyway, there's a confidence level that they will say this is true, but there's still that possibility that it's not true. And if they don't have that 5 sigma confidence level, they will not necessarily say it's true, even though they're pretty sure it's true. That actually came out. What?
I just think my word should weigh more heavily than yours because I'm the actual scientist here. Okay, and you're not.
I withdraw my support of your scientist. You're gonna let this go to your head, Jeremy. You're gonna let this go to your head, and we're never gonna hear the end of it.
Absolutely not. I am the scientist here. Okay.
Jeremy, I love how you scientifically changed the subject.
Scientists can do that, you know?
Yeah.
But by the way, did you notice that Bob Dole agreed with me? I want to point that out.
Yeah, you and Bob Dole think I'm a fucking scientist. This is awesome.
Well, no, that wasn't the point of my statement. My statement was we agree that you can have observation only and not an experiment and still have science. We both agreed on that.
Yes, I do science. I'm a scientist.
Shut up.
The janitorial sciences.
That's actually, I can see that being, is that a natural science? I guess you could say it is. After all, you deal with a lot of shit, literally and figuratively. So that's sort of a natural science.
Yeah, natural science, big time. So, moving forward, I mean, you know, we're just going to refer to me when it comes to the science stuff, seeing as how I'm the actual scientist there.
You're the final arbiter of what science is, since you're a scientist.
Yes.
We should actually find probably a bigger pool of opinions or whatever. We need a bigger pool.
I'm gonna get all my people at work, all my janitor coworkers.
I meant within this community. I mean, I know that Jace is a scientist. I think there's a few others.
Jace, let me tell you something about Jace. Jace Hood. Okay, he lives in Plato's cave. He looks at shadows of electrons and shit. All right. He's doing weird shit.
Where does he live?
Plato's cave. Do you know what he does? He looks at like shadows of electrons.
And is that not
it's
science?
Like Plato's. It's like Plato's cave, bro. He's looking at shadows.
Plato's cave. I don't know what that means. That's weird.
The allegory of the cave. What's it called? Maybe I'm not saying it right.
I don't know what that is.
You ever heard of Plato's cave?
I don't think so.
There's these people. You know, I don't want to tell. I might mess it up, but all right, I'll try it. There's these people. They were facing. They were looking at a wall, and all they could see was shadows of a wall. They didn't see anything else. All they could see was the shadows, and then one day, some guy turned around and he saw what was really going on, and he tried to tell others, and they tried to kill him. Is that how it went, or did I butcher it?
I can look it up. You didn't do a very good job.
Yeah, you might want to look that one up.
See, I tried to kind of tell you that earlier when we were discussing the whole idea of spectroscopy, and you still made me go through it.
No, dude, you had no science earlier. Unless you think the observation is science, in which case I'm the scientist and I'll be the judge of it. And I'm telling you that's not.
And we're going in circles. And in circles we go.
Just remember, I'm a scientist here. This is the places where your arguments end up at. Just these weird places.
See, you conduct science. Are you a scientist? I think that may be more of a philosophical question than a scientific question.
What would you call somebody that conducts science?
We can start calling you Jeremy the Scientist. There you go. That's a new nickname for you.
If somebody's conducting science all the time, I would call them a scientist.
Janitorial science. I like that. That's good.
Janitorial sciences.
Now, again, we asked that a minute. Is the janitorial science a branch of natural science?
The custodial sciences.
Yes. I mean, is that is it a natural? Maybe it's closer to computer science.
Kosho, you here? Listen, breaking news, bro. I'm a fucking scientist, okay? We got to figure out if Kosho's a scientist. I bet you he is.
By the way, I don't know if you're watching chat, Jeremy, but Kosho is making fun of you in text chat.
No, that's fucked up. He can't make fun of. No, he's a science denier, is what it is. Because I'm a scientist. All right, you want to start?
You want to start? Jeremy, you're a science denier, scientist denier.
You want to start denying me? You're a scientist denier.
I like that. And I do regret calling you a scientist now, yes.
I know. I knew you were gonna. This was gonna come back to bite you. Nice work, Bob. We missed you, Bob. Bob got you.
So hold on. I do have a question. So this data that you pass, I mean, you said you pass this data on, whatever data you're collecting. You pass it on to your supervisor, right? Do you?
I give it to my supervisor, yep.
And what do they do with it?
We both analyze it.
Okay, and so, I mean, do you change, I mean, so what do you do with that data? When, I mean, are you changing the number of toilets? Are you changing the procedures?
There's a lot of stuff. If there's a lot of shit in the bathroom, we might lock the door the next day, or we might post a security guard out in front of the bathroom and have them check after every time someone uses it. If there's not a lot, we might just let it go and leave it alone and nothing happens.
So, I mean, we're making fun of you, but the thing is, you're using this data. You're actually making real world changes using this data. I mean, that to me is science. You're changing your environment based on this data.
I'm a scientist. I know.
As much as you're making fun of this, I have no problem with it. Now, again, it's going to go to your head. I don't think that. I think that was a mistake.
It already has.
I mean, the thing is, you were a scientist and didn't even know it, and now that you know it, I think we're all in trouble.
Yeah, you're going to get wrecked. So suck it, Kosho.
So here you go. You're not watching the voice chat. He specifically said right here. Kosho said, I was claiming Jeremy was doing science before he even did. That's what Kosho just said.
It's too silly, bro. It's too silly.
So there you go. Kosho actually says, Kosho agrees with you and me. You are a scientist.
Okay, so now my word obviously holds more weight than your guys' since I am a scientist and you're not. Are you? How are you? What do you even know? You're not even a scientist.
Here's the problem, Jeremy. Your word only holds weight in the custodial sciences, not in the natural science.
This could be natural science. We haven't delved that deep yet.
I guess that's true. But can you translate your understanding, your experience with the custodial sciences to natural science? Are they transferable?
Listen, out of everyone here, I'm the only one that's actually doing science, so I'll be the judge of this.
Well, that doesn't seem fair.
It's not. Life's not fair.
I mean, that if you're the judge of your own, I mean, that's kind of like I'm going to referee
I
my own
obviously
game.
know more about science. I'm the one doing it every day. You don't even do it.
That seems a little bit.
You regret. You regret.
I would say if he's dealing with piss and shit every day, that's natural. That's natural science.
We agree on that.
There we go. Natural science. I'm the fucking expert here. Once again, I'm still the expert.
I would use the term expert a little bit looser.
Show. He can't even voice chat because his girl will beat his ass if he wakes her up.
I'll translate for you. Was Jeremy doing science when he experimented with his sexuality after high school?
Yes. That's an experiment, is it not?
Listen, his dad took me to Applebee's. All right, very romantic.
What, was he a priest?
He was my rabbi. Listen, he's got enough. He's got enough shit on his plate. All right, all his peoples in Manhattan are cheating every fucking Sabbath or whatever it's called.
I think you got a basis for a lawsuit there.
That little fishing line you guys hang. You think God don't know you're cheating? Come on, Kosho.
Jeremy the scientist. We need to we need to put your new chat name there. Jeremy the science expert.
I'm a professional expert specialist.
You would think as somebody as experienced in the custodial sciences, you'd know more about the Coriolis effect, flushing toilets and all.
Bro, somebody really tried to use that on me like 2 years ago, maybe. Somebody really broke that out, and that was gone for that's been gone for like 4 or 5 years now. That toilet bowl thing. Dude, there's not many people that know more about the Coriolis than me.
Yep.
I taught SC damn near everything he knows about it.
It was a short discussion, apparently.
Dude, I got DMs dating back 2 years at least with Xanax. 2+ years. All Coriolis. nothing but. I must have done at least 100 hours in the random voice chats with him.
I actually remember a lot of those. Yes.
Yeah.
I mean, hours on end.
We did Coriolis Week in here a few months ago.
I remember we had a discussion on Coriolis. I specifically asked you, is Coriolis 0 at the equator? And you actually educated. You didn't educate me. You corrected me a little bit in that it changes slightly with your change in altitude. So I actually have rephrased my statement now to say, is Coriolis the minimum at the equator and not 0 necessarily?
Yeah, because if you were to say there's no Coriolis at the equator, I just tell you you're wrong. It's wrong.
Yes, we had that discussion, and while I did concede the point that it does change slightly with altitude, if you're changing altitude. Now, if you stay the same altitude, it is actually technically 0. But if you're changing altitude, it does change slightly. So I've rephrased, whenever I ask that question, I rephrase it to ask, is Coriolis a minimum at the equator and maximum at the pole?
You should just say it with keeping the same altitude because that makes more sense.
I mean, you can, but then, I mean, people always talking about planes falling and changing out. And it's just, balloons, do they change altitude? Do they not? They're moving, whatever. It's just easier to specifically say minimum at the equator, maximum at the poles.
You've also got another problem, though, with the Yutvos effect. And Zanuck claims that's the Coriolis effect, but a different type. So that's also another issue.
I mean, it's a different type of Coriolis, yes.
Yeah. There's this. I mean, do you have a different amount of Yeltsin effect at the equator than somewhere else?
I think it's the other way around. The Odysee effect is actually greatest at the equator and smallest at the poles.
So see, there you go.
By the way, I think
better get so hyper specific when you start asking this question.
Is Montreal here? Are you here, SC?
You better start getting hyper fucking specific when you ask this. He's not here because I just tried to diss him and he didn't respond. So
I'm driving. I'll be home soon.
remember how I taught you everything you know about Coriolis effect?
Well, I was going to point out, if you taught him everything he knows, I was going to actually demonstrate that I don't think he knows as much as you think he does.
I didn't. That was a joke. I didn't teach him everything.
Oh, you didn't? So you left out some things. Is that what you're saying? You did.
We've had disagreements on it.
Okay.
I'm not saying Coriolis does or doesn't exist, but does anybody have any actual definitive validation that it does exist, other than there's these claims of bullets and things like that? Is there any actual this is it for sure definitive that it actually does exist?
There are typically, I would say, 3 examples, if you want to say. Bullets, and actually Zanuck, I don't have it, but he has specifically posted one of those military documentation things that shows the correction for Coriolis. The hurricanes are supposedly affected by Coriolis, whether you think that's true or not. And then, of course, there's the Foucault pendulum. Now, as far as any other demonstration, I can't even imagine what else would be on a scale that you would see it. Those 3 things, I mean, again, bullets barely show it at only at 1,000 or plus yards, typically. The whole Coriolis with the Foucault pendulum is, I mean, it's perceptible, but it's not huge. I mean, you have to sit there and watch it process for an hour or whatever period of time. And then like I said, the artillery documentation, I mean, it's a pretty small amount over a fairly large distance. So I can't imagine much else that would really show it. I mean, the whole thing about Coriolis on planes and on helicopters, I mean, it just wouldn't be visible on those things.
Hey, what's up, brothers? What's up, extremists?
Hello.
I'm glad to see that you've accepted all the experimentation you've done as making you a scientist. I just wanted to real quick, I've said this before, and no one in here is going to like it, not even the Globers, but
I already like it.
Well, there you go. I'll tell you this, though. If we could tonight, if we were in opportune locations, observe the International Space Station, or whatever you want to call that object as it's orbiting, or whatever you want to say it's doing, and we could, without looking at what it's going to be doing, we could predict accurately the path it's going to be taking, and we can, confirm that by people observing it, simply by using the Great Circle route that it would be continuing, and then adding in Coriolis of the Earth's, given the Earth size and rotational speed. So I think that would confirm really both things in one fell swoop. Coriolis and the globe, that is.
Do you still like it, Geo?
I was going to say, I take it back. No, I don't like it anymore.
I thought that might be the case. Yes. Wait, so why will the Globers not like that? Because I liked it.
Oh, well, I don't know. Because it usually anything to do with satellites is not going to sway anybody.
I thought it was pretty good. But let's ask Jeremy. He's the scientist here.
Oh, that's true. Yeah, go ahead, Jeremy. PH Dick.
Okay, what was the science question you had for the scientist?
Jesus Christ. We were wanting to confirm Coriolis, as Geo had asked. He asked for a demonstration of Coriolis confirmed. And I suggested if you had enough people in opportune locations tonight, you could observe the ISS let's say from 2 positions, estimate its speed and path, and predict where it's going to be anytime in the future for the next couple of hours at least, using only the speed that you saw it traveling, assuming that it's going to continue a great circle route that it seemed to be trekking, and or after you correct for Coriolis. So you make a great circle route, correct for Coriolis, and use that to predict its path and confirm it by taking later observations.
So you got to have a map with distances on it and shit, right?
You need to use a map for this.
We don't need a map?
We actually don't need to use a map. So no, we won't need a map.
So all right, we're 2 people standing on the ground. You're somewhere, I'm somewhere else. We don't know where we are because there's no map.
No.
Okay, now what?
No, that's it's important that you know where you are.
So no, we don't. There's no map. We don't have no idea where we are because we don't have a map.
Let's say we all have
no map.
Let's say we all have GPS receivers that give us our positions. How about that?
A GPS receiver that gives you your positions.
Yeah, we'll simply use that to predict
on the map
position of the ISS at some point in the future.
Your position on the map.
All the information I gave.
Where's it giving us our positions at?
Well, wherever we are, it's going to say longitude.
Where are we? I don't know. There's no map.
Yeah, okay.
I don't even know where we are. We're just 2 goofballs standing on the ground somewhere, looking at the sky, holding hands.
You fixate on. I mean, I tell you, dude.
Jeremy, the scientist, is being an asshole.
Yeah, bro, I don't know. You got me doing this thing, and I don't even know where I'm standing at because there's no map. This isn't scientific at all.
Dude. You're like the Columbo of scientists.
Oh, you want to do some science, and in the meantime, we don't have a map, and we don't even know where we are.
I'll tell you what. We're going to exclude any of the people who don't know where they are in our test. Okay.
All right, where are you? Point on the map to where we are.
We will accept actual names and locations, or even longitude and latitude positions.
Okay, cool. Point at the map. Show me where we are. Make an X on it. Are you going to put a little X's on the map for where your observers are?
Do me a favor, dude. I'd like to see your credentials. Okay.
Extremis, this is my credentials. Tell them I'm a scientist again.
Jeremy, the asshole scientist.
Yeah. That makes sense, dude, considering all the experimentation you've done.
Bro, listen, the thing Geo wants, you gotta show it from both the inertial and the non-inertial reference frame, right? So like when there's a guy throwing a ball in a roundabout, we can get in both the inertial and the non-inertial reference frames with cameras, record exactly what happens. We can say, oh, look, it went straight in this one. It didn't go straight in this one. We know that it didn't actually go straight and that this is the only way Coriolis can happen. All right?
Really? Is that necessary? Okay.
I mean, that would be one definitive way on how to show that, yes, there is actual Coriolis. Because if you're all just standing on the roundabout and there's some deviation, you might be like, I don't know, is the wind blowing? Is it some kind of force we don't know about? Is it ether drift? Like, shout out to Lemon.
All right.
I mean, who knows? It could be a ton of things, right? But if you see that difference where in one reference frame it's deviating, another it's not, you can be like, oh, well, that's obviously not actual deviation, so we're good. Coriolis.
Listen, ass eyes, I get it. And I already have an answer. So, an example, actually. That does seem like a very ridiculous request, and I don't think it should be honored. However, I can honor it, so I'm going to. Yeah, so there's actually an observation of the moon passing in front of the Earth from 4 times the distance of the moon. And from this vantage point, it's actually free of Earth's rotation. Okay, so it's not observing it from Earth's reference frame, rotating frame, right? However, the moon is passing right in front of it. Now, I wonder how hard it would be to find somebody observing the moon at that same time. If that exists, you will see that from that person's on the Earth, the moon's taking one path in the sky, but from the vantage point of that inertial reference frame, the moon was simply taking a straight path. Any questions?
Yeah, so many. What do we have the Coriolis effect here?
Absolutely.
So we're observing it on Earth, and it apparently deviates.
Well,
but it's not actually deviating.
It takes a straight path from that the video or the several images or whatever of the moon passing in front of the Earth. It seems to be passing in a straight line in front of it, and we know that it's not exactly a straight line, but for that time period, from that vantage point, it appeared to be going in a straight path. But I assure you, anyone on Earth, especially people who were where the moon was high in the sky during that time, it was not taking a straight path. So, yeah.
So the moon's path changes depending on where we're looking at it.
Yeah, that's actually defines what Coriolis is. It's observing the deviation or the path an object takes due to you observing it on a rotating frame.
All right, where is this observation points at? One of them's on Earth, another one's where?
A million times the distance to the moon. I'm sorry, it's 4 times the distance to the moon. So the L1, I think.
So it's like 1 million miles out.
Yeah, about 1 million miles. Yeah, give or take.
Okay, how do we just get there just to make sure these people are showing us the right thing?
I'm not sure. I think hitchhike. I don't know.
All right, let me know when you're ready to go. I'll go with you.
Okay, it's dinner time for me, so
maybe after dinner. Just so we make sure, like, this shit's got to be repeatable, right? We're not going to just trust these people willy nilly. That wouldn't be good science. That's not how I do science. That's not how I would do science, and I'm the scientist here. So
we're talking about Nazis, though, dude. You don't trust Nazis?
Who?
Nazis, Werner von Braun. You never heard of that?
Yeah. Well, I mean, you don't want to get into that. These guys were. What was the one guy's name? He was obsessed with sex magic. I mean, these were some weirdos.
Have you ever done sex magic?
I don't know, but I am looking. It sounds interesting.
Yeah,
just from the name of it.
Scientist.
Kosho, may I ask you a couple questions, sir?
I wouldn't mind that, but I actually my wife called me to dinner, so I'll get it.
Okay, what the wife takes precedence over me. That's for sure.
Oh, it's the wife now.
I mean Jeremy's wife. Sorry.
That was quick. What did you just go to Vegas last weekend or what? Get married?
Well, a minute ago it was his friend when Blaze was here. Your demeanor switched so fast that night, dude. You're shameless.
So did Kosho say girlfriend and then wife? Is that what he said? I missed it.
It was just something for another night.
It's gone from roommate to friend to girlfriend to wife.
Okay. I like to know
like 2 days
because I remember Ruhev talking a few months ago, and he was in a different server, and he said he had to go pick his daughter up, and about 5 minutes later he said he had to go pick his daughters up, and then he left, and he was back within 10 minutes back onto the server. And I found it interesting that he had one daughter, then he had two, then he had to go pick them up, and then he was back within 10 minutes of picking his daughters up. So I just found it really interesting how maybe perhaps some stories can change. Because Ruhev said he had a really great 6-figure derivative job in Australia. And I love how, when you tell the truth, you don't have to worry about lying. But when you're lying, you have to worry about what you said before, because you got to have a lie to cover up a lie. And so I like to hear people, are they consistent in what they're saying? But I would love to ask Kosho some questions. I have him in my head now. If he's going to go away to be with his girlfriend, wife, friend, or whatever, I need to write him down so I can remember to ask him when he comes back. Thanks. I think Kosho is going to be my new friend, my new Glober friend. I got Matthew, the Glober friend. Kosho will be my second Glober friend.
Is Jeremy the scientist one of your flat earther friends?
All flat earthers are my friends. All of them are. Anybody who's seen the light, even if they haven't seen the tiny invisible microbe life yet, sorry, Geo, are my friends. Kosho, are you here for like another 5 minutes? Or is he already gone? He's gone. Okay. Oh, there he is. Kosho, you still here? I like to ask Kosho when there's 6,500 satellites in space or more, and you say pictures of satellite in Google, you get a cartoon, and you don't get an actual picture. And I want to know why. The ISS just appeared one day, even though we were told it was constructed in outer space at 17,500 miles per hour. I want to know why we don't have any pictures of it being constructed. It just was not there, and then all of a sudden it was there. It's just like the moon landers in 11, 12, 14, 15, 16, 17 Apollo, that they were supposedly under the moon lander, and then all of a sudden they appeared, being ready to rock and roll on the moon, and they didn't show them being brought out and unfolded or whatever they did. They never showed us that, and I find that fascinating. And then I want to know why Felix Baumgartner, who went up 127,854 feet, when he came back down, that he basically came back down within miles of where he went up, but according to the Coriolis, he should have landed in the Pacific Ocean. So I just want to know these things because I'm a stupid flurf, and glow people on social media, on Discord, TikTok, Twitter, Facebook, Instagram have all the answers, and I'm just a stupid flurf. That's what I like to know.
How much should he have moved because of Coriolis? How much should he have turned or rotated?
Approximately 1,600 miles.
How did you figure that out?
He was up there 2 hours.
So 2 hours. How? I mean, what does that mean?
In planet New Mexico, he's not moving at 1,039 miles per hour at the equator. He's moving at approximately 800. Because up in Oregon, they're told at the 40th parallel north, they're moving at about 700 miles per hour with Coriolis. So it's about 800 miles in New Mexico.
So basically 2 hours times the Earth is rotating 750 miles an hour or 800 or whatever.
800. So that's 1,600 miles, and he should have landed in the Pacific Ocean.
So you think that's how Coriolis works? It's just your time aloft times the speed of the rotation. That's Coriolis.
How do you think Coriolis works?
Okay. I'm going to ask you. I don't think you were here for this earlier.
How do you think?
I'm going to ask you. Hold on.
I'm a stupid flurf. How does Coriolis work?
It does not work that way. So hold on. I'm going to ask you, and I'm going to ask you another question.
No, go ahead and school me.
This is part of that explanation. So we talked about this a few minutes ago, and Jeremy and I had this discussion specifically earlier, that at the equator, Coriolis is actually at the minimum value. And at the poles, Coriolis is at the greatest value. Would you agree with that statement?
I've always heard it's 1,039 miles per hour at the equator and basically 0 at the North Pole. School me.
That is the rotation. You are correct. But that is not what my question was. My question was...
Hey, school me. Hey, you know the answer. School me.
Hold on. I'm going to tell you the answer, but I want to ask you the question again.
No, don't ask me. Just tell me.
The answer is Coriolis is minimum almost 0 at the equator, and it's the maximum I don't know. It's not a miles per hour. It's actually a force. So it's actually measured in Newton. But that force is greatest at the poles. That's what Coriolis is. It's a force greatest at the poles, minimum, not quite zero. If you stay the same altitude, it's actually zero. But if you change altitude, it's a very slight change. So if you're at the equator, Coriolis is actually basically zero.
Who's your expert subject matter on that?
Find a Coriolis calculator and look it up. Every Coriolis calculator you will use, if you put in the equator, it will say it's zero.
Who's the astrophysicist?
Okay.
Who's the subject?
Okay.
On that.
So why? Here's the question.
I don't want to Google something. I want to know a professor or an astrophysicist that will back up just what you said.
I'm going to say a weatherman, but even then, here's the thing: is that
I want a subject matter expert. You got one?
So if I give you a calculator,
it's not rocket science.
So here's why. I'll actually tell you why that is the case.
Yes, school me. Go ahead, school me.
The reason that Coriolis is zero, pretty much at the equator, is because it has to do with the conservation of angular momentum. Okay. Now,
who's your subject? Who's your expert on that? Who can I get hold of and ask them and for them to confirm that? What astrophysicist or physicist can I get hold of to get that?
I don't actually know that the astrophysicists would say that.
So you read it on Google? You read it on Google?
Actually, Wikipedia, but actually, it's weathermen would actually be more likely to use the Coriolis.
Can you give me a name? Can you give me a name that I can actually go to Facebook?
Where are you from?
Is there anybody?
Tell you what, I'll tell you how to look up your local weather channel. Find the weatherman for your local weather channel and send an email to them. They will tell you that.
And these are the people that told me in South Bend, Indiana, Tom Coombs, ABC 57, that he went and saw that it was a mirage, that Chicago was actually over the curve, over the bend, but because of bendy light, we could see all of Chicago as if we were on a level plane. Is that the type of media you get hold of? Is that what you want me to get hold of?
Yes. Okay.
Okay.
As a backup to that,
okay, good.
We will let Jeremy, he's on your side. We will let Jeremy explain to you that what I said about Coriolis, it's the minimum at the equator and maximum at the poles. Somebody from your own side can tell you that I'm correct on that. Would that be acceptable?
Jeremy, the scientist here. What do you need?
Yes. Jeremy, we are having a discussion on Coriolis all of a sudden.
Please,
okay. Now he says that the Felix Baumgartner, when he jumped from New Mexico-ish, he was in the air for 2 hours. The Earth rotates at 750 to 800 miles an hour. He should be 2 hours. He should be 1,600 miles off because of Coriolis and Earth rotation.
Uh-huh. Because of your Earth rotation or your Earth spin, exactly.
Okay. Now, because of Coriolis, I said that that's not how it's calculated. Coriolis is actually a force, and it's a small force, and it's actually greatest at the equator. Greatest at the pole, and zero-ish, close to zero, at the equator. Even though the rotation at the equator is 1,000 miles an hour, Coriolis is actually smallest at the equator.
So you're telling me
Jeremy.
So you're telling me freedom is slavery? Is that what you're telling me?
No, what I'm asking Jeremy is to confirm that I am correct on that. Somebody from your own side. You will obviously not accept my explanation.
So if Baumgartner goes up for 2 hours, the Earth isn't moving underneath him. Is that what you're saying?
I didn't say that. No. This is specifically for Coriolis. It is greatest at the poles, least at the equator. It is a force, and Jeremy will back me up on that. Will you back me up on that, Jeremy?
So if Baumgartner goes up for 2 hours and the Earth is spinning 800 miles underneath him. Coriolis doesn't take into effect that it's spinning underneath him. I should just ignore that, even though we're told that around New Mexico it's spinning at 800 miles per hour, and that if he goes up and he's not spinning, but the Earth is spinning, when he comes down, he should basically come down to where he started at, which he basically did, and not end up in the Pacific Ocean. Is that what you're telling me?
Jeremy,
you do know. Hold on. You do know when if he is in orbit, he is rotating around the Earth with the Earth's rotation.
Hold on, Highlander. Hold on. He's obviously not going to accept our answer for this. Let's let Jeremy, the scientist, explain to him on this.
Hold on. In the globe model.
Why is Jeremy the scientist? May I ask that? Why is Jeremy the scientist?
Oh, tell him why I'm a scientist.
Because Jeremy collects data, he does observations, he has a purpose for this data, he collects the data, analyzes it, passes it to his supervisor, and they make changes in his environment based on this data. But there is not any experiments performed. Therefore, we have determined that Jeremy is a scientist.
So I'm told at the equator it moves at 1,039 miles per hour, and I'm told at New Mexico about 800. I'm told at at 40th parallel north, around Oregon, it's 700 miles per hour north. So when Bumgarner goes up, spends a couple hours up there, we're told that the Earth is spinning with the air, and so obviously he's going to come down right or close to where he went up, or there's something else going on, and Jeremy and yourself, they're going to school me. Is that what you're going to do?
But the other problem you have is you're talking about Earth's rotation in miles per hour.
He's not Highlander. Stop.
We don't measure. No, because that's stupid. We don't measure rotation in miles per hour.
He is not going to listen to you or me or any other glober. Don't even try. Let's have Jeremy try. Somebody from his own side.
So the whole idea of the helicopter. So the whole idea of the helicopter.
Hold on, you guys talk. I mean, okay, I understand. Extremis, you had an objection, but Highlander deserves to have his time to speak. Go ahead, Highlander.
No, I was just saying, you shouldn't be measuring rotation in miles per hour. Yeah? I mean, you don't put your foot down in your car, and your car tells you how many miles per hour your engine is revving at.
That's a non sequitur, but go ahead.
Every rotational body has a tangential speed and an angular velocity. You can measure them however you wanted to. You could say for the Earth, it's 1,000 miles an hour at the equator, or 15 degrees per hour. Both of those are true. They absolutely do it like that. I mean, in your model, of course. That is how it's done.
Yeah, I just want to know.
Hold on. Did you not hear me talking, bro? Twice you did that. Did you not hear me talking?
Sorry, SE.
No problem, bro. Highlander, if I may, 2 questions. Do you think that the Bob Gardner was in orbit? Number 1, do you think that was in orbit? Because I heard you say orbit.
Yeah, that was weird.
Okay.
What did he say?
Okay, maybe he wasn't in an actual orbit.
You got yourself into this, Highlander. You get yourself out.
All right, no problem. I accept that. I wanted to ask something else, but I forgot. So whoever wants to go.
All right, so listen, as far as the other thing goes, though, Jeremy, the scientist here, by the way, the globe model doesn't have it. So where the gas in the atmosphere and the Earth is like these detached things that gas and solids normally are, they have it as this one entire entity. So it's all rotating together, which doesn't happen in reality. But anyways, so you have to change your tangential speed. So Felix Baumgartner would have had some Coriolis on the way up and the way down, but I mean, and there would have been some winds and shit. So I don't know what the whole point of this is.
My point was, Jeremy, you did not calculate it based on he was up for 2 hours and the Earth rotates at 800 miles per hour below him. That's not the way it's calculated.
Yeah, that's not how it works in the heliocentric model. He's rotating in their model. He's rotating with the surface. It's in lockstep.
I want somebody from his side to tell him that.
So I want to get this right. Because I'm just a stupid flirt. At 127,854 feet, Felix is up there, and he's going with the same spin of the Earth. So he's up there at 24 miles, and he's going the same spin as the Earth underneath him. So if that's the case, why do airplanes have to worry about it?
Crickets?
Airplanes don't worry about it. Was that for me? Why do airplanes not have to worry about Coriolis?
Actually, Jeremy, I'm not picking on you. I just want to. I'm just a stupid flurf, and I just want to know.
It's okay. I'm a scientist, flurf. I'm here for you, bud.
So I just want to know because I look at Copernicus, who I don't think actually lived. I look at Ignatius, who goes in and sees the Pope in 1539. He goes, "Hey, I want us to take over education, lawyers. I want us to take over everything." And that guy becomes the first black pope, who is ahead of the gray pope and the white pope that we all know about. And the Jesuits took over in 1543, and they basically told us through religion and philosophy that you live on a ball, and there's no science that actually backs up the ball. The only thing that backs up the ball is George Lemaitre saying in 1927, "Big Bang," and then Pinsett comes along, later on around 2015 and goes, "Well, no, George Lemaitre invented the Big Bang." So if you invent the Big Bang, because that was the first time it was coined in with Lemaitre in 1927. If you invent the Big Bang and you can't see 8 inches per mile squared, how do you know the Big Bang actually did it? And how do you know you're at 8 inches per mile squared, even though you can never show us 8 inches per mile squared? So how do you know that it actually existed, the Big Bang, at 8 inches per mile squared, if you were told that it was invented? I want to know why this is not a philosophy and why this is not a religion, because our eyes, our observations, and our experiments and our experience show us that we live on a stationary topographical plane. We don't live on a spinning ball in the vacuum of outer space. So school me, Globers, school me.
Yeah, that was for you, Extremis.
Did you get all that, Jeremy? I would like you to tell him why he's wrong.
School me.
That was for you.
So you think he's right?
I don't.
Okay.
8 inches per mile square.
Can I say something on the phone?
Go ahead.
I'm hearing you guys talk for hours now. And I couldn't say something because I was driving. Coriolis, right? First of all, you guys maybe I missed it. Did anybody define what the Coriolis is? I didn't think so.
I could.
Oh, by the way, Essie, let me ask you this. Because we got an answer from. So that guy thinks that to calculate Coriolis, Felix Baumgartner was in the air for 2 hours over New Mexico. The Earth rotates at 800 miles an hour. He should therefore be 1,600 miles off of where he took off from. Do you think that is true according to the rules of Coriolis or the globe model?
The 1,600 miles, I think he's a bit off. But not only do I know he's correct, if you like, I can walk over to my office right now, because this is the one time that I actually did a debate, and guess what subject was on? And I did research, and I have writings on it. Guess what that subject was?
Coriolis.
You got it. Yep, I can go get it right now, and I can read you the drop rate, the drop rate, whatever you want, bro. And yes, he's correct. He should have been in the ocean, according to your fantasy model. But if memory serves me correct, he landed 60 miles in the opposite direction.
So how do you calculate the Coriolis?
Like I told you, first of all, we have to define what the Coriolis is.
Okay. I mean,
you have to define. Can you define Coriolis for me, please?
I mean, I think we know what the definition is. Why do I need to define it? Do we not agree on what it is?
No, we don't. We don't agree
so we're not
on your. We don't agree in your cartoon and your fairy tale. Sorry.
So hold on. I'm not asking if you accept that it's true, but I'm just asking if we agree on what the globe model says. Whether you agree or disagree with it, do we agree on what the globe model says it is?
I have a model of Santa Claus, and Santa Claus is going to come down my chimney real soon. Does that mean Santa Claus is real? Because I have a model.
That was not my question.
That's okay.
No,
That's
but
all right.
no. But we can all agree that what you're saying that Santa Claus looks like, we all have that impression that that's what he looks like. Whether Santa Claus is actually real or not is irrelevant. He is saying what we understand it to be. We all agree on that.
What is that, Highlander? Can you define what the Coriolis is, please?
The force or the effect?
We're talking about something which is not defined. Especially the ballers. I bet you guys cannot tell me what the Coriolis is right now. Besides maybe a kosher or... But yet you're talking about extremists, and you, sir, Highlander, you can't define it. But yet you're arguing against it.
How am I arguing against it? All I said was I was trying to reiterate what the other gentleman was saying. Whether you believe it's true or not, we all have the same understanding of what it is. Yeah?
No, we don't. What is the understanding? I'm asking you, what is this understanding?
It's when an object...
For 3 hours, you guys were talking about the Coriolis. Not one person has defined it yet.
Yeah, well, I just started talking and you just blasted right through me.
Oh, I'm sorry. I didn't hear you. I thought I was talking. Go ahead. My apologies.
Hey, SC, don't blast through people.
I'm sorry. Go ahead.
It's when you move from one latitude to another and the tangential velocity of the Earth is changed. Basically.
When you move from one place to another and the tangential velocity of the Earth is changed.
North
to
south or south to north.
I don't believe that is the definition of the Coriolis.
No. May not be the exact definition. It's not far off. Will you tell us, Essie, what is the definition then?
The definition of the Coriolis, as far as I know it, is the apparent deviation of an object from a rotating frame of reference. So in other words, let me explain this plainly without using fancy words. We have a merry-go-round.
Mm-hmm.
There's two people on the merry-go-round, one on one side and one is on the other.
Mm-hmm.
You throw the ball. One person throws the ball while the merry-go-round is rotating. The ball travels in a straight line. But the person on the merry-go-round, to him, it appears that the ball is rotating. But the ball is actually going in a straight line. It is not rotating. It's a visual effect.
Well,
it's an apparent.
Would the ball not be rotating depending on how the person was throwing it?
No,
What's
well,
the
you can
ball
throw it in that.
What's the ball rotating while it's in the air got to do with the merry-go-round? Does it matter? Does it really matter? Does it really matter if the ball is rotating or it's not rotating?
It's not about the ball rotating. It's the vector in which the ball is traveling.
You said the ball was rotating.
I didn't say the ball was rotating. You didn't hear correctly.
You said the ball was rotating.
Oh, I did not. Let me try again if you didn't hear me the first time.
You said the observer sees the ball rotating, although it's going in a straight line.
That's what I said. Yes, the person in the rotating frame of reference, to him, the ball appears to be rotating, but it is not.
No, it appears to take a curved path. It makes no difference if it's rotating or not. If a ball's rotating, it's rotating on its own axis.
I misspoke. Yes, a curved path. If I said rotating, it's late. I apologize. I meant a curved path. Correct.
Yeah.
Okay. There you go.
Yeah. That's the Coriolis
Which part
effect.
of that thing? Sorry? You agree with what my explanation of what the Coriolis is? Yes or no?
That's a Coriolis effect, yes.
So it's an apparent deviation, right? Not an actual deviation, correct?
Yeah, the effect, yeah.
Not the effect. The ball is always traveling in a straight path.
Yes.
Never deep left or right. Correct? It just appears to the person on the rotating frame of reference, the merry-go-round in this case, it just appears that the ball is turning. Correct?
Correct.
Curving, call it whatever you want.
No, I'm not saying any different.
Okay, so we agreed that the Coriolis, in this case, and as it pertains to the Earth, is a visual effect. In other words, if you're on Earth, right, and you throw a ball in a straight line, right, if it's doing what you think it's doing, that ball, you should see it just like on the merry-go-round, deviating. Correct?
How fast do you think the Earth is spinning, and how much? Hold on. Let me finish. Yeah, let me finish. How fast do you think the Earth is spinning? And when you throw a ball in the air, how much deviation do you think that you should be seeing?
First of all, answer the question. Should we be seeing deviation? Yes or no?
Right, the deviation would be so minuscule that the human eye would never be able to. The human eye would never be able to perceive it.
So you're saying now that we should be able to see deviation, but it's not enough. Now you asked me how fast. I'll explain to you how fast. Hold on. In your fantasy model, your merry-go-round at the equator is spinning at 1,000 miles an hour. I don't care if you don't like that. That's the rim velocity. Look it up.
Right. Okay. So Okay. So I take another ball, right, and I spin it at the same speed as the Earth, right, and my football is, say, 1 foot wide, yeah, and it's spinning at the same speed as the Earth. Is the equator of my ball spinning at 1,000 miles an hour? No. But is it spinning at the same speed as the Earth? Yes. Yeah. That's why we don't do miles per hour, do we?
Then you have no Coriolis. If the ball is spinning at the same rate as the merry-go-round, you have no Coriolis. Do you understand?
Why is it? If you spin the merry-go-round at 15 degrees per hour, yeah, you are actually on the merry-go-round, you're barely even going to notice it spinning. Yeah, and you're expecting us to see deviation if your friend throws the fucking ball to you. Do you know how mad that fucking sounds? Do you know how crazy this fucking sounds? Yeah?
Yeah, are you done speaking now? Yeah? Now it's my turn, yeah? Thank you. So, in your model, in your fantasy model, when you're standing at the equator is spinning at 1,000 miles an hour. Now, there's nothing that you can say or do that can change that. So, if on your model you throw a ball in the air at the equator, you should see it whizzing by. Woo! And there's nothing that you can say or do that can change that. Go ahead.
Right. I'm standing at the equator and I'm still rotating at 15 degrees per hour, right? Which is still twice as slow as the hour hand on a fucking clock. Yeah? Do you realize how fucking slow that is? That's why you want to use the miles per hour. Because it sounds massive, it sounds real fast. Yeah? But compared to the Earth's size, no, it's not fast at all. Yeah, the Earth is rotating. It doesn't matter what size the ball is or how big your merry-go-round is. Yeah, if you're spinning at 15 degrees per hour, it is still not fast. Yeah, you're still not going to perceive any sort of deviation. It is not going fast enough. Yeah, whether you like that or not, at the equator, it is still going so slow you will not perceive any deviation because you are going so slowly.
Right. Are you done now? Okay. You can squirt
1,000 miles an hour all you want. But 1,000 miles an hour is just bullshit you guys come out with.
So you can squirm all you want. You can make the Earth 10 times the size. You can make the circumference 20 times, 100. Make it the size of the galaxy. If the rim is traveling at 1,000 miles an hour, there's nothing you can say or do that could change that. If you throw a ball in the air, you should be whizzing underneath it. There's nothing that you can say or do that can change that, my friend.
Nope. Again, it doesn't matter. The Earth can be the size of a galaxy, like you say, and if it's rotating at 15 degrees per hour, yeah, it's still not going to be fast. You can use all the big numbers you want, yeah. It's still not going to be fast if it's only going 15 degrees per hour, yeah. You can work out whatever tangential velocity you want, yeah, to try and make it sound like it's whizzing really, really quickly, yeah. This is the thing flat earthers do. They use a tangential velocity to make it sound like the Earth is spinning real fast. But it's not. It's spinning at 15 degrees per hour. And that's why you won't use 15 degrees per hour, because 15 degrees per hour is so slow that if you throw a ball, you're not going to perceive any sort of deviation with the naked eye.
So I'm more than glad to use 15 degrees per hour. In your model, that translates to 1,000 miles an hour at the equator, at the rim. You can cry, pout, run, do whatever you want. That's not going to change. That's your model. I'm using your model against you. Now, if you want to believe that...
You're using your dishonesty, Essie.
If you interrupt me, I will not talk to you again. Now, you can do whatever you want. You can shout and whatever. If something beneath you is traveling at 1,000 miles an hour and you jump up, or you throw something in the air, it's going to deviate away from you. Whether you're going to deviate away from it, whether you like it or not.
Wait, what? If you're traveling at 1,000 miles an hour and you jump up, you will deviate?
Yeah, if you're traveling at something that's 1,000 miles an hour and you're standing on it, right? You're on a merry-go-round. It's traveling at 1,000 miles an hour, and you jump up.
It's not spinning at 1,000 miles an hour, Essie. That's why you want to be so dishonest and use the 1,000 miles per hour, because to you and the rest of the flat earthers, that sounds real fast. So therefore, we have to be dishonest and use 1,000 miles per hour instead of the actual 15 degrees per hour, which is a hell of a lot slower than what you can perceive.
You cannot do that, Montreal. You cannot say that a merry-go-round rotates at a velocity at 1,000 miles an hour. You cannot do that.
Yes, I can, and I love it because everybody's listening here. Ballers, especially Kosho. That's why Kosho's not talking. He knows I'm correct. He knows your model, the equator at the rim, is traveling at 1,000 miles an hour. There's nothing you can say or do that changes that. Your whole cosmology depends on it. The day, the hour.
Hold on 1 second, Essie. Right, nobody is disputing that the tangential velocity at the equator is approximately 1,000 miles per hour. Right, nobody's disagreeing with you on that. Right, but it still doesn't take away the fact that it doesn't matter what the tangential velocity is. It's still only 15 degrees per hour, my friend. Doesn't matter where on the earth you are, you're still only going to be going 15 degrees per hour.
To be clear, hold on 1 second. This will take, just be real quick. Miles per hour is not a unit of rotational speed. It is specifically a unit of linear speed and not rotational speed.
I know, I tried to tell him that, but he won't listen. He still wants to use the 1,000 miles per hour because then he thinks that that's going to sound real fast, and that when we throw something up at the equator, it should zoom away from us.
Guys, every rotating body has angular velocity, and it also has a tangential speed.
Yeah, we're not denying that.
I don't think SE agrees with that statement.
The table, and he's saying it's linear speed. You're incorrect, sir. It's not linear speed.
Wait, repeat that one more time. You cut out.
The rotation is not linear speed.
That is correct. Therefore, it's not miles per hour.
That's what he said, SE. If you were listening, you would have heard him say that.
Dude, you can say it any way you want, man. I'm going to sit here and laugh at you all night long.
So, to be clear,
it's your model. Your model, 1% per day. That translates to 1,000 miles per hour at the equator. Rim velocity. There's nothing that you can say or do that's going to change that.
Right. Let's put it this way, SE, right? If
we're not disagreeing with that statement, to be clear. We don't disagree with that statement.
If we take the Earth, right? SE, if we take the Earth and put another planet next to it that's twice the size, right? But it's rotating at 15 degrees per hour as well, the tangential velocity at the equator of the bigger planet is going to be more than Earth's, but it's still going to rotate at the same speed as the Earth. Can you comprehend this?
If we have another planet, I love if we have another planet. You have a philosophy and a religion, and you have no proof for any planet anywhere.
Okay, I'm going to interrupt this real quick because I want this point, and this is a backtrack slightly. But Jeremy, I want you to tell Jim, the Waterworld guy, specifically that you do not calculate Coriolis based on 800 miles per hour at the latitude and the time in the air. I want you to tell him that because he will not listen to Glover.
Yeah, that's literally in their model. That's not. That's how you might do it on a merry-go-round or something, where the air is not moving with the rotating body. But when you leave the surface of Earth, you didn't leave you're still in the air,
right?
And they have the air moving lockstep with the.
So whether you agree it's true or not, I don't care about whether you agree with it. That method to calculate it is not what the globe model says.
And ST agreed with me, and Jeremy suppose he doesn't agree with me. If we go by what Jeremy says, then planes shouldn't have to worry about Coriolis at all because they're moving with the rotation of the Earth as well. So, guys, I'm a stupid flurf. I'm a stupid flurf, but that's okay.
No, first of all, SC is very confused about the Coriolis effect still for some reason. But the globe model, you change your tangential velocity, which planes are doing, so they should have to worry about the Coriolis effect.
After all these years, you still I taught you the Coriolis and you're still spouting this bullcrap, huh, Jeremy? Seriously.
Jeremy, I thought that was the Coriolis force that they had to deal with. The effect is what the observer on the ground sees, is it not? There is a difference between the Coriolis force and the Coriolis effect.
Yeah, the effect is the deviation that they would have to.
Yeah. And the actual force is what the plane would have to deal with.
Actual force, dude.
You see, they want to skip what I said, right? And go into the magic. If you do what I just did, they're going to see that they're delusional.
What did you do?
What did you do? Do it again. I missed it. What, be dishonest and calculate rotation in miles per hour.
Dishonest, okay? You're starting to piss me off.
Right,
you wouldn't do that if you were.
Tell me, when you rev your engine of your car, how many miles per hour does it rev at?
What does that have to do with anything?
Well, you're talking about revolutions in miles per hour, so I want to know how many miles per hour your car revs at.
I'm reciting your model, what your model says. Your model says, your scientists say
our model says we measure revolutions.
It's starting to piss me off.
Yeah, no,
interrupting him.
Go ahead.
I wish Matthew Learns was here right now because Matthew has a different take.
All right, SC was speaking, dude. Don't go on some rant. Go ahead, SC.
Go ahead, SC.
Thanks. It's going to be brief. I was just going to say that he doesn't have to like it, but that's his model. His scientists say that there's a rotation at the equator at 1,000 miles an hour. They say it, not me. That's their one revolution per day.
We don't disagree with that. We have agreed with that a dozen times. What we disagree with is, what we are trying to explain is, this is specific only to the equator and changes based on your latitude, but 15 degrees an hour is true no matter what your latitude is.
Exactly.
Where's Matthew when you need him?
To prove rotation. You have yet to show rotation. You can't even go into what effects this does. First of all, we haven't agreed what it is. You agree with me, extremists, but Highlander doesn't, right? So how can you go on and converse about something that you don't even know what you're talking about? You're assuming a spin. You're assuming this rotation off the get-go, and you're saying a plane should do this, a plane should do that, and I'm telling you, no, you haven't even shown it, and I'll prove it to you. We'll go to the equator, I'll throw a ball up, and you ain't gonna see no deviation.
Because the Earth's not moving fast.
That's true. You will not see deviation at the equator because Coriolis is 0 at the equator.
That is fucking false. We just went through this.
You don't know that.
Coriolis is minimum at the equator. You will not see deviation at the equator because it's minimum.
My God, man. That's the most where you would see it, bro. If there was rotation, right, on your globe, because at the equator it's the most, right? And as you move up in your fantasy, I know your fantasy, around where I'm at, I believe I calculated it at 800 when I did my research. So trust me, I know what I'm talking about on this. Okay? There is no rotation. You have to show rotation. And at the equator, it's the most extremistes, not the least.
Jeremy, will you tell him?
Jeremy,
His scenario of throwing a ball up. His scenario of throwing a ball up. I don't know that there would be less or more of a difference in Coriolis than there would be anywhere else on Earth.
Hey, Jeremy,
forget about the ball going up. If you throw it laterally, north or south, will the deviation at the equator be small or large?
Jeremy, are you the Glober's favorite flat earther? I just want to know.
Jeremy's the only one that actually understands this.
First of all,
he's a scientist. He's the only one that understands this.
And you know what? You know, there's this little thing out there that says 97% of scientists agree with those who fund them. So that means nothing to me. When you say somebody's a scientist, 97% of scientists agree with those who fund them. Scientists don't work off the private sector. They work off of NGOs and government grants. So if they don't agree with what the government wants them to do, they don't get funded. They don't feed their kids, and their kids don't go off to college. They don't have a house. They don't have a car. Their wife probably leaves them, or their husband probably leaves them. So you know, if you want to invoke scientists or scientism or whatever, go ahead. It means absolutely nothing to me.
Does everybody agree that in order for there to be your Coriolis, that you have to be spinning? Can we agree on that? All extremists and Highlander.
The globe would have to be spinning, absolutely.
So again, I'm going to ask Jeremy again. Jeremy, I'm doing this. The reason I keep asking Jeremy is because you won't believe anybody on the globe side. So I'm hoping you'll believe you are more likely to believe somebody on your own side.
I think Jeremy has an admirer. What do you think?
Jeremy to me is one of the smarter Glovers. Sorry, one of the smarter flat earthers. He understands this better than most.
Slipped, didn't he?
Jeremy,
he understands this better than most.
Jeremy,
you let it out of the bag now.
Jeremy, please tell SC Montreal that Coriolis is least at the equator and greatest at the poles.
Go ahead. Tell Montreal, Jeremy, that at the fastest point of where this supposed globe is spinning, the effect is the least. Go ahead.
No, see, you've got it wrong again. It's not spinning faster at any different point. The Earth spins at the same speed no matter where you are.
See, he doesn't even know his own freaking model. Doesn't even know his freaking model.
I think Extreme is going to be sending Jeremy a Christmas card. That's what I think.
I mean, if you were at the equator and you threw a ball north or shot a bullet north, there's going to be more deviation than if you're at the North Pole shooting something south.
Absolutely. If it's spinning, absolutely, bro.
Okay.
I mean, that's logic.
Hold on. Do you agree with that, Jeremy?
Jeremy, you're not only going to get a Christmas card from the Extreme guy, you might actually get a present.
In the globe model, there's not supposed to be any Coriolis at the equator.
Thank you.
Be careful, you're going to move down to number 6 or 7, Jeremy. Think carefully before you answer this.
Hey,
Jeremy. But you're talking about if you're throwing a ball east or west, or you're shooting something east or west, or if you're shooting it north to south.
Yeah, see, I don't know about the north or south thing.
Because that would make a difference.
The north-south, Jeremy, the north-south thing is what we're talking about. We're not talking about the east-west thing. We're talking about the north-south thing. Come on, Jeremy. Jeremy, I'm going to make sure Extreme sends you a nice present for Christmas.
Okay.
So, to be clear, the Coriolis is north and south. The Edvos is east and west. And to reiterate, Geo asked if you shoot something from the equator north, he said Coriolis should be the greatest effect from the equator north. And if you're at the pole and shoot it south, it should be the smallest effect. And that is opposite of what the globe model says.
Oh my goodness!
And Jeremy confirmed that.
Oh my goodness! Jeremy didn't confirm anything. If you're going north south, you're going north south on your fairy tale cartoon globe. You have to account for Coriolis at 1,039th equator, 800 in New Mexico, 700 at the 40th parallel north, and blah 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 as you go further north. It's a north south thing. It's not an east west thing. Don't strawman us. We understand. Merry Christmas to you.
Okay. Jeremy, I'm going to ask you again because he heard something different than I did. I'm going to ask you again. Geo said if you are at the equator and you shoot something north, the Coriolis should be the greatest. And if you shoot something south from the pole, North Pole, the Coriolis should be the least. Do you agree with that per what the globe model says?
Well, in the globe, you got to change your tangential velocity, and the more you do, the more Coriolis effect.
It's just a freaking yes or no question, okay?
Jeremy
yes
wants
or no.
Jeremy wants a nice Christmas present from you, Extreme. So that's why he's doing that idea.
You're making it way more complicated. You're trying to wiggle out of this, Jeremy. You know what everybody's asking. So I'm going to ask it one more time. Geo said, if I'm at the equator and I shoot something north, the Coriolis will be the greatest. And if I'm at the North Pole and shoot something south, Coriolis will be the least. According to the globe model, that is wrong, and I want you to confirm that that is wrong.
Yeah, I thought it was the opposite, and it's supposed to be the least at the equator.
At the equator, that's what the globe model says. Correct, Jeremy?
I think so, yeah.
Thank you.
Yeah, now reality, back to reality, fantasy. If you have something spinning, right, the effect is going to be the greatest where the speed is the greatest. Well, no matter what your fantasy model says, doesn't matter. If you're on a spinning platform and it's rotating and you throw something in the air, you should see deviation. Period. End of story. That means you have no Coriolis on Earth. Sorry, guys. Sorry, man.
Okay,
it's as easy as that.
I'm sorry.
Okay,
I'm
Jeremy's
sorry.
Jeremy's going to get a nice present.
It doesn't matter how many times. It doesn't matter how many times you say the speed of the rotation in miles per hour. It's still that's just fucking wrong. Yeah.
You could say it any way you want, Highlander. Would you like me when you're in the
said if you're standing at the fastest point of rotation, a body rotates at the same speed. Yeah, it doesn't get faster when you move anywhere. Yeah, doesn't matter where on Earth you move to, the Earth is still spinning at 15 degrees per hour. Right? It doesn't spin any faster anywhere else.
Highlander, you have to better, bro. That's all I can tell you.
Would you like me to explain? I can explain why it's smallest at the equator and greatest at the poles. Would you like me to do that?
You can do whatever you want, but I mean, it would depend on how far you're shooting it. You know, this idea of shooting something. If you're at the equator, you're shooting it.
You are right.
Yeah, because I'm not talking about shooting it from the pole all the way to the equator, or vice versa.
That is correct. It does matter. It does matter how far it goes.
That was something else I was trying to point out to SE, that the amount of deviation you would see if you were throwing a ball is so minute that your eyes wouldn't be able to pick it up. But apparently he thinks we should be able to see this mad fucking deviation.
I don't think, bro. I'm reciting your model back to you, and it's killing you. You don't like it.
No, you're not.
No, it sounds.
No, you're not. You're just being fucking dishonest.
Don't accuse me of being dishonest, dude.
You are.
Do not do that.
You are.
Highlander,
no, I'm not.
You seemed hung up on the rotational speed versus the actual velocity. There is a difference. If you're at the equator on a globe idea, you would be hurling at 1,000 miles an hour. You have to, because the circumference of the Earth is 24,901. even if we just take it at 24, that's 1,000 miles per hour split up into 24 sections, 24 hours in a day. That's why it's a little over 1,000 miles per hour. So you are moving at 1,000 miles per
that
hour.
at least 15 times.
Yeah,
We have
again,
said that is true 15 times.
Yeah, we have agreed with that multiple times, right? But you don't measure rotation in miles per hour.
You can. You can if you want.
That's what he was saying earlier about how fast does his motor turn in miles per hour.
You could do it that way if you wanted. If you wanted to measure the speed of the flywheel and put it in a miles per hour, you could calculate it that way. If you wanted.
So then what if you're going to measure the speed of your flywheel in miles per hour, what part of your flywheel are you going to be measuring? Are you going to be measuring the central part? Are you going to be measuring the outer part, or a bit in the middle somewhere?
They're all going to be different speeds.
Yep. Yeah, exactly. They're all going to be different speeds when you're measuring them in miles per hour. But if you measure it in degrees per hour, the full rotation is the same no matter where you pick on the flywheel.
I know, but you seem hung up on that, but no one's like conflicted about that or has even been debating that. You just seem to be hyping that up for some reason. We're all aware of that.
The only one that's conflicted about it is SE. He seems to want to use 1,000 miles per hour because he thinks that that's super mega fast, and if you throw a ball up in the air, it should fly away from you at 1,000 miles per hour, and that's not what fucking happens.
Because we live on a stationary topographical plane. Yes, it doesn't happen. Thank you for playing. See, the globe is a fantasy. It's a fairy tale. It is a cartoon. So things that you think work because you've seen it work or whatever doesn't work because it doesn't exist. It's a philosophy. It's religion. It's Catholicism. It's Jesuit creation. And Lamette and Pinsett basically said the same thing. The Big Bang was invented. And if the Big Bang was invented, heliocentrism was invented. It was invented by the Catholic Church and the Jesuits. Guys, you can have fun all you want to, and you can do all those things. But there's some of us that know what the gig is, and we know where you're coming from, and we know the origins of heliocentrism better than you even know. So go ahead and keep playing your little cartoon, your little fairy tale, because we know what's going on. We don't care. We were all brainwashed at age 5. And some of us grew out of it. It took longer than others. We understand. Thanks for playing.
Okay, thanks for that. So, SE, go back to the whole point of all this started where you were talking about, I think you were saying how you calculated Baumgartner's Coriolis distance or something?
Not the Coriolis distance. I calculated if he was in the air and the Earth was rotating like it was supposed to be, right?
Okay.
Where he should have ended up. Yeah.
Okay. So
he should have landed, if I remember correctly, 2,000 feet into the Pacific. Don't quote me on that. I told you I have it written down. If you remind me tomorrow, I can read you all the notes I have on it. He broke all kinds of records, by the way.
So I was just wondering how you kind of came up with that number.
I calculated it.
Based on what numbers? What was the math that you did?
It's simple. The Earth is supposed to be rotating at a certain speed, at a certain direction. So if there's an object in the air, right, and the Earth is rotating underneath it, it should have traveled this much. It's not difficult.
Okay.
I'm not a math genius.
Hold on. See, when you did the calculation, did you take into consideration the speed that the capsule was moving when Felix Baumgartner was up there? Or did you just assume that was sitting stationary?
No, he did not. He just said basically whatever craft he took off from, as soon as he moves up, the Earth is now spinning 1,000 miles an hour beneath this balloon. So basically, if it's spinning 1,000 miles an hour beneath this balloon, the balloon takes off. After 1 foot, the Earth has now spun 1,000 miles per hour for 1 foot past the balloon.
That's a straw man. He didn't say that, but go ahead, keep going.
That's exactly what he said.
You guys are so triggered, man. I know it sounds ridiculous. Your model is quite fanciful.
Is that what you said, SE? Did you say that?
I mean, I'm guessing conservation of momentum isn't a thing to you, SE, no?
Conservation of momentum?
So hold on. Just before he answers that, if he's in a balloon, he takes off from the balloon, the Earth is spinning he's in New Mexico, 800 miles per hour beneath him. After he is in the air for 1 second, the Earth has spun 800 miles past him. If he's been in the air for 1 second.
That's 800 miles per hour.
Well, do the math. 60 seconds, 60. Okay, 3,600.
Hey, Extreme. If you woke up tomorrow and you found out you weren't living on a globe, would you be okay?
Wouldn't make any difference. I would still have to go to work. I'd still have to pay my bills, and I'd still have to feed my kids.
Okay. Would you come on social media and you find out tomorrow that you didn't live on a globe, you lived on a stationary plane? Would you come on Discord tomorrow and still say you lived on a globe?
If the government came out and said actually the Earth is flat and here's a picture of the complete flat Earth?
Okay, so I calculated it. 800 miles per hour. Hold on.
Extreme crickets. Thanks for playing.
What?
So I calculated 800 miles per hour is 1,173. Hold on.
Thanks for playing.
Hold on. 800 miles per hour is 1,173 feet per second. So he is in this balloon, Felix Baumgartner. He takes off from the Earth. The balloon is now in the air for 1 second.
1 second.
And the Earth has now spun 1,173 feet to the side below him.
In your fairy tale, yes.
Is that what you're doing, SD? Just to be clear, that is what you're doing. Is that what you're thinking?
I'm not doing it at an inch up, but basically, yeah, you have it right. It's the amount of time the balloon is aloft, right? As compared to how much your fantasy ball is spinning underneath it. It's not difficult to understand, bro.
Okay. Now, the question is that correct? Is that the right way to do the math?
No.
I'm sure you're going to correct me. You think it's not, right?
I'm not going to correct you. I want Jeremy to correct you.
SE, did you take into consideration the speed of the craft? Or the speed of the balloon?
Too good.
No? I'm guessing you assumed that the balloon had no speed whatsoever and that the balloon was stationary in reference to the Earth.
Okay, so we'll do it this way. So the balloon is on the ground. The Earth is moving in the globe model at 800 miles per hour. How fast is the balloon moving with it on the ground? I'm waiting for an answer.
I'm waiting for an answer too. If you wake up tomorrow and you find out you didn't live on a globe, would you still come on here and say you lived on a globe?
SE, what is the answer?
Self into. He has no clue.
Wait, what?
You don't realize what you've just gotten yourself into.
Extreme is a zealot. Extreme is a zealot that can't answer the fact that if he woke up tomorrow and figured out that he wasn't on the globe, would he still come on here and say he was on a globe? He can't even figure that out.
So I'm going to ask the question again.
There you go.
Anybody is free to answer this question, by the way. This is not. I'll answer your yes. Now I'm going to answer my question. I'm going to ask the question again. If the balloon that this Felix Baumgartner is standing on the Earth is rotating in New Mexico 800 miles an hour. How fast, with the balloon on the ground, is the balloon moving on the ground? How fast is it moving with the Earth? Anybody's free to answer this question, by the way.
That's a simple answer. It depends which way the winds are blowing on that given day.
So the balloon is on the ground, and you're telling me that it depends on which way the air is blowing, the wind is blowing.
Exactly. Yeah. Ask any balloonist. Tell him, when I go aloft, which way am I going to travel? See what he tells you.
Essie, let me ask this question a third time. The balloon is on the ground. The balloon is on the ground.
Guys are like,
I'm going to ask this question again. The balloon is on the ground, has not left the ground. The Earth is rotating at 800 miles an hour. The balloon, still on the ground, has not left the ground yet. How fast is the balloon moving?
if your fantasy sphere is rotating at 800 miles an hour, obviously the balloon is doing the same.
Okay, now,
right?
That is correct. Yes, we agree on that. Would you agree with this, Highlander?
Yes.
Okay, the balloon takes off. The balloon, which was moving at 800 miles an hour, is now in the air for 1 second, which we equated earlier. 800 miles an hour is equal to 1173 feet per second. The balloon is off the ground for 1 second. Is the balloon moving with respect to the Earth at the same speed, or is the balloon stationary and the Earth has now rotated 1,173 feet to the side of the balloon?
Well, in this scenario, hold on. Who's answering? Me or Highlander?
I would rather you answer, but not Highlander.
Right, okay, no problem.
We'll get Highlander's answer second. We'll ask you first, Essie.
Okay, so this is the answer now. For 1 second, right, because of conservation of momentum, the balloon may still be at that same speed. Maybe slightly unmeasurable, probably. But I'll give you that. You're going to go with conservation of momentum. Yeah, that's normal.
So, to be clear, the Earth has not rotated under it at 1,173 feet after 1 second.
I would say no for that 1 second.
Highlander, what is your answer?
Mine would have been the same. The conservation of momentum would have kept it above the same spot.
Okay.
Okay, now it's my
We both agree on that. Yay!
Wow. Okay, now it's my turn to ask a question. Is that okay?
Okay, but before you do that, I want to be clear. That's not what you said earlier. Hold on. Just a quick question. Sorry. I just want to make sure I'm clear before we move on. I want to make sure I'm clear. That's not what you said earlier, is it, Messi Montreal? You said it would move 1173 feet sideways earlier, right? You did say that, did you?
Well, you didn't start off in the air and in the ground, right? We started off in the air.
I mean, the balloon always started off on the ground. It was never just magically started off in the air. It was always on the ground to begin with, and then it rose a 1 foot or for 1 second or whatever. But anyway, it doesn't matter. We both agree now at this point.
Okay, now we agree to it. Conservation of momentum.
Extreme, can you let SD have his question? Because I have a question for Extreme afterwards.
So now it's my turn, right, guys?
Yes, absolutely.
Thank you. So now this conservation of momentum that we agreed upon, right? For that 1 second. My question to you is, for how long do you think that balloon will keep that conservation of 800 miles an hour? Conservation of momentum. For how long do you think it will keep that speed?
That's an interesting question. My answer would be it keeps it. There is a, I don't know exactly, there's a particular function that describes that loss of linear speed, and it's a very slow loss. It does not happen very fast. In other words, if it's the same speed after 1 second in the air, it's the same speed after 2, 3. After an hour, it might be very slightly different. It's a very slow leap, for better words. It's a very slow loss of speed. Slow. But I don't know the exact time.
So how slow though? How slow for like? That's not an answer.
I mean,
Because,
the thing is, I don't know how to calculate the exact. I mean, my answer is if it's traveling. Okay, let me do it this way. If it's traveling at 800 miles per hour on the ground and it lifts off and it's in the air for an hour, it would probably be going at 775 miles an hour, 750, something like that.
Really? Really? Okay, so now my turn.
Okay.
Now you're telling me if a plane is traveling at 800 miles an hour, right? And it drops something out the window, which is not safe, right? Let's say it drops ammunition from the bottom.
A bomb, okay.
You're telling let me finish. You're telling me that the ammunition is not going to drop down. It's going to keep going for an hour or 2 or 3. That's what you're telling me. And you're telling me after an hour, that munition is going to be going from 800 miles an hour to 795 miles an hour. This is what you expect me to believe, bro.
No. See, the thing is, you're doing the calculation wrong. Because if it's in the plane and the Earth, the plane is traveling at 600 miles an hour. So that ammunition is traveling forward at 600 miles an hour. And it's a ballistic trajectory. So it's at an altitude of, 10,000 feet. So it will continue going forward at 600 miles an hour, but it will go down. I mean, it'll hit the ground within 30 seconds, a minute maybe. And when it hits the ground,
laws here?
What?
Do we have conservation of momentum laws?
Again, I was getting it. When it hits after one, let's say it hits the ground after 1 minute, it was still going forward at 500 miles an hour. I mean, I'm kind of just sort of spit, but I mean, it's still got most of its forward momentum after one. In fact, it's probably more than that because I said it'd be an hour. I bet it's going forward at 590 miles an hour. Now,
so
one clarification. Hold on. That is not counting wind and air resistance and all that stuff. I mean, that makes a fairly big difference on it.
Have you ever been on a travelator in the airport? Have you ever tried one of those travelators in the airport? If you stand still on them, you're keeping your conservation of momentum, right? What happens if you move in the opposite direction of the travelator?
Exactly. Thank you.
It's fucking bullshit.
They have it's like almost frustrating talking to them because they just don't. Man.
So I answered your question. What is your answer, Essie, about the whole plane and the bomb dropping and all that?
Bro, I don't know. I don't know how to get through to you, man. I just don't know how to get through.
The plane and the bomb are still traveling at the same speed as the Earth.
You just favor the ball for no reason. That's all this is. We're just trying to help you.
I mean, I answered his question. I answered it honestly. I answered it the best of my ability. I would like him to answer his own question. I was nice enough, and I'm trying to carry on the conversation. I would like to know what his answer is to his own question.
I tried, but Highlander interrupted me. Did you not hear?
Okay, go ahead. Don't interrupt. I want to know what his answer is, Highlander.
Obviously, if you drop from a plane an ordnance, it's going to go down. It's going to take a trajectory, and it's going to fall. It's not going to continue conserving momentum for an hour and then decrease speed by 10 miles an hour, like you said. That's my answer.
So, I guess my question is, once it hits, if it hits after 1 minute, if it's in the air for 1 minute, what is the forward momentum? Well, let me rephrase that question. Where does it lose all or most of its forward? At what point does it lose its forward momentum?
Immediately. Well, almost immediately.
So to be clear, you drop the bomb out of the plane, immediately it still has its forward momentum.
Bro, what is your problem, bro? You're starting to aggravate me, man. Do you understand that things do not keep their freaking momentum forever? Yes or no?
So immediately it still has its forward momentum. After 5 seconds, does it still have any forward momentum?
Forget it, bro. Anybody else want to talk to this dude? I ain't gonna lose another ounce of energy on him. Sorry, man.
Extreme. What percent of people in this world do you believe that believes with you that we live on a ball? What percent?
99.999.
Okay. I want to get this right. I want to get this right. Tell me if I'm wrong. Extreme just said that 99.999% of the population of this world agrees with him that we live on a ball. Is that what you said, Extreme?
That's 6 decimals.
What the hell are you doing in here for if you're trying to convince 0.00001% that they don't live on a plane? What the hell are you doing in here?
Entertainment.
I mean, is your life so pathetic that you have to come in here when 99.99999% of the world agrees with you? If I tell you what, if 90% of the world agreed with me on something, I could care less what the other 10% did. I could really, really care less, and it wouldn't be entertainment to go school the other 10%. I would only do it, Extreme, if I was getting paid to do so. Are you getting paid to come in here and school 0.00001% of the world's population? Is that what you're doing, Extreme? Talk to me. Talk to me.
Of course he is. I'm part of HR and I'm here to make sure he's doing his job so he gets his check next week.
Good. I love the fact that I would never entertain 5% or 10% of the world's population that didn't agree with me. I let them go live their little old fantasy, their little old world, their little fairy tale. But no, Extreme comes in here and proclaims that 0.00001% of the world doesn't agree with him, and he's in here trying to convince us that he lives on a ball. Thanks for playing, Extreme. You are so transparent. We could give a crap what you have to say about anything. You exposed yourself. You exposed yourself just now. And if anybody who knows that they live in God's creation, a stationary topographical plane, listens to you about anything, when you just told us that 99.99999% of the world agrees with you, you are a clown. And
Hold on a second. Hold on a second. You just said God's creation. Where is your evidence? Hold on. Where is your evidence? Where is your evidence? Hold on a minute.
Can I have an opinion?
Where is your evidence for said God? And where is your evidence said God created this earth?
First,
oh shit, you don't have any.
No, you strawman me. Shut up. Genesis 1.
Oh, from a book that's full of bullshit. Okay.
For Genesis 1:16-17, and God placed two great lights in the sky, not one to give light upon the other. I literally have 5 videos that show the sun is not illuminating the moon. It is videos. It is real time. November 1st, November 3rd, August 8th, and 2 other ones. And I'd show those to you, but you wouldn't believe it anyway. So God's creation. I have an opinion on God's creation. I showed you, and I'll put them on live stream for you to see it, and you can come back and tell me that I'm a fool. But I have 5 videos that say Genesis 1, 16 through 17 is correct, and you will tell me no. So you interrupted me, you strawman me, and we have a guy up here that believes 99.9999% of the world agrees with him, but he's in here schooling us. Now, we're not that stupid.
Yeah, so what, dude? This is a platform to discuss cosmology and various topics. He's free to be in here and share his viewpoints. For you to just subjugate him and degrade him and try to bash who he is not helpful to anything. It's just toxic and unproductive.
James King, the King James Bible that was published either in 1610 or 1611 is the most read book in the entire history of the world. So
right.
forgive
Nobody,
me if I want to read that and work off of that. Forgive me. Forgive me.
Nobody's disputing that it's the most read book on the planet, right?
I'm going to post those videos
Hold on.
right now.
Nobody's disputing that it's the most read book, right? But that book could have been created by two drunk assholes sitting in an inn fucking 4,000 years ago. Nobody fucking cares. It's a book written by man. It's fucking... Some guy could have been on magic mushrooms hallucinating all this shit and decided to write it down.
You don't care, but some people do.
You don't evidence that your Genesis is true. You have no evidence
don't care,
whatsoever.
But somebody does. Thanks for playing.
Still no evidence that God created this earth. You still no evidence that God is real.
I just posted the first one. Here comes the second one.
Well,
it's in Livestream. Go look at it and tell me, explain it away because you know so much.
Okay, let's have a look. What ideas?
You're so smart.
Right. So a video of the moon. Yeah? Is this what I'm meant to be looking at?
I have now 2 posted. I'm working on 3, 4, and 5 just for you.
Okay, so you posted a video of the sun and the moon in the sky at the same time. So how does this prove the Bible is true?
First,
that God is real?
Genesis 1, 16 to 17. God placed 2 great lights in the sky, which basically says they are self-illuminating, but you are taught that the sun gives light to the moon. Is that correct?
So God, it says God placed 2 lights in the sky.
2 great lights in the sky.
Well, what about all the other lights that we call stars? What about them? I thought he only put. I thought it said 2. I thought it said 2.
And the stars. It says
no. You just said
no.
2.
It's
2
what it
lights.
says.
Yeah.
I didn't
You said 2
that.
lights in the sky, not 2,000 lights in the sky.
No, I didn't.
Lights.
You're strawmanning me again. Don't
you
strawman
just said
me.
no.
Don't
you just said God put 2 lights in the. I only went after him because he went after that other guy for no reason whatsoever, and that was not nice and it was unfair.
He's in here. He admitted that 99.99999% of people believe as he does. So he's in here talking to point 0.00001%. Why?
Yeah, so what? Because he's my friend. That's why. Because we're friends. How's that? There's no other reason that's needed than that. He's free to be here and discuss whatever he'd like to discuss.
Good. And we're gonna push back against it. Absolutely.
Well, you can do what you but you're not just going to abuse him and degrade him and subjugate him and just berate him and ridicule him for being here. That's not fair.
Who is we? We are going to push back. Who is that? Who is we?
Me, okay? I'm gonna push back, all right?
Okay.
Push back against what? He's free to be here.
I'm gonna push back against what he says. Is that okay?
Yeah, you could disagree, but you can't just degrade him and abuse him just because he's here.
We all have different views and opinions, and nobody should be bad. Yeah,
he's here. Okay, very good.
Nobody should be abused for their opinion, even if their opinion is wrong or you disagree with it. Fuck hell, I've said a load of shit that's fucking not true because I thought it was, but then people have pointed out where I was wrong. Yeah, but that doesn't mean that anybody should be fucking abused for it.
So, SE, you still here?
Yeah, I'm still here, bro.
So I don't know if you saw this, but I put in the chat. If you try to find a calculator for Coriolis online and you put in your latitude as the equator, 0, it will show that your Coriolis is 0 on every single calculator for Coriolis on the internet.
Bro, listen, you're very frustrating to talk to. I try to keep my cool, but I can't get through to you. You see, you guys don't even understand the conservation of momentum, bro, and you're trying to use that against the Coriolis. You don't know the meaning of these things, man. And it's like I'm trying to pull teeth with you guys.
So
now you're telling me
I'm not doing this for the record. I am not calculating. I'm not figuring it out. I'm not doing the conservation. I am simply telling you that if you find a Coriolis calculator on the internet and put in 0 or your latitude, the equator, they will all tell you, every single one of them will tell you that the Coriolis is 0, without exception. So my question to you is, if all of the calculators tell you that the Coriolis is 0 at the equator, why do you insist that you're correct about it being the greatest at the equator?
Well, I agree. If they say the Coriolis is 0, I agree with them. I think there's no Coriolis, so there's no dispute there. Whoever made that calculator, tell him he's a genius. Yes, there is no Coriolis.
But that's the problem is you're saying that on the globe model, the Coriolis at the equator should be the greatest. If you put the equator
in your fantasy, you see, you don't. I don't want to insult you, bro, but me and you were not in the same level of understanding. We cannot have a conversation, me and you, because you don't understand the simplest things, bro. And I have to re-explain them to you every sentence, and I don't want to do that, man. It's late, you know?
Okay, so let's do it. If I calculate the Coriolis, and it varies based on your weight, how fast you're moving, and your latitude. Those are the 3 factors on the globe model. If I put in my weight as 100 kilograms, I put in my speed as 200 feet per second, miles per hour, doesn't matter, and I put in my latitude as 0, it will tell me that I have 0 Coriolis at the equator. If I change that number and tell them I have 45 north latitude, it will give me a particular number. And if I put my latitude at 90 degrees north latitude, it will tell me the largest number. So it goes from smallest at the equator to largest at the poles based on every single Coriolis calculator online and that exists.
And SE said the creator of that calculator is a genius.
Yeah, if he said there's zero Coriolis, I agree with him. Yeah, he's a genius.
And there is a lot, the most Coriolis at the North and South Pole.
You still agree with that?
Go on.
Do you still agree with that? In your mind, let me ask you, in your mind, what should the Coriolis be greatest or smallest at the poles?
There is no Coriolis. You have yet to prove.
Stop doing it from there is no Coriolis. Do it. Think about this from the globe Earth perspective. From the globe Earth perspective, Coriolis exists. From the globe Earth perspective, should Coriolis be greatest at the poles or the equator? From the globe Earth perspective.
Look, if you want me to agree that your model says that, I'll agree with you. Yeah, your model says that. Are you happy? Doesn't mean it's reality, though.
Okay.
Are you happy, Genesis? Are we done?
Well, you didn't really answer my question. You just said yes. But my question was, is it greatest at the equator or the poles? It wasn't really a yes or no question. It was a equator or pole answer.
I would say it depends on how far you're claiming to shoot something. It depends on that, but there would be more deviation at the equator because you're moving faster in comparison to shooting something that you guys are going to claim is essentially partially detaching from the Earth. So that's going to be greater at the equator because you're moving faster. Like the merry-go-round is moving faster there than it is at the poles, where it's hardly moving at all.
At the equator, if you shoot something north to south or south to north, then its change in latitude is going to be, it won't be as quick as what it is from one of the poles. Yeah.
It doesn't so much have to do with the distance as it has more to do with the velocity, the miles per hour, feet per second, whatever. Again, you got a bullet that travels, 1,000 yards, or you got a artillery shell that travels, 10 miles. The Coriolis is sort of the same, in both regards. It does affect the artillery shell more just because it's in the air longer, so it does travel more. But the force that's on it is the same. It just has more time to affect the larger, what's in the air longer. So I guess in that regard, it does have to do with the distance traveled, so to speak. But the force is actually measured the same if both objects travel the same speed. If you have a bullet traveling at 800 miles an hour and you have an artillery shell traveling at 800 miles an hour, then the Coriolis on both is the same, but it affects the artillery shell more because it was in the air longer.
SD, here's the bottom line. Extreme believes that 99.99999% of the world agrees with him, and he's in here trying to win an argument with you. So thank you, Extreme. And you're trying to win an argument when you believe that 99.99999% of the world agrees with you. So thanks a lot.
But I think we all agree that throwing a ball in the air at the equator, you're not going to see any deviation. None whatsoever.
Of course we agree. You know why? Because the Earth ain't spinning.
Because the deviation is so minute that you won't be able to see it.
There is no deviation. You're correct. See, that's twice we agreed, extremist. Highlander.
It doesn't matter where you are on the Earth. It doesn't matter which direction you throw the ball or how hard you throw it. You're still not going to see any deviation.
Bro, Can I appeal to your sense?
Because
Can I
the
appeal
Earth
to your
moves so
if you're
slowly.
if you're not? Can I appeal to your senses? If you're actually looking for the truth, forget what you read, forget what people have told you. Don't even believe what I'm telling you. Just use your logic and think. If you're on a platform that's traveling at 1,000 miles an hour, any miles an hour, pick 200 miles an hour, right? And you throw something in the air and you're spinning. Do you not think that that object is going to deviate, like you're going to deviate away from it? Is that not logical to you?
How long was it in the air?
And
Here we go,
and how don't give me fucking I'm spinning at 200 miles per hour. Yeah.
That's true too. That does make a difference.
Okay, 20 miles an hour. How about 20
No,
miles an
it's
hour?
not.
No,
It's
God,
not
you
in
keep doing
miles.
that, Essie. You keep giving us angular speed in a mile per hour. Why do you do that?
As if you can realize that we can calculate like rotational speed to. I don't know what to tell you anymore.
Nobody said you cannot calculate the tangential velocity at the equator. No one's saying you can't do that, right? No one's saying you're wrong when you say it's approximately 1,000 miles an hour. No one's disagreeing with you, Essie, right? But when you say the Earth is rotating at 1,000 miles per hour, that is not correct.
But you just agreed with me, and the next breath, you said I'm not correct, bro. Listen to what you're saying.
Because you don't
take back, and you're gonna want to bang your head on the wall. I'm telling you, bro. I feel like banging my head on the wall.
Yeah, that's because rotation isn't calculated in miles per hour.
Highlander, you just told me I'm correct about the speed.
Tangential velocity calculated in miles per hour, but rotation is calculated in degrees.
Okay, it's calculated in degrees, but are you moving that fast? Yes or no?
No, 15 degrees per hour is not fast at all. Have you ever watched the hour hand on a clock and thought, wow, that's moving at 30 degrees per hour. That's really fucking fast. Wow, that is mega quick. No, it's not.
Man. Way to do this, then.
Our hand on a clock isn't moving fast at all, but yet it's rotating twice as fast as the Earth is. Do you understand that? Do you understand that, Essie? Do you understand that the hour hand
You
on
got to be going 18,000 miles an hour to get to break orbit. So if our globe's in orbit around something, it has to be at least going 18,000 miles an hour, which you can't just watch like an hour.
Running.
Yeah. What about walking? What about 15 degrees an hour? So hard.
So I came up with some comparisons for you, SC Montreal. The Earth rotates once per day. Now this is 15 degrees per hour. How many rotations per minute does that equal?
Dude, go to math class. Go ask your math teacher. I don't care what you say.
Okay. That's sort of a rhetorical question. I'm going to kind of go through this and just sort of ask questions and then give you the answers.
You've given me a headache. It's late at night. Let somebody else deal with you.
Hold on. I'm gonna tell him this, Highlander. So just
because he wants to keep things dishonest. That's why.
Well, I'm gonna just tell him all this, and he doesn't really have to respond. He can just sort of listen and just think about this. He doesn't have to answer because this is just sort of like facts as opposed to opinion stuff. This is just facts that I'm going to present here. So. To answer the question, if the Earth is rotating once per day, that is 0.000694 rotations per minute, which equates to 1,035 miles an hour, or tangentially 463 meters per second or 666 kilometers per hour. Now, we're going to compare that to a merry-go-round. By the way, this is going to take a little while, so I apologize. If anybody wants to say something, feel free to interrupt. If you're on a merry-go-round, this merry-go-round has a diameter of 3 meters. Now, for this diameter of 3 meter merry-go-round to be rotating at 1,000 miles an hour at the edge, this 3 meter merry-go-round would need to be going at 1,475 rotations per minute, or 2,124,000 rotations per day. So, to reiterate, 3 meter diameter merry-go-round, 1,000 miles an hour on the edge, the highest speed at the edge, that is 2 million rotations per day compared to 1 rotation per day on the Earth, and it's 1,000 miles an hour at the fastest point. We're going to size that up a little bit. Let's go with a 10 meter merry-go-round. Pretty close to the record, but not quite the largest. Now, for this 10 meter merry-go-round, at 1,000 miles an hour at the edge, it would rotate 637,920 times per day, or 4.4 revolutions per minute.
Hey man, I came in the bullet and the artillery shell. Are y'all more focused on like Coriolis or like the force of the edge velocity or whatever? Like what y'all want?
Coriolis.
Well,
this is
y'all just talk about the initial, like you said, force and put it in what unit are you saying? In the newtons of force and then the inertia of the thing and the mismatch and all that. Well, why do y'all do this all the time?
Actually, right now we're talking about the difference between angular speed and linear speed. That's actually what we're doing right now.
I mean, I hear that, but didn't you start off just wanting to know did the damn artillery shells miss or not? You know they're gonna miss.
We discussed that a few minutes ago, yes.
Oh.
So I did one other comparison. A basketball rotating at, hold on, let me read this here. A basketball rotating at 1,000 miles per hour at the equator. This is a basketball, whatever, 18 inches in diameter, would be rotating at 1,000 miles per hour at the equator, the fastest speed, 26 million rotations, a little bit more, per day.
That's cool scale, but what was the relevant point of it?
Because SE seems to think that rotation should be measured in miles per hour and not in degrees.
So
I have no idea. No.
Here's a small other comparison. If you want to experience, now again, Coriolis is it's a force. It's measured in terms of Newton, by the way, which has not, I mean, that's a force. So the normal 80 kilogram person experiences about 2.5 newtons, give or take, at the equator. I mean, there's some other factors, but that's sort of the small amount, which isn't very much. Now, if you want this 80 kilogram person to experience 250 newtons of force, which would actually probably throw him off the Earth, by the way, or at least knock him over at the very least, the Earth would need to rotate at 9.65 times per day. Not once per day, 9 times per day. That would probably knock you over. Or at least you could feel that for sure. I don't know if it actually knocked you over. But anyway, and that would be a linear velocity, by the way, at the equator of about 10,000 miles per hour, give or take. So there's just some numbers to think about in terms of the whole linear velocity and kind of some comparisons to our everyday world in terms of merry-go-round, basketball, and all those things. Okay, I'm done. I feel like I've Monologued enough.
I mean, all you have to do is point out how slow the hour hand on the clock goes, and then say that goes twice as fast as the Earth does. Then you realize how slow the Earth is actually spinning. Yeah? Anyone else got any more interesting topics?
Yeah, Elon's stepping down from Twitter.
I take it he's got a lot of backlash from the public then. I'm only asking because I haven't really kept up with that story. I'm not really interested in who owns fucking Twitter.
He put a poll. He put a public poll and said, should he step down? And he's going to do what the results of the poll said, and it's 56% yes right now.
Yeah, but did he not have? Did I seen a thing the other day that was saying that he did a poll before that, and because it wasn't going his way, he took it down.
Yeah, he's done many. I'm just saying there's this new one here.
I'm surprised he hasn't taken another hissy fit and taken it down.
Faking space and controlling social media. I guess that's what these guys are into, huh?
Ooh, I like the way you went with that. That was good.
Just happens to be the place they put the rocket launches and
yeah,
all the latest space news.
That was good. I like that. See, we can have some fun. We can have a laugh.
So Highlander, you would agree that, you know, if the Earth isn't a globe and outer space is fake and all that, you think it'd be is it something you'd want to know? Do you think it'd be important for humanity to know about this and to possibly at some point stand up against these people that are doing this?
I think if the Earth's not a globe and it's all a lie, then it's got to be a simulation of some sort. Which then begs the question of who's running the fucking simulation.
What do you mean by simulation? Like, what's your definition of it in that sense?
I think the easiest way to comprehend it would be to say the Matrix.
Yeah. Why wouldn't it just be a okay, but in that sense, though, could it just be a creator that's just created a stationary platform of Earth to live on in the sky, and then all of us humans, and all for the purpose of creation?
Could be. But I mean, if the creator's powerful enough to create the whole universe, right? Then surely he's powerful enough to create the solar system the way that the globe model shows us that it is.
Yeah, I see what you mean. I guess the question is that what it created, though? Is that what the creation is or not? But yeah, it also could be powerful enough to create the Earth that isn't a globe and then put these people in place that tell everyone it is, and then, you know, play that whole thing too.
Yeah, but then you've got to, if you go down that route, you've got to wonder, why would the creator create a flat plane of existence and then create people to control the rest of his creation and lie to them? You know, what would be the purpose of the creator doing that?
Yeah, well, that's a question in and of itself. Yeah. But I guess that could be asked about anything. Like, why would the creator create war or children dying of cancer or, you know, all kinds of things, or, you know, car accidents, you know, all the horrible things that people go through, physical illness, you know, all these things.
That's why God's always referred to as a male. Because war and things like that isn't in a woman's nature.
Well, I mean, the word God, people have different viewpoints on that sometimes in terms of their religious perspectives. I guess I was using more the word creator, just the idea that there's like, and the idea that there's one creator and we are it is us, we're all one. We're just different parts of it, experiencing different angles and aspects. So I was just saying, like, from that perspective. So from that perspective, it is everything. It's the male, the female, the peace, you know, peace, war, conflict, love, hate, you know, all of it.
A bit like we are the universe trying to figure itself out.
Yeah, or like experiencing different facets of its own being. Yeah.
Yeah. Yeah, I've heard that before. You know, the universe has broken itself into all these tiny little parts to try and figure itself out.
Yeah, like a partitioning process of some sort that would partition itself into all these different, you know, animals and dogs and cats and humans and insects and all these different.
Yeah.
But I mean, from that perspective, I guess in terms of the Earth, you could say it could be either, right? It could be you could say, just from that perspective alone, it could be, like you said, if the creator could create anything, it could create balls in space and vacuums and gravities and all that kind of stuff. And we could get into like the second law of thermodynamics and like there's all kinds of, you know, arguments as to whether that could exist. But let's just say in a completely like almost like a video game that you're just creating, that you could create anything. So it could have created that. And then what in that perspective would then people that don't agree with that being the case, as it were, like, sort of the quote unquote flat earth movement and so on, even though people have, it's not only recently, there's so many ancient civilizations that have had a stationary planar earth, plane of existence kind of cosmology as well. So it's not like us talking about it now. We're not the first, whatsoever to discuss this. And then from another angle, like you were saying, okay, it is a stationary planar earth. And then the globe lie is part of the creation, and the controllers and these people that are currently in control for whatever purpose that the creator is playing that out. And then the process of humanity coming to the awareness that it's false. And then what does that represent for the kind of coming age, or, the age we're in, and then what's coming in the future?
Yeah. I was once I heard a couple of guys talking about what if we are in like a snow globe, if you like, right? But the Earth is a globe and it revolves around the sun, and we have the whole solar system, yeah? But we are actually just a science experiment for some really intelligent alien. And a lot of what goes on, it's them inputting, certain things into the system to see what happens, because they're doing their experiments. And I was like, well, that's kind of fucked up, but that's also could be possible.
Yeah.
Because that could explain all of a sudden natural disasters that we get. The alien could be sitting there going, oh, we'll create a fucking earthquake in India and see how they react. Boom.
Well, coming from a perspective of a creator, I know atheism would be different, but from a perspective of a creator, then whether that's, you're referring to like an alien or something. That would be like a subset of the creator, perhaps.
Yeah. Yeah.
Like the creator would create what you're referring to as an alien or something, and then that being or entity would then create us, like a petri dish or whatever, that it's then farming or creating, almost like if a human were to get like an ant farm and put it in their house or whatever, you have a little pet reptile in a cage or whatever, that kind of thing. But even from the idea of the creator, like even like some ultimate level being of creator, in that perspective, it would be purposefully creating all of these components, like the earthquakes and tragedies and comedies and love and hate and overweight people, skinny people, eating disordered people. Yeah, I'm just randomly naming things.
Yeah.
It's like all of these different components would be all intentional parts of it. Almost like that game, The Sims, that video game where you kind of sit there and you have these little humans and you make them go to work and they go to the bathroom and they, you raise kids, it's like a game of controlling humans or kind of creating and managing them.
Yeah. I suppose we'll never really know until we move on to whatever's next.
Yeah. Some of these questions are pretty transcendent to be able to come to, or to distill in one's mind. So you do think there's something next then? Because I know you've talked about there not being a creator, but you do think there's something after you die then?
Oh yeah. I know that this body that we're in is just a shell. Yeah. And I mean, this is just my own personal belief, but I believe that when you die, you leave this shell and you move on to the next place, wherever that may be, whether it be reincarnated here or being born on another planet or, you know, going to heaven, if you like. I don't know. But yeah, I believe it doesn't end with this lifetime.
Yeah. But you would call yourself atheist as well? Or
Yeah,
maybe agnostic?
I wouldn't say there's a God or a creator, but I wouldn't say there isn't one. Yeah, because I honestly don't know.
Yeah.
Could there be like multiple realms or your ability to come back and forth if like some type of sentience didn't put that in place, you know?
I mean, especially there's been a lot of this Mandela effect thing going on recently, and I mean, there's a lot of it. Like the biggest one for me was Looney Tunes, right? That I distinctly remember, right, and I remember it like it was yesterday. When the cartoon ended and it come up saying Looney Tunes, it was two O's, yeah, and the pig would come up and stutter and say that's all, folks. And when he did that, the O's and tunes were eyes, and they would move up, yeah. But apparently that's never happened, and it's tunes as in TUNES. And I'm like, that's not what I remember. Same, I seen a thing today where a guy took a Shelby GT to that pawn shop, you know, for Pawn Stars, and they were on about how it was a GT 350, and that's what that car was made famous by the film Gone in 60 Seconds. But I thought the car in Gone in 60 Seconds was the GT 500.
Demok, your mic's all we can't hear you. It's all muffled or broken or something.
Yeah. I mean, I could be wrong about the GT 500, but I swore it was the GT 500, not the GT 350.
Yo, tell me what you think about this this logo I'm messing with.
Yeah, it's pretty cool.
Is that going to be your new logo?
I'm thinking about it, but Gio did not think it was very cool. I could tell, so I'm gonna have to redo it.
No, I like it. Why? The tone of my voice? I think it's cool.
Yeah, I like it.
Intuitive.
I like the mirror version on the tree on it. That's pretty cool. Yeah,
it's like
I
a
like
double
that.
Taurus. With the tree. Yeah.
Well, just like the letters don't pop as much, maybe like they kind of blend in with it a bit.
Did you design this? What's it?
Yeah.
That's pretty cool.
Thanks. I couldn't find anyone to do it, so I'm like, fine, I'll just do it.
The design is good, bro. The colors are off.
Okay.
There's just one color. You gotta change the colors.
I have like 50 different types. It's so funny.
Yeah, that's what I was thinking. Just
about the letters.
Yeah, just for the letters to stand out more amongst the whatever color you choose for the background part. That was one thought I had.
I could drop so many in here. It's super fun. I'll drop a few. The first ones I had, the letters blended even more. I think the
Can you not?
gradient's cooler.
Yeah, the one where the letters are white is
One
is
color.
better.
Mix it up.
Do what?
Mix it up, bro. You got a screen, you got the tree, and you got your name.
I think the first one you showed us, but with the letters being white, like in the second one, I think that would be the best.
Okay.
But that's just my own personal opinion.
Yeah, I agree that I think it's cooler where I just decided to make like a gradient where there's like the tree and the rest are different colors. So maybe I'll try and make the letters like white or something. Well, thanks for the feedback. Sorry to interrupt.
No, that's fine.
Well, we were kind of talking about a little bit like, because Highlander was saying, well, couldn't the creator have created the heliocentric model, and have that be the case? And then he was trying to think about why the creator would create a stationary planar Earth and then insert the globe lie within it.
Oh, I guess you could apply that to before they allegedly found out it was a globe too, huh? Why would they make a globe Earth? Why would he make a globe Earth and insert the flat Earth lie into it a few hundred years ago?
Right, like let's say it was a globe from the beginning or something, and then there's all these cosmologies that have a planar Earth, like the Vedics and all of these ancient cosmologies that have a planar Earth. Yeah, like why would they? Yeah, exactly. You could kind of reverse it in that sense.
I will say that, like, in my opinion, like the only way that like the globe heliocentric model could exist is if there was a god. Like if there was some type of, like intelligent design. It's just so crazy, and like the Earth would be so lucky.
Yeah, I know. It seems like equally it would need. Yeah, it all seems to need a creator. I mean, just the idea of anything random or having no intention behind it really just doesn't even logically fit really in either model. Because I mean, to create spheres and gravity and all these different components, you would have to have a creation behind that.
Yeah.
What makes me think that, or sway a little more towards a creator, is your body is mathematically perfect. Like, see from the inside of your elbow to your wrist, yeah? That's the size of your foot.
Yeah, and also the Fibonacci sequence that's in the body, like the ratio.
Yeah.
It's all through the body, like from the elbow to the wrist to the knuckles to the knuckle to the end of the finger. Each of the fingers also between the knuckle, all the distances between the knuckles are all the Fibonacci sequence.
Yeah.
There's a whole multiple others. Like even the ear is the Fibonacci spiral.
I mean, the distance between fingertip to fingertip when your arms are outstretched, that's your height. Yeah. If you put your thumb down next to your index finger, from the tip of your thumb to the tip of your index finger is the length of your nose. The pupils of your eyes are the exact distance from of the corner of your mouth. That same distance is the distance between the pupil of your eye and your ear. It's fucking crazy. I mean, that makes me think there must be some kind of intelligence behind human design.
Chanji says, like, why couldn't a god create evolution to play all this out? Well, like, in all reality, evolution has been, like, clung on to, like, if anyone's being honest, to explain existence without a creator. So it's not like we just stumbled upon some evidence we had no choice but to accept, and boom, evolution's the only way. No, we have, like, tons of guesswork and leaps of logic to try to make the idea of evolution be possible, theoretically. And if you ask most people, I mean, yeah, they like it that are honest, like academics, they'll tell you that it's basically the alternative to creation. So.
I mean, I don't think evolution excludes a creator.
No, it doesn't necessarily.
That's my own personal opinion.
Yeah, I agree. It doesn't. Like, it's the same thing with the heliocentric model. In fact, like, for evolution to exist, it almost requires a creator. But yeah, I'm just saying, like, it's convenient in debate to say that they're unrelated, right? But in reality, the reason that it's been adopted across the board in academia is because it's considered an alternative to the requirement of a designer. Now, like, I know in debate, people won't say that because it's like not as good optics. It's kind of like people will debate for evolution, but they'll say abiogenesis is a completely different subject. You see what I'm saying? Like, yeah, I just think it's a debate tactic, personally. Like, I think if you talk to actual professors and stuff, they'll tell you that's kind of like what shows us, that's what helped us discover that you didn't need a creator. That's how they look at it.
You could actually give him the creator on a silver platter and say, yes, okay, God could have created evolution. Because if you think about it, yeah, that's true. But there's no proof of evolution. That's the problem. I challenge anybody, show me proof of evolution. Show me proof, skeletal proof of one creature turning into another creature. I challenge anybody.
I mean, you could say that about God as well. You know, show me the evidence for said God or said creator. You know, it's.
No, but this is possible. You're saying evolution. That means, you know, we evolved from amoebas in water, right? And we, from a cell, we became a body and bigger fish, and then the fish went to land, created legs, lungs. You know the story, right? Okay, show me one instance of this. Dare anybody? There isn't. Doesn't exist. So even if God created evolution, which he could have, yeah, all powerful, there's no evidence of evolution. So sorry, Sean, bro.
Yeah, I mean, like I said, I mean, it's a debate tactic, in my opinion. Like if you're debating someone about evolution and then you bring it to its logical end, you're like, okay, so, like, you believe in abiogenesis? They'll be like, nah, I didn't say that. You know, that's a different subject. We're not talking about that. And like, okay, well, then you have to invoke a creator, right? Like, I don't know. To me, it seems like a debate tactic to break the topics up into different things. It's kind of like the heliocentric model, right? Like, intellectual honesty would demand you kind of address and absorb all the implications of the model instead of, like, separating dark matter and separating dark energy, and you know what I'm saying? You would just be like, oh, well, this is everything that my model makes happen. If you claim that the Earth's a ball in a heliocentric model, well, here's what all happens. You know, if that's the case, here are the ramifications. But for a debate tactic, because it's easier, it's a safer position in debate to keep them separate and pretend they're unrelated. And then to say, like, oh, I don't have to believe in that. I don't know much about dark matter. I don't know much about relativity. Right? Keep them kind of separate. So
yeah, but the fact is, what do you have here, B-Ball? Seriously, what is that? There is no evidence evolution. They cannot show you like skeletal or fossil remains of one creature turning into another creature. It doesn't exist. It's a myth. See what B-Ball has here.
It is kind of clever marketing in a way, though, because it's like there is like the word to evolve. There is like a certain evolution of time, and of things that occur, just within the earth, like different systems of the earth, rocks that wear down and all of those kinds of things. And so from that idea, one could say that humans have been evolving. We're even evolving into 2023 and then to 2024. But to use that word and then to link it the way that they have into the kind of theory of evolution, it just seems like a clever marketing way to kind of use that term and that idea and then to link it with something that is sort of like an aberrant idea or concept that does not have any actual backing to it, to then explain this creation story, which seems to come with the globe and this whole current model that they're pushing.
Oh, yeah.
Yeah, absolutely. You see what Earth? Are you serious, B-Ball? Really? Diagrams of a hand turning into a whale from a whale? You got to be kidding me.
Well, they have to believe that their ancestor is a strawberry. So, I mean, just put it into perspective here.
Yeah, Sean G said evolution doesn't say creatures turning into another. Yeah, that's exactly what it says, and turning into many others, and those turning into others and others and others. Yeah, that's your fantasy story, bro. Sorry if you don't like it.
It's kind of another talking point. You know what I'm saying? Like,
yeah, yeah.
It says we all have common ancestry, so I mean,
no evidence of it. If there was, they'd be posting pictures left, right, and center right now. But there is no evidence.
What's that? And then, where's the others? Like, where's all the different things running around?
Yeah, you have to believe that a fish or something from the water came out of the water, sprouted legs and lungs, and then that thing became another thing and another thing, and whap, we got a giraffe. Where's that record? And from that, whap, we got an elephant, and we got a zebra, and we got a dog, and we got a cat, and no, man, that's these are fantasies. Fantasies.
but do you agree? It's like a talking point to say it doesn't say that things turn into other ones, when it literally does. It says that everything came from a common ancestry, and that everything came from a common amoeba, right? I mean, so that is technically that turning into something else. I mean, you have to track it all the way back. It's not like you just get to snap your fingers and starts with all these different kinds.
But that's literally what it says. This literally their model.
Yeah. But it's just hard to
There's
defend.
no Sorry?
It's hard to defend that, so it's easier to say that's not what it says, and then just kind of skate past it.
Yeah, then they're going to show you beaks of the Galapagos Islands. Yeah, it's always the same story over and over. Bro, that's not the same thing.
It's allele frequency over generational change.
How
there is a
would
change.
the same hold on? How would the same bird changing the shape of its beak not be classed as evolution?
It's not a change of kinds. That's just a bird being a bird. You need to change a kind.
You don't think we're gonna have some kind of genetic alteration? Let's say it's exposed to some type of it goes by some uranium or something. It has some radiation exposed to it, so it changes the DNA, and so then it mates, and then it has a little deformed bird with a little teeny beak. But something happens where the little beak is more adapt to getting food because of a drought or something. So the ones with the big beaks, that the normal ones with the big beaks, all die off, and you want the little beak procreates and it survives. And that's kind of how evolution works.
But you need to change a kind.
Well, isn't that a change of kind? Oh, you're talking about going from it's still a bird, but it's not a lizard or something. Didn't change
Yeah,
into
change a
something
kind.
different.
Yeah.
Yeah. I don't
Never
know enough
been
about evolution to make a comment about that.
never been observed, man. I
Well,
watched this guy
you
go
don't know.
around and
You
ask
make it
people.
sound like
at
we're gonna
work at
watch it like a movie. Like, let's see this change of kind. The bird turns into a turtle.
Well, Zanuck, at the end of the
that's
day,
not how it works.
it's a way to try to explain, let's say, a globe in a vacuum that just congealed together because of gravity and the swirling and whirling of gravity, that then these rocks and these things all swirled together. And then on this rock ball thing, the little whatever single-celled organisms ended up becoming all of this.
Right.
Versus the idea that it's all created. There's individual components of the creation, like cats are cats, dogs are dogs, humans are humans. We didn't all just come out of a congealed Big Bang rocks of gravity sludge, that there actually is an intention and an actual intention purpose behind it all. So it's a dramatically different scenario.
I'm totally with you, because I look at things like the eye, and you understand how the eye actually works. I don't think, even though millions and millions of years is a long time, I don't think that's long enough for this kind of structures to kind of morph naturally. So I'm kind of with you, just because I'm ignorant for most of the ideas. I mean, I know the general high level for sure, but really in my heart and knowledge level, it's hard for me to imagine that that's possible, that there's enough time for all this to happen, even if it's a billion years. I'm more along the lines of intelligent design.
Horizontally, like evolve away from a planet horizontally, like 1 foot off the dirt. I don't think that's possible on a globe, is it? You couldn't grow.
You cannot be a science, claim that you're into science and have anything to do with intellectual thought and believe that there's not an intelligent designer, in my opinion.
Well, if they say is true, and they're talking about there's enough, that they say, contrary to what I just said, there is enough time, and these lizards suddenly will have genetic mutations where they lose the tail and those survive, and then suddenly they lose their gills, and then they form lungs that are kind of related to gills but are different, because now the one that was born that had some malfunction suddenly can process air where it didn't process air before, and now it's a mammal, and instead of laying eggs, it's giving live birth because it's some genetic mutation.
Yeah, but that's
over a billion, over hundreds of millions of years, but I don't think that's enough time, even hundreds of millions of years.
But I mean, that's adaptation. It's adapting to its environment and slightly altering. It's not changing its entire species into something different.
Yeah, we need like a change of kind.
That's why it does that.
We need to change of kind.
The in-betweens.
It hasn't adapted. It actually has. It's mutated. The genes have changed.
John, you're coming in kind of low, man.
Someone trying to talk? I couldn't hear him.
Yeah, I was in the middle of talking. So just run right over me.
Because we can barely hear you. It sounds like you're like 100 yards away in a pool.
Yeah, you keep cutting out as well.
Understandable that you made the assumption that he was just talking over you, though.
Yeah, like let's say we have white wool, and because we have a mutation that makes the fur comes out white, albino, but yet now it has more survival because now it can't be noticed by its predators, and so the rest of them die off. He survives, he procreates, it flourishes because he's white. Is that part of evolution, or is that just adaptation? I think it's an evolutionary process.
because of mutation. What do you mean by adaptation? SC, what do you mean by adaptation? What's an example of adaptation?
If you stick something underneath the ground.
It is in the Galapagos Island, where over time, due to the plants, their beaks they changed to feed on the plants. That's what you would call adaptation.
Well, aren't they changing because the ones that had bigger beaks because of mutation, or just because of the natural variations, that they became more? They would survive longer or better. Same thing, right? I don't think it's a difference.
No, the birds with the correct beaks survived, and the other ones didn't.
Well, that's what I said. Like what charge?
We're talking about
what changed.
Zanuck, we're talking about birds. Zanuck, please. We're talking about a bird evolved, say a four-legged thing that crawled out of the ocean. That's what we're talking about, evolution, not
over short
a beak.
The beak change. Oh my God, the beak. Sorry to say that, but the beak change. Yeah, we agree. I think we both agree that maybe there's a mutation. Some are born with longer beaks, and for some reason they're able to get more food.
No, not I never said mutation.
Hold on a second. Hold on. SE, I was in the middle of a sentence. So the longer beak versions live longer. The other ones die off, and these other ones become more plentiful because they can survive better. But then that's just one small step in the evolutionary process. Don't you agree? I mean, according to the theory.
When you said, what did you say?
Mutation?
What did you say caused a mutation? Yeah, I didn't agree to that. Let's be clear.
What makes the beak? Oh, you just think there's some that had longer beaks and they survive more because they were born with longer beaks, or that style of bird.
People longer arms, shorter arms, longer tongue.
Yeah, humans. Exactly.
I don't know.
I
think we could agree that maybe there was a mutation, and the mutation caused the same bird to have a longer beak, and the ones that had the longer beak, because they also mated and procreated, those survived better. And as time went on, the ones that had the shorter beak weren't as susceptible to were more susceptible to famine and maybe drought because they couldn't drink as fast. I don't know, whatever. And the longer beak ones survived. So that's one step in evolutionary process. I can buy that. I think I'm with you though that doesn't turn the bird into a whatever they turned into. I don't know what's next, a dolphin or something. I don't know.
If one species cannot turn into another, your evolutionary theory goes bye-bye. Well, because it started off. It started off in a pond.
I don't know enough about it, but what is a bird supposed? What are these birds? What do they turn into? I mean, dinosaurs didn't turn into humans.
Right? You got to figure it out. They don't. They were always birds. They never turned into from or are going to turn into anything.
So that was the final step.
Yeah, what about the humans? Which human lives longest?
Evolved into birds.
Short arms, long arms, tall, big toes, little toes, big teeth. Which human lives longest? One with fangs, one with blonde hair, one with curly hair. Which one? Tell us, Zanuck. What's the attribute they gain to live longer and better more than everybody else? Which ones? Where's it at?
Or look around you and tell me what's turning into another creature. What's in the process of turning into another creature? Look around you. Isn't everything perfect the way it should be? Isn't a bear, a dog, right? You can crossbreed.
They say the birds birds evolved from those theropod dinosaurs, right? That's 150 million years ago. That's the theory, right?
Yeah, but it's still a bird.
But it came from the dinosaur.
It's proof of it's still a bird. You getting it? You got it?
It's right. And they also
didn't turn it.
Yeah, that came from the dinosaur, though.
Zanuck, I mean, if you're not getting what I'm saying, I don't know how else to say it.
Well, they had the bipodal pasture, then they had the wings, then they had the tail, and then they had the sternum, and then they became in the modern birds. But it started out as these dinosaur type
references.
And before the dinosaurs,
where's all your different references?
Than that, like squirrel, like weird little angry squirrel and lizards.
You know that's
funny, man.
fucking funny, don't you?
You've been drinking, Janek. A squirrel,
Like
so we
chicken
got
whale.
Chicken whale.
Little angry squirrels.
Squirrel, lizard, chicken whales.
So not angry birds, but angry squirrels.
Angry squirrel. Looks like the angry squirrels were the predecessors to these dinosaurs.
So that would be Angry Birds 0.5.
I don't know.
Watching that
mammals?
cartoon.
I think they're mammals, aren't they?
You've been watching that cartoon where the squirrel has to save his nut out of the ice.
Mammal? I'm gonna go with mammal. I don't know. I'm not an expert of.
Yes, a squirrel is a mammal. Yes.
You guys think that you came from
here's the chart.
strawberries?
Yeah, I'm convinced. Way to go, Janek. Yeah, I'm a believer now.
We got pigtails.
This is what they believe, man. This is what they believe, and they'll tell you one creature doesn't turn into another one.
Yeah, but they believe we all came from strawberries.
Yeah.
That's legitimately what it says.
Oh, we came from the squirrel. I think we came from the little angry squirrel.
You always came from a strawberry.
Strawberry.
Legit, dude.
Pigs and monkeys.
The sauropods, the Tyrannosaurus. What the hell is that? Drama Escosada. That's like my ex-girlfriend. She's a drama sada something or other. Sodomizer. Terra. I can't even pronounce. I could never be one of those anthropologists. Or what do they call them that they study dinosaurs?
Pseudoscientists.
We got friends. Wasn't he a dinosaur studier? What are they called?
Pseudoscientists.
What are they called? A pseudoscientist.
You gotta admit, it's kind of funny that
who
people
studies
believe they
dinosaurs?
came from strawberries, dude. I just can't. I mean, I know I'm saying it over and over, but it just puts it into perspective. That's not a straw man. I know it sounds so insane that it must be a straw man. It's not.
Humans did not come from a straw man, no.
Paleontologists.
Yeah, you came from a
Paleontologists,
strawberry.
right? Yeah. The pseudoscience kings, right? According to you guys, paleontologists are just studying total bullshit. They have no
They are.
idea.
They claim that we came from strawberries.
All they do, they just came from strawberries. Everyone came from strawberries.
I know it sounds funny, but that's what they believe.
What about the evolution of carnivorous plants? I must have seen 10 carnivorous plants yesterday. Is there an evolution of plants and
Yeah, of course.
flesh?
I like the little finger hand, the hand that grabs the fly and swallows them.
Yeah, but I'm talking about there's at least 10 types of those varieties.
And by the way, nobody thinks that humans came from strawberries because strawberries have not been around that long.
Yes, actually, you're from an
Genetically
ancestor
modified.
with a strawberry.
If one of those little plant-eating monsters ate my finger, I'd pull him out of the ground and eat him.
Maybe the little shop of
haven't been around long.
Little shop of horrors.
Yeah, the little shop of horrors. Maybe it's some type of yeah.
It could be. You never know, right?
Well, you don't know. You don't know.
Plant.
We don't know anything. We're
No.
so ignorant. All we do is listen to the Bible, and read Bibles, and listen to people that make up shit and pseudoscientists, and Earth is round, and there's vacuum of space next to a high pressure. Fucking crazy sun.
No, listen to that crazy stuff. Isn't that insane?
Curvy measure, bent rulers. We got loads of stuff, haven't we?
Horizon drop at altitude. It's all nonsense. Just eyes don't. No one doesn't understand how the eye works.
So they say that strawberries have been here for 8 million years.
Our own personal moons. It's all projection and simulations and nothing's real.
They did adjust 50 varieties of banana into one, apparently, like in the 1800s, and the bananas used to taste like the sweets, but then they got 50 types of variety of banana and put it into one. I wonder don't know why anybody felt they needed to do that, but I would imagine maybe, I don't know, the content of the bananas that we eat today.
I think because we're healthier now. Look at how hot the chicks are today. You think they were hot back there in the, 3000 BC? No way, because they were eating shitty bananas. Everything was ugly. They were all unhappy. Everyone was ugly. Now they're all happy. They got bananas. They got watermelons now. Think about they didn't have no watermelons before. Now they're seedless watermelons on top of that.
But
Everyone's
is the
happy.
fruit
The chicks are hot. Everyone's happy. We're in paradise.
is eating the fruits and us ingesting it and then exhausting the gases from eating those natural fruits, are they good for the environment? Maybe that's what they're trying to tell us. Don't eat the fruit, or something like that.
Fruits. Do you think the fruits make you blow methane?
Because there's sugars in the environment. I think what we see above us and stuff like that, there is some type of which there is. If you look it up, there's a carbohydrate in the sky, so a basic sugar. And if we're looking up, maybe we're just seeing a type of sugar aberrance and not thermal or magnetic or anything else. We assume it's just the fact that
there's no vacuum of space. It's just freaking Willy Wonka's chocolate factory up there, sugar farm.
Zanuck, would you admit that you really just believe in space?
No, because I know how the pressure degrades with altitude. I've gone too high myself, and I've been on tops of mountains, and it just makes sense because no reason why it wouldn't go down continuously, exponentially as it does. Why would it not? Why everything we see shows that it goes down exponentially? All the tests, we have space, we have measured space. Kindergartners with their parents send up balloons in classes to see, hey, what is the pressure at 100,000 feet? And it's basically space.
Danny, can I use your same logic? I mean, let me apply your logic here.
To be clear, hold on, one quick thing. To be clear, it's not an exponential decrease in air pressure; it's a logarithmic decrease.
All right. Well, you just said strawberries weren't here very long, so just so you know, I'm gonna apply your logic, Danny. Okay. So if we dive down into the ocean, and as we go further and further down, what happens to the pressure?
Pressure gets greater.
Okay. So is
and
it
goes
logical
up one
for me?
atmosphere every 30 feet, every 33 feet.
Is it logical for me to assume that the pressure gets greater infinitely?
As long as you go down, it will go up because of hydrostatics. These are laws of nature. It will go up, adding only 14.7 psi every 33 feet. However, going up, it's an exponential degradation. Fairly linear for the first 5 or 10,000 feet, but after that, it's exponential. So that
You
we
didn't
have
seem to get my.
0.05 psi at 100,000 feet or 120,000 feet.
I don't think you
That's
got
space. That's basically space. There's no air there.
I think you missed the point.
Yeah, you kind of missed the point, man. Like, if I
What's the
start
point?
going down in the ocean and the pressure increases, so we get greater and greater pressure, is it logical for me to assume that since it gets greater the further down I go, that it just continues to get greater infinitely?
For as deep as the ocean is, yes.
Okay. So it's logical for us to assume that there's a limit to the depth of the ocean, and then we reach physical containment of the ocean.
We have something that is pressing upon. At some point, there will be something that is pressing upon. That's why vacuums can't. That's why vacuums cannot do work. Vacuum the
So
other direction is
eventually,
not the same. Well, hold on, it's not. There's nothing containing a vacuum because the vacuums can't do any work. There is not a surface needed to have a vacuum.
so eventually we reach an area that's containing the pressure. So just because there's a gradient or a gradual increase of pressure, the fact that there's a relationship of distance and pressure doesn't somehow open the door for the conclusion that means it goes on forever, because to have that pressure in the water has to be contained.
It's no different than creating the vacuum above. The reason I say that is because you have an exponential decrease in pressure as you go up. You don't need anything up there to have the pressure because vacuum does not need anything to create it. However, pressure does. And what does pressure need? A containment. But what do you mean by containment? All I mean by containment is a force. That force can be molecules hitting each other. All they have to do is make contact. Once they pressure, and that contact, that Gaussian contact, can be caused by the container, a physical container, a wall, or it can be caused by them running into each other. There's no difference. These molecules, these elastic collisions, don't discern between a container, wall, or each other. So the way that happens is because of hydrostatics, which does not need anything above, because that's what the vacuum is. It only needs things below because everything is going down. Everything's going down because these things have weight. Why do they have weight? We don't know. Gravity. What is gravity? We don't know, but it does create a force in mass that's proportional to its mass.
If everything is going down, then why is it that your belief says that we're losing tons of hydrogen into space?
Because single atoms, especially that are bouncing around in the thermosphere that have high velocities, will reach escape velocity, and they will have the velocity to escape the pull of gravity. And that's exactly why they leave. That's why we leave very few, considering how much we have on the Earth. Very little mass is leaving the Earth, but some does, and it's only based on their velocity.
How can you escape?
And single atoms,
How can you
molecules
escape?
are too large and too massive to escape, but atoms can. Hydrogen and helium atoms can escape.
Yeah, so big tons of fish can move around easy, and
CO2
you can
doesn't.
lift those and throw them, but you can't throw
We
pieces
don't
of
lose any
sand.
CO2.
We know. It's real weird, isn't it?
So not everything goes down, right? So
no, it has a higher. No, I didn't say everything goes down. I said everything has a higher velocity down than any other direction.
No, you said everything goes down, quote unquote. But if you want to change it, that's fine. So to me, it's extremely.
A molecule bouncing off another molecule can go up. It just has a higher velocity when it's going down. It has a higher, has a greater has an acceleration down always. Always has an acceleration going down. Yes, that's what I meant by that.
Okay.
So don't take that out of context. Even though it's going up, it has acceleration going down.
So what's weird to me, right, is I find it to be illogical for one to say that the Earth's atmosphere extends into space infinitely. I think that's dumb. And in addition to that, if I were to test your theory, right, well, the idea is that the gravity of the Earth is resulting in a force that is holding down this gas.
Right. Causing a progressive force upward, yes.
So if gravity is causing a force, well, a force that isn't a force that we can think of like a force.
No, let's talk Newtonians just so we can have a discussion.
Upward.
We don't need
Opposite of itself.
Crazy other types of
Opposite of
theories.
its own
Let's just talk
existence.
about Newtonian.
Opposite against its own existence, against itself, against downity
we know that
down at
everything
all
has
costs.
a higher velocity, even though it goes in all directions.
How do you get in a single? How do you get a singularity?
Going down. Everything has an acceleration.
How do you get a single focal point, Xanik?
Ubiquitously.
Xanik, how do you get a universe
no way
into
you
a
can
focal
show
point?
Otherwise.
How do you get a
That's
universe into a pinhead?
That's why you can weigh a bottle of gas. That's why you can
I
weigh
think,
a bottle.
Xanik, do you have Democ muted?
I have him low, but I mean, just because he's just.
Well, you're talking over him.
Oh, I didn't hear him.
You seem to be talking over everyone. As per.
So this is what I'm trying to say to you, man.
Asking, how do you? Yeah, how do you get that focal point, Xanik? How do you get everything like if everything went to a focal point, the focal point that we all came from, a Big Bang? No, what was a Big Bang? What was that thing?
What are you talking about?
What is a Big Bang?
Not a focal point.
What did it start from?
We're not talking about Big Bangs. Where are you going?
No, you're not. It's not a focal point. It's not smaller than a pinhead. Everything in the universe. Everything.
It's something that isn't. It's a point that.
Well, how did that happen? If there's all this forces going away from that, how did gravity do that? How did you get a focal point if there's an uppity up? It doesn't make any sense if everything went downity down to a focal point, but now you're saying everything's got an uppity down. Well, you're saying gravity is up down. So what is it?
D-Mock, come on.
What?
Once you put
Up,
that on
down.
pause and let
Helium.
the adults in the room have a conversation.
Does gravity make helium go down? Does gravity
Yes.
make helium go up?
It
So now
gives it a
gravity
downward
is up, down.
acceleration.
Up, down,
Gives
right?
helium a downward acceleration, yes.
So gravity's both directions, right?
Gravity, one direction, acceleration down.
No, up, down.
Says you.
No, says you. They're not the same direction, are they?
No, you said up, down. I said down.
Yeah.
So
what about
you.
helium? So what about helium? What's
Also
it
has an
doing? Where's it
acceleration
going down?
Also has an
Is it
acceleration
going down?
Should I say it a fifth time? I'm not going to say it a fifth time.
Well, show me how it's going down. Drop a rock and let helium go, and show me them going the same direction.
Acceleration down.
Are they going the same direction or no?
No.
This is so simple. No, they're not. So gravity is both.
Nope.
So what is gravity? Down or up?
Acceleration down.
So how do you get up? How do you get heat rising?
You still have acceleration down.
What?
You don't understand accelerations, D-Mock, so I can't really explain it to you. Or nor do I want to.
Explain? You mean you can't imaginate it to me?
Imagine
I
it?
don't think
How do
you have a
imagine
demonstration of anything. No, explanation is invalid without demonstration. I'm sorry, pal.
Okay.
Well, I wanted to comment. Zanuck, you were admitting that the pressure going down in the ocean has to have a barrier and a limit. So why is it that it would not be the same going up? And why do you think that it would be inhabitable as well at high altitude? Because obviously if you're going, the deeper you go into the ocean, the less inhabitable it gets.
Both are inhabitable. Both extremes are inhabitable, but going down, there is the place where everything is piling up. Once something is stopping to accelerate, there's no room to accelerate. That becomes its limit. Upward, there's no limit. So you're getting it closer and closer to zero because there is no zero. There is no limit. The only thing keeping the pressure up anywhere in the atmosphere above it is that there's gases there that have been piled up and have weight. And the weight of those gases progressively increases the pressure as you go down to the surface. And even when it changes states and is in water form, it goes down, even continues to go down. Now we have the hydrostatics, which is different of water versus gas, because gas is compressible and liquid is really not compressible for all practical purposes, even though it is slightly. It's a whole different. That's why we have an equation in hydrostatics that show us how the pressure will go up, and it's a linear function. It goes from zero relative pressure down to thousands of psi at a rate of 14.7 psi for every 33 feet.
So you don't have any physical evidence that you see. And do what yourself?
Make a barometer out of mercury, out of water. You'll see that you're 33 feet for water.
What are you testing?
29
in your electrical barometer.
For mercury. All these things will show how
it's chemical electrolysis, right?
By hydrostatics.
No, voltage or currency is created in your chemical electrolysis in your barometrics, right?
What about if you open up a can of pop at the bottom of the sea? If you open up a can of pop at the bottom of the sea and then open up a can of pop up in the high in the sky.
Yeah, what's going to happen?
They're both. Am I right in saying they both? Neither of them. You can shake the can and neither of them fizz out. I definitely know under the water that it won't fizz out if you shake the can. What about up above?
Oh, it'll have a big explosion up if you go high. Because in the max, it'll have a max that it will explode. The max will be in zero pressure. But at anything in between 14.7 and zero, the higher you go, the more the explosion, the more that it will expand. But under the water, the opposite. You can get to the point where it never explode. It'll implode. You can shake it all you want. You pop that can under 1,000 foot of water, it's going to implode.
Yo, I'm just trying to point out to you that it's extremely illogical to think that the Earth's atmosphere extends infinitely into space. In addition,
Why is that logical?
because it's the opposite of logical.
No,
But in addition to
that's not an
that,
answer. What's the logical fallacy for that response? I can't remember, but no, that's not an answer.
no, I just okay. Really, I have to explain
It's
to
not
you why it's
logical because
stupid
it's
to think
illogical.
that the Earth's atmosphere extends past infinitely beyond
How
all
far
kinds of other
infinitely?
masses in a
Does anyone say it
vacuum.
extends infinitely?
Yeah.
Who? Who says
Okay,
the?
so where does it stop then?
It's hard to say. It depends on how you want to clarify it's stopping.
Okay, so you see what I'm saying? It's
Well,
just
no. You want to say so. Let's say an atom a helium atom escapes the upper atmosphere and goes off into space, and it's going out toward out. Well, now it's going to be in an orbit around the sun now because it doesn't have escape velocity to escape the sun. But now it's in the solar system. This one little particle, and it's on the other side of millions of years from now. That same particle is now on the other side of the sun. For our modeling, sun being the center and the Earth is rotating. So and Mars rotating around the sun. So our little molecule is like now on the side that Mars is on the other side too. Now, is that molecule part of our atmosphere? I mean, I would say not. I'd say there's some at some point we say the atmosphere is, it's we're releasing particles, but we're not. They're still orbiting, or still part of the Earth, and they're not going anywhere else. So that how far does that go? I don't think it goes past the moon. I think it doesn't go past the Lagrange point. I think it would probably be somewhere closer. Now, the exact number, where do you draw the line? How many particles does it have to be leaving the Earth for you to say that the atmosphere is going further than that point? You have to
yo,
set the limit.
yo, I almost fell asleep, bro. Chill out.
Yeah, well, trying to give
I
you information. I know you don't like information. That's why you fall asleep when it's given to you.
nah, I just don't like people pretending that they know stuff they don't. It's boring to me. But okay,
No,
cool.
I've given you all the high level information you need to make that discernment and that decision yourself. People say the atmosphere runs infinitely. You said it's illogical. I go, why? Because it's illogical. I go, okay, that sounds
I said
boring.
because it's the opposite of logic. If you don't see why it's illogical to claim that the Earth's atmosphere extends forever, I don't know what I can do for you.
Well, I
Because
don't
the
think
reason I'm not going into detail is because I'm trying to make the other point, which is you claim that the gravity of the Earth is holding down these gas particles or whatever,
yes.
which is a convention and a concept. No one's ever seen a
No, because we
gas
can weigh.
molecule, but
We
whatever.
see evidence of that by being able to weigh gas.
Okay, so actually, I have a downward electric current on the Earth, but so say that it would go into the vacuum, but the gravity of the Earth's holding it down. So I think in my mind, I'm like, that's an interesting claim. Let's test that. So if the gravity of the Earth is able to hold the gas pressure down to the Earth next to a vacuum, then it should definitely be able to hold the gas pressure down next to a weaker vacuum. And it should definitely be able to hold it down next to a weaker vacuum closer to the Earth because that's closer to the source of gravity that's holding it down. So then I put a shoebox of gas inside of a vacuum chamber, and when I take the lid off, it violently fills the vacuum. So a weaker vacuum with stronger gravity, and we don't see this mystical phenomena of gravity being held down by the vacuum. So that's perplexing, huh? I'm like 5 years in. I've never got a direct, specific rebuttal ever. Actually, I think I'm
We'll give you
7
one.
years
I'll
in.
give you one right now. I don't know why you muted me. Was I talking over you?
I didn't mute you.
Why
But
did
yeah,
you
you
mute me?
were. I mean, just assume you always
Yeah,
are.
dude. He couldn't even speak without you just jumping in every 2 seconds to think that you're correcting or controlling or whatever you're trying to do to the conversation.
Okay. Well, I thought I was making some points against. He said just a nip of it in the bud, but okay. Sorry about that. You can get it from me. I'll give you the answer right now. Why you think that the gas can be contained, and why, if we can hold all this atmosphere down by virtue of its weight, why does the top layers why are they able to fly off into space? Because you have to understand how these forces work, right? You got a weight of a molecule, and you have a velocity, and that velocity, if that isn't going in a certain direction and going fast enough, then it doesn't matter what the force, what its weight is compared to its velocity. It will escape the Earth's gravitational pull. That's the reason why it can leave the Earth. And you don't need to have, it doesn't matter whether there's a vacuum out there. It could be 0, it could be 10 to the minus 17, it could be 10 to the minus 10, 10 to the minus 5. It doesn't matter. that is not pulling anything. Vacuums do not do any work ever. It's always the force that acts on these objects. The force that they're bouncing off each other, the force caused by their weight, which is a force, and that has that's the reason for why we have hydrostatics and the laws of hydrostatics, and nothing behaves any different than we experience with those laws of hydrostatics and how it applies to the atmosphere.
So
fewer words, Anik, fewer words.
I feel like you didn't actually answer my question, and that's okay because I'm kind of used to it. Like I said, it's been 7 years now, and I've never gotten like a specific rebuttal. You weren't even answering anything that I said. I mean,
I thought I did. Why don't you
you
say
were
it
answering
again?
a question I mentioned like
How about you answer? You ask it
10 minutes ago
simpler,
or
and I'll
something.
answer
But
it simpler. Why don't you answer it? Ask it in like a sentence, and I'll answer it in a sentence.
if gravity of the Earth is holding gas pressure down next to a vacuum of space, then how come the gravity of the Earth doesn't hold gas pressure down next to a much weaker vacuum on the surface of the Earth where gravity is stronger?
I don't understand that last sentence. The question,
Mhm.
last question.
It's called cognitive dissonance.
Why doesn't gravity hold gases down to a much weaker vacuum? What do you mean by that?
You asked me to say it in a sentence, and I
I know,
found
but I
out
know
that
what you
with
mean by
ballers, I have
weaker
to say it
vacuum.
in like 4 sentences.
Where's the weaker vacuum? You mean the higher pressure?
If we replicate a vacuum on the Earth, it is
Oh,
nothing
okay.
compared to the vacuum of space.
Oh, I get it now. Okay, got it.
Do you agree that the gravity of the Earth is stronger at the surface than it is at the edge of space?
Slightly, not very much though, but
Okay, so if we have gas pressure sitting in a vacuum on the surface, how
Right.
can a weaker vacuum,
What's a weaker vacuum? What does that mean?
it has more pressure?
So we run the surface of the Earth, and you have a
Wait, what?
greater, higher pressure, which is a weaker vacuum. What does that mean?
Whatever you. Okay, see what I'm saying? Now you're
No,
diverting into
no,
semantical
I'm really not.
arguments.
What's it? I promise
It's been
you, I'm
7
really.
years, man.
No,
7
no,
years. You can't
I
bless
want
me with
so
an
bad.
answer after
I've
7
never
years.
been. I've never been more excited to answer a question for you, but I really don't understand what you're asking. I'm
You
not
haven't
trying to
answered.
divert. I really want to know what you mean. Can you use different words for a weaker vacuum so we can understand
Oh.
the question?
Okay. If we have a vacuum of 10 to the negative 17 torr in space, we have a gas
Okay.
pressure next to that vacuum of space, and somehow gravity is holding that gas pressure down beside
Yes.
that 10 to the negative 17 torr vacuum, then
Right.
how come where gravity is stronger at the surface of the Earth, it cannot hold gas pressure down next to a vacuum of 10 to the negative 6 torr?
So we make a vacuum on the surface of Earth, you're saying, of 10 to the minus 6. Why can't gravity keep the air from going into that vacuum? It's an easy question to answer, by the way, and I'll be able to do that for you. Is that the question?
That's the question.
Oh, okay. God, that's okay. Well, then I'm very happy that I'm able to answer the question after 7 years. So I'm going to do it very easily.
He's sitting up in his chair.
I know.
He's getting closer to his mic.
I did. Chewy. You're so funny. Exactly what I did. I prop myself up. I go, okay, here we go.
We heard you. Yeah, we heard it.
Did you? Did you hear it, or you just guessed I did that?
Are you just buying time, or are you just trying to decide how you're going to be a sophist here, or what are you doing?
No, because so now you have a pressure of what is 110 to the minus 5, and you have, which is basically 0, and you have a pressure of 14.7. So 14.7 is pounds per square inch. That's forcing it into that vacuum because the differential pressure between the vacuum and outside is about 14.7. Let's call it 14.6 to give you all the benefits that you need. We're talking about 10 to the minus something much more fractional than 10 to the minus 5. There's 14.6. So it has that force of 14.7 pushing into the air. Now, the air itself, the molecules of the air, each molecule has a weight, and that weight is proportional to that weight is its force. It's proportional to its mass, and the mass will give you the weight of that object in that gravitational field. And so that is very small. Now, it has a 14.7 psi force acting against it, and it only has a minuscule force of weight acting against 14.7 psi. So obviously, it can't overcome that. But up in space, its weight is now equal to the force of gravity.
Okay.
Right. So now
Good
that it's
try, I guess, but
its force is equal to the weight of gravity, and the vacuum is not. There's no difference because it isn't a vacuum. So there's no. So actually, it will now have a weight greater than the force that you're implying that was due to a vacuum. There's no force due to vacuum. All there is a force is what the pressure is at that level in space. I think it's a good way of answering your question. Down on the surface, a lot more pressure pushing it into the vacuum, and the gravity can't act against it in the downward. Obviously,
hold on. This is a too many words fallacy, and you also went twice. Like you said your thing, and then.
Well, I'm trying to think of the best way to explain it. So okay, I'll stop there.
I just made that up.
Empty words fallacy.
Too many.
That's not an empty word. I keep on thinking how you're going to take it. So, if the vacuum is open at the top, well, it's going to go down, right? So gravity is going down because that's going down, but that's not why it's going down. It's going down because there is pressure that is acting all directions, up and on the top, going into this container. Now you're saying that why doesn't hold on? I'm almost done. One sentence for the finish up. I promise. One sentence. The opening in the vacuum on the bottom. That's how I should have started this whole description. Open it on the bottom. There's still a 14.7 psi pushing it up. That 14.7 psi pressure going up is much higher than those molecules' weight going down, and that's why gravity can't work against the vacuum in your container. So I've answered it perfectly. Nobody can dispute that. I guarantee it.
Okay, calm down. So let's
I'm not
say
excited. I'm just giving you the answer.
Oh my god. Let's say that I have a container of gas, and it's really, really low gas pressure. But then I have an even lower gas pressure vacuum surrounding that box that has the gas pressure. When I take the box off, what happens to the gas pressure? Even though it's really low, not 14.7 psi. I never said that. Let's just say it's really low gas pressure, but there's an even lower vacuum outside of it. And I pull the lid off the box inside the vacuum chamber. What happens to it?
Okay, you asked it twice too, but you did say that before. You did say, why can't the gravity Earth keep that gas from not escaping that vacuum, or keeping the gas from going up into the container? Is what you said. So now you're saying that I have a very high vacuum next to a lesser vacuum. Now what happens when I open the chamber to the lesser vacuum with the moderate vacuum? Is that what you're saying now?
Sure.
Same reason.
What happens?
The higher pressure that's surrounding it will move into the lower pressure center. Why wouldn't it?
Wait. Would it
collisions
fill
are causing?
Would it fill the less full vacuum? Yes or no?
Will it fill it?
Yeah.
Well, yeah. Once you open a container, all molecules will interact.
Yeah.
So yes, they will. The pressure will neutralize because the outside pressure being higher than the inside being lower will interact and fill that space.
Let me give you an even better analogy. Say we build a really, really tall chamber, and we have a gradient of gas pressure. So we have 14.7 psi at the bottom, and then we can use like an electric current, kind of like we have on the Earth, which is why we have a gradient. By the way, you'll get there. So if we increase or if we decrease gas pressure in this gradient up higher and higher and higher in this container, and it's just a small like cube size container, and then we have a vacuum chamber outside of it, right? Whenever I pull the lid off of that really tall tower with a gradient, what will happen to the gas pressure inside of the cube?
Where do you have tell me what the pressures at the top, and tell me how tall it is.
It doesn't matter. You choose the numbers.
Okay. I've given this example many times where we have a 100-foot tall pressure in the top of this 100 foot. We had 100 foot. No, maybe it was 1,000 foot. Anyway, it was something. I think it was the number. If I remember the number is correct, it was like 14.3 versus 14.7 at the bottom. 14.3 at the top and 14.7 at the bottom. And we lay the whole thing on its side. What happens to the pressure inside?
Why are we putting it on the side? You're now hijacking.
Yeah, don't do
example.
that. You didn't say anything about the side.
Well, I was
hijacking
just giving my example how I dealt with
bullshit.
this a long time ago. But so what you're saying that it's 100 feet high. Let's say it's 14.3 at the top.
Yeah, and there's a vacuum around it, and I take the lid off the top of it. What will happen to the gas inside of it?
Where's the vacuum around it?
Say that it's right above it, but it connects to the cube. So I'll take the lid off, and then it'll be inside the vacuum.
Let me try. You have 100-foot. Let me try this real quick. You have 100-foot tube of air, and this whole thing is in a giant 500-foot tall vacuum chamber.
There we go. Now we're talking. Good way to clarify that. Good
Well,
job.
no, it's not the best analogy just because when it comes to the Earth, it's like above it. But whatever, it doesn't matter. Same principle applies, of course, regarding physics. So what happens to the gas pressure inside the gradient tube?
It'll be released into the vacuum, this 500-foot chamber. You've established a vacuum in there, and it'll have a gradient as well, but it'll be a very slight gradient, obviously. But it is a 10 to the minus 5 or 10 to the minus 10 gradient, whatever you have, this 500-foot container that's holding the 100-foot tall 14.3 top, 14.7 bottom. You open the top, and all the air rushes out because all those molecules are moving and having collisions at a magnitude of 14.7 psi, no matter where it is. So at the bottom and 14.3 at the top. And outside, I open the lid. That lid now being missing, there's no surface for that to bounce off. So all the molecules that want to hit that container are being released and hitting the container or other molecules in this partial vacuum. So it wasn't a perfect vacuum. And all these molecules, by statistics, will continue to bounce up and fly up the top of this container until it is neutralized.
Right. So what if we had 1 psi in the really tall gradient tower?
Overall?
Yeah, starts at 1 and then decreases to 0.8.
Okay.
And what happens when I take the lid off?
It'll still equalize.
Thank
Same
you,
thing.
Extremistus. See how easy that was to answer the questions, Danik? It took him 1 second.
No, I wanted to explain how it happens, and yes, you will equalize.
You're getting into too many details. Just give him the answer he wants.
Hold on, but not equalize, because it's not a pure vacuum outside. It has a gradient also, and it'll have the same exact gradient in that tube when you open it. Whatever the tube is inside that 500-foot vacuum, partial vacuum, whatever the gradient is in that partial vacuum, that tube will have the exact same gradient.
He wanted to hear it'll equalize. That's all you need to tell him.
Well, yeah, also, in addition to that, that's why I said, say that you have this really tall tube. Maybe I should draw it for you. You have this really tall tube with gas pressure in it. And then you have a bigger box that sits on top of it, like a Lego or something. Like you got a big box vacuum, and it sits on top of this like thin cube tower, right? So it's like its lid, but it's a little wider and taller, right? It's like it's a lid on it. And so then we have it like robotically set up. I press a button, and then the top slides off the thin tower on the bottom. Are you following me?
Mm-hmm.
Okay, what happens to that gas pressure inside the small tube?
Well, so according to hydrostatics, you still have this gradient, but when the vacuum above it is not according to the gradient of the distances above the ground and the pressure. So it'll all still have to equalize, but not as much as it did when it was around it, because now it's only above it. It's going to have a gradient. It's going to be based on what it should be for every foot upward and every what is it for air?
So it's going to fill the available space.
Well, not.
Yeah, thanks for playing, man.
Space? No, it only goes. It'll go up infinitely if this box is infinite. How tall is the box?
Just make it infinite.
Well, then it won't. It'll go as high as hydrostatics dictated for the weight of the air.
It'll fill the available space.
Because it doesn't continue to go up forever. So,
why not?
For example, sulfur hexafluoride. It only goes up a certain height in a column like that because it has a
just totally diverted so hard right now. That's crazy.
Well, no,
I wonder why.
You think just because you open a container into a vacuum that it's supposed to go up? It's not. It's going to stop.
It'll fill the vacuum.
No, it won't.
Yes, it will.
No, it won't.
Do you want to bet 10 grand on it, and then we'll go do it?
Absolutely.
Okay.
We could probably calculate how high that vacuum would go, how high the air in that container would go at. Is it 1 psi or are we talking 14.7 and 14.3? You changed gears on me there.
Okay, what are you saying that something different would happen for the two?
It'll continue. Yeah, if one's a 10 to the minus 5 or something, then it might go up, a couple 100,000 feet and then stop and not go up any higher.
Oh, it'll just stop, and then there'll be like a vacuum up above it, and the gas will just stop arbitrarily in the middle of it. Yeah, it keeps going. The vacuum is super tall. So you're saying that eventually the gas will go up in the vacuum and then stop at some arbitrary line, and then the gas will stop filling the available space. Is that your argument?
Because
Holy
that'll be the point where this one molecule, that one last molecule, has weight, won't go any higher than some height.
Oh, so your argument is about a finite amount of gas.
Yeah.
Whoa, you have a problem here then, don't you,
You
Xanax?
started with a finite amount of gas.
Yeah,
So what happens on the Earth? Is gas constantly being produced on the Earth?
Yes, but it's still, relatively finite.
Bro, it's constantly being produced, but it's relatively finite.
Yeah, any given time there's a finite amount.
Right now we have a finite amount. Tomorrow we'll have a different but finite amount.
No, in 5 seconds we have a different amount.
That's fine, but it's still finite in 5 seconds. It's
No,
not
good thing
infinite
we
at any
opened the lid up
point.
for more than 5 seconds then. So are you guys saying that the height that it goes will continue to increase as the amount of pressure it makes increases?
No.
Yeah, just
Why
pick
would it?
your intellectually eviscerated body up off the ground, throw your ball in the trash, it's going to be okay. And surely you understand the implications of this, because even your own logical mind knows what would happen.
I mean, if you're continually making gas and there is some sort of container, solid container, is there?
What's up?
If there is some sort of solid container and you continually make gas at the surface, it's always being generated. If it's not being lost somehow, if it doesn't escape the container in some way, then the pressure would continually increase. I mean, I guess you could say it's sort of recycled, I guess, maybe.
Well, go back. You talk about diverting, and I understand where he's going with. If you think about it, if we had a container applying all gas laws and hydrostatics, the pressure in the container should be equal everywhere. Should be equal, even if it's being produced in a slight amount at the surface.
Oh, you're going to divert to weight.
It doesn't. Air has weight. We can measure the weight.
You're going to divert to weight.
It's just logical to assume that all this weight is a bias downward because it does have weight. That's the reason we can weigh gas in a container. How do you think we can weigh gas in a scuba tank? Why do you think we can weigh 10 or 15 pounds of air in that scuba tank?
Because it has weight.
Okay. And why does it pile at the bottom? Why is it not uniform in the container?
Why does it pile at the bottom?
Yeah.
Is that what it does?
Well, how do you weigh it?
That's a great question, man.
What's the mechanism for where the air molecules that are not liquid are communicating with the container in such a way that it has more weight? Can you tell me how that works?
We have a downward bias on the Earth.
No, but how's the air molecules? If they're going in all directions, how is that container with air in it suddenly able to be being weighed on a scale? How is it communicating the weight to the scale?
You're saying if I put a box on the scale and I put some air in it, it'll weigh more?
Absolutely.
Yeah. And you're asking me why, and downward bias wasn't the answer to you?
What do you mean, can you explain what downward bias means?
Oh. You didn't know we had a downward bias on the Earth?
Well, I know it. I think I know what you're saying, but I want you to tell me what it says in better words.
Why?
There's a gradient. I think that's what he's looking for.
You tell me there's a gradient in that container?
No, that's not what's being said. Things tend towards a certain direction. Orientation is what I'm hearing. Maybe you could stop playing stupid, Xanac.
No, he says there's a downward bias. Would you be willing to agree that the velocity of the molecules is greater going down? Is that the bias you're talking?
Seemingly there is an electric current down to the ground, so it is certainly logical.
I asked the question. It's yes or no answer.
I already answered it.
No, you said you said voltage.
He said yes.
Yeah.
No, he didn't say yes. I'm saying, I'm asking you if you think
Extremism is faster than you, man.
The velocity of those molecules is faster downward. Is that safe to say for your explanation?
Sure. The one thing for sure though is that
good.
No one's ever seen a gas molecule anywhere. So we're just using a convention of gas molecules in the ideal gas law, which assumes infinite, which is just a really cool story, bro. But sure, for intents and purposes, if we want to take all these
We're actually not using the ideal gas law at all, because it's not an ideal gas. Number one. Number two, you've already conceded, and everyone heard it. You said that you would say, we have a higher velocity downward. So if you have a higher
But I don't
velocity downward,
believe in little gas molecules. Can you?
it doesn't matter what caused it. The point is you have a higher velocity downward, so that impact on the ground, on the bottom, will be more numerous and with a higher force. That higher force only on the bottom, any surface that reacts at the bottom will give it more weight. That container will weigh more because the force is greater on the bottom of the container because those velocities are greater going down.
Yeah,
They're
but that's
downward bias.
yeah, dude, you don't get it though. You don't get it.
do
It
get
doesn't
that.
contain it down. It doesn't prevent it from going somewhere else. It's just that when it goes in the direction of down, it's going in the direction of the downward electric current, so it has slightly more force. Okay.
Why would it
So
have more force if it's not going faster?
it can go faster. That doesn't change it.
Oh, you're saying it's caused by electric current, though.
You think I
That's
just
okay.
said that it has more force, but it goes slower? You understand the difference in
No,
what I'm saying and what you're saying is mine's actual real physics, whereas you're claiming that the gas
Mine's not
is
actual physics, really.
no, because you're claiming the gas is prevented from going up.
No, I didn't say prevent it from going up. It goes up. It goes in all directions. It just goes faster going down. And the impact, because every impact is a change in momentum, which is defined as a force, is greater on the bottom. So it
Okay, but this
registers
is what you
on the
don't
scale.
get. This is the problem for you, right? What I'm talking about can be proven,
But I'm
right?
talking
Like
about
we can
controlling
actually
also.
prove the downward electric current. We can prove it's super weak, right? And we can prove that, of course, if you had downward current, then you had extra force, then you're going to have an increase in velocity. Of course, overall, the elastic velocity of the gas can overcome this very slight downward force. So when we put this next to a vacuum, that slight downward bias is not going to prevent the elastic velocity of that gas from filling the
Not
available
elastic
space.
velocity. That's a made-up word term.
It's a made-up word.
Yeah, there's no such thing as elastic velocity. You're just making up shit now.
What's it called?
There's elastic
Elastic velocity. What does that mean? How are you using that term?
Yeah, that's what it's called. Like, it's an encounter of kinetic energy.
What encounter of a kinetic energy? What the hell are you saying
I thought
now?
gas had what does gas not have elastic velocity?
No.
Potential, resistance, potential.
Anyone in
Same
physics
thing.
before.
Or just a collision?
There's elastic
No, there's elastic collisions. Yes, I've heard that
Okay,
term.
whatever. Elastic collisions which result in velocity.
That I accept.
Okay, cool. So let's get back to the actual point instead of diverting to the word because you can't respond to the argument.
Hold on. The elastic collision results in a non-elastic velocity, if you want to use your words. But no, the velocity doesn't change because that's what elastic means. There's a change of direction with no loss of momentum. So the velocity,
Okay, nice. Complete total non sequitur to what I'm saying.
Velocity doesn't change. No, you
Hey,
brought
buddy,
up elastic velocity.
Stop trying to play fucking semantic fucking games, Xanax.
Yeah, because they
elastic
cannot
velocity. I
rebut
don't know
what
what
I
he
just
means.
said, dude. It is so bulletproof that it cannot be
You know what? I'll
rebutted.
give up right now. If you say that was just a semantic mistake, we'll move
Already
on.
did. I see. I know it's foreign to you, but I'm just
It
intellectually
is foreign
honest.
to me. I don't like when you make up shit.
No, I immediately said, "Oh, is it actually called this? My bad."
Oh, you didn't say that, but okay, you said something about.
I did though.
Yes, he did.
Okay, Extremistus, did you hear that?
Extremistus said
After a couple of sentences, he did say that it was an elastic collision. He meant to use that term instead.
He said elastic velocity, and he said collisions. He said the word collisions by itself. I don't care.
I knew what he meant.
I give up.
Calm down.
You win. I'll take it as a misspeak. No problem. Okay, elastic collisions. Yes,
Dude,
we have
imagine if I
elastic.
did this to you every time. Oh my god,
No,
we'd be here
I'm not
forever.
trying to fight with you. I'm not trying to be pedantic at all. I
No,
took it
you
back.
actually are doing everything in your power to
I thought you were
prevent
serious
yourself
about-
from responding to my point.
I'm trying to understand your ideas, and I thought that it was some type of new idea, but if you just misspoke, I'm totally over that. Elastic collisions, got it.
The elastic collisions of the gas result in a velocity much stronger than the slight downward bias from the downward electric current, which would introduce an additional downward force, which would increase the velocity towards the ground, but would not be strong enough to prevent it from filling the available space next to a vacuum. The only difference is I can actually scientifically verify, measure, and prove the very thing that I'm talking about, whereas you cannot, and you need something stronger that's going to hold it down next to a vacuum. Your turn.
No, I think I agree with everything you say, other than what the cause of that is. But yes, that's why the velocities are greater going down. That contains it because those forces, when they interact with each other, are going to be aggressive as you go down because there's more of them. That's why the pressure is high at the bottom, but it's all contained by the velocity that are greater, all of them going downward. And if there's more of them, there's a higher pressure. There's less of them, less pressure. I don't think it's caused by voltage, but I don't care what causes it. That's not my realm. I don't really care. I mean, I truly don't care what causes it, whether it's gravity or something magical.
You
But
don't
all I care
care.
about is
All your
hydrostatics is
little
real. Hydrostatics is real,
Bro.
and that's how it works. And
This is what you don't
that's
get,
why it
Zanuck.
doesn't
You're
go into
just
the vacuum.
skating
You
past
said
my
it.
point.
You
Bro.
actually
So
hold on. I'm still talking, and I agree with you. That's why it doesn't go into the vacuum. You just said why, because it has a higher velocity.
no, I didn't say that. I
Current.
said the difference in what I'm saying and what you're saying is I know that would not prevent it from filling the available space in a vacuum,
Oh,
whereas
okay.
you
So we
need to
already
invoke something additional. So step one is you need to actually substantiate what else you're invoking because mine can be scientifically verified and
so can mine.
measured. Yours cannot.
Oh, it
Okay.
absolutely can be. So
No,
can
no,
absolutely.
no.
Yes.
Secondly, okay, I know that you have to have that container to weigh the gas. I know that if you put the gas beside the vacuum, although there are very weak, slight downward bias, right, of that current, it would not prevent the gas from filling the available space at all. Okay, now you're claiming it would, and you're claiming an additional mechanism. You need to verify it.
I just told you how we verified it.
Yeah, I can still jump up, Zanuck. Gravity's not strong enough to always keep
No,
me
you just
down.
applied more force to the ground than gravity provides on the way down.
Let me-
So when you exceed it, but you still have a
Same
deceleration.
as the little gases.
Same as the
bouncing
gas.
around.
Don, you were
Exactly.
muted
Same as the
for a
gas.
reason.
Wow.
Don,
Same
when
as
you
the
jump,
gas, Zanuck. Do you not get
as
it?
soon as you leave the ground, Don, you have a downward acceleration. As soon as you leave the ground.
No, but you not get it? Well, whenever you jump up, you introduce more energy, so then you're able to go up. It's the same as the gas, right?
How
Because
are you
we can actually measure. We know how much downward force there is in my understanding, which is actual science.
How did
You're
you
making a
generate more energy?
totally. You're claiming there's something else there other than the downward electric current. In fact, most of you guys deny that it exists, which is hilarious because your own paradigm knows it exists, right? So
Well,
let me read it for you.
electric
Another
current
thing that can be measured in addition to the potential gradient is the
All right.
current in the atmosphere. The current density is small, about 10 microamps across each square meter parallel to the Earth.
That's not enough power.
The air is evidently not a perfect insulator, and because of this conductivity, a small current caused by the electric field we have just been describing passes from the sky down to the Earth.
Okay, so why don't we have I squared R losses, number one? Number two, why don't we have the energy that is required to lift a mass 10 inches or a foot or a meter, let's say a meter, jump a meter, we can calculate how much energy is required to do that. That current you just talked about, this per foot, per meter, is not great enough. The current flow through the resistance, the I squared R or the volts times the amps, whatever you want to use, is not great enough energy to account for the motion, the movement of that mass, whatever it is, on the quantum scale, to jump a meter. You said it comes from the voltage by jumping up. You said he's storing kinetic energy. You can't store kinetic energy, and kinetic energy is the motion of mass. Potential
Now, I
energy
know it
would
would
be,
take some people that are pretty good and veteran at debating, but some of you guys may have spotted it. That was where Zanuck fully imploded. And I know that maybe someone didn't catch it.
really. You said that
Oh
there's
yeah, dude.
You can't.
Oh yeah, dude.
You
I
have
know
a
you like the
problem with
back of my hand,
traditional
dude. I can
terms.
basically make a movie about what you're gonna do before you do it.
You should make the movie.
I can make a
Because what I'm talking
cartoon Zanuck
basic
character.
colloquial.
The
Don,
categorization and terming of phenomenon is your issue, Zanuck. You're cookie cutter unflexibility, man. You should be more flexible. You'll be able to hear better.
He said it was a small current and a voltage, which is 100 volts per meter as you go up.
I didn't even say
and I
that.
said, fine, if there's a volt and air has very low resistance, as he said, then that current should flow through the resistance much higher. If 100 volts is going through a tenth of an ohm, what would the current have to be? Do we see that current flowing? No, we don't. Why don't we? And if we don't, how do you account for this energy, this potential energy that is converted to kinetic energy as you leave the ground, go up, decelerate as you go up, and decelerate as you go down, and re-impact the ground with force? And there's a noise, and there's heat generated, etc. Where did all that energy come from? You already told us that it's very minute. So where did the energy come from?
Okay. So listen carefully. What I told you was that I'm invoking something that can be actually scientifically demonstrated and verified, and that you were making a claim additional to that, and that I needed you to verify it. Your rebuttal was not to deny that what I said was there. It was to try to critique what was there and still not substantiate what you're claiming's there. So it's called a shifting the burden of proof fallacy, a red herring fallacy,
That's not true.
obfuscation / empty words fallacy. I will help you out here, okay? It just gives you the downward bias, okay? It sets the up and down. It's a very, very weak downward current that goes from the sky down to the earth. This is what sets the up and down. It sets the directionality, right? Now, will it affect things slightly like gas? Sure, right? But the gas will overcome it, just like a buoyant force will overcome it, just like any additional force. It's very, very weak. It's significantly less than a single amp, right? It's a micro amp. So it's very, very weak. You understand? Now, if you're claiming that something else is there, right? Before we get ahead of ourselves, before you start to tell me about how you don't understand it, we need to establish some type of alternative that you're claiming. I've established mine. Mine's measurable, testable, provable. So if you could please establish whatever else you're claiming is there, then we could go to the next step, right? So we can
Sure.
be
It's not a problem.
scientific.
We've already gone here many times. What you said makes little sense to me, and I'm sure it doesn't make anybody else. But you seem to have a lot of confidence in being concrete evidence that we don't have that you've just described. And I would just debate this nonstop forever because you just aren't getting it. That's it. But that's okay. We have evidence. The evidence is it has a velocity down, and if you're talking about the cause, with there being like electrical potential voltages and micro amps that show. You said this before. I remember hearing you talk about this. It just establishes a bias, and after the bias is established, that's the direction it will travel. I mean, what if it's laterally? I mean, suddenly if there's a bias going laterally, it'll go off into horizontally forever? No, it doesn't work that way. It's always going to go downward. You can't get things to go upward with any kind of voltage. Even if you had some type of your this electron generator or your Van de Graaff generator, whatever you got infinitely large, you couldn't levitate things or even impart this directionality where things would go that way, definitely based on the voltage existing in the atmosphere. I mean, this is all just kind of made up. And we do have evidence. We have a lot of evidence for what we're talking about. I've given you
Just
the
hand wave
basics.
dismissal, man.
Not hand wave. I'm just telling you, I don't see it. I asked you if now showing just the directionality itself allows you which way things are going to fall. But the reason they fall is what? What is the reason that they continue to fall that direction? If it's not this micro small voltage that doesn't really have a chance
Yeah,
to
it
do anything,
literally
you have
is.
to
So.
set the directionality.
Yeah, it is actually. So, when an object is more dense than the medium is surrounded in, it will go down. The question is, why is there a downward bias, and what sets the up and down? Of course, on a plane, there's an objective up and down. What sets the up and down is the difference in potential. Thus, we have a downward current going from the sky to the ground, setting the up and down, creating a very weak, slight, almost negligible downward bias. Now we have the object's density relative to the density of the medium, and this will determine directionality additionally. In order to manipulate the vector simply based on the electric potential, you would have to drastically manipulate electrostatics. In fact, flip the polarity of the entire field, which is impossible on its face when it comes to the Earth. So then we have to ask ourselves, what is density? What causes density? Layman terms, density is compactness of matter. Okay, well, what gives it matter? Its compactness. Well, first we have to see what holds matter together. Intermolecular attractive forces. Okay, well, what are those? Well, they're electrostatic. Okay, well, what is weight? Okay, weight is the effect of that object going down based on its mass, based on its density, and these other variables. Well, that's convenient because all of these things are intrinsically electrostatic. So we've substantiated that it's a very electric, it's an
Hold a second.
electric phenomena. How do you understand this?
Yeah, I got it all. My question is, so what is weight? This is the downward bias. And then you said something about going downward. It can be static. A weight can sit on a scale and register a force. You're saying that what's causing that? If the electrostatics are so slight, and yes, I have no problem accepting everything you said about what makes mass. Why is it what's holding it together? Fine. That's going back to the argument that I've already shot down many times, saying that just because you went in your Van de Graaff generator, got paint chips to float, and normally they're not floating, and now you're making them float, and when you remove the Van de Graaff generator, it falls. So therefore, because electrostatics made it float, therefore they're falling due to electrostatics. I mean, do you understand what that? We all think that's a stretch.
Because you're religious, but
Okay, really? That's
yeah,
logic?
I get that we
Is
have
that
a
logic
huge
that
disconnect
makes you
here,
think that way?
Zanik, right? Because I think for myself. So like no one else has formulated my stance. If someone else holds my stance, it's very likely they maybe heard it from me because I made it up. Okay, this
Yeah, it
is
sounds like
my
you made it up, actually.
Zanik. I know that as soon as I say that, you think, "Oh, you're such an idiot. Of course, you're just making up." No, no, no. See, this is how people that are free thinkers operate, right? And this is
No,
the only way we
you're
have
really
any
intelligent.
discoveries
You're an
in the
intelligent guy.
entire
You just
history of
you
mankind.
say
You know who
stupid things.
never discovered anything? The people that ran around and stuck their chest out about the current theory and how well they can remember it. Okay, the people that
Yep.
actually made progress were the people that found the holes in the current theories, pointed them out, and then
I think
replaced
those
them with a
holes.
more viable theory. All right,
Okay,
so
I
I don't
think
care that
here,
we don't
stop.
agree. Okay, I take pride in the
I
fact
get
that
it.
I
I
think
know
for
you don't.
myself.
Okay, can I say something real quick?
We'll
I think
stop
it's
with the
noble.
little.
I think it's noble that you're taking this on. I think there's nothing wrong. There's nothing. Can you hear me? There's nothing
Yeah.
wrong with what you're doing. The problem is you're ignoring a lot of established physics, but you don't agree with any of this stuff. If you think it's all indoctrination, that's fine. I think it's great that you're going after this stuff, but you have to make an attempt yourself to understand certain things. We had a little discussion about the focal pendulum,
Zanik,
the IV thing.
you think
I
putting
don't know whether you got
mercury
that
in
or
a
not, but
tube tells you
you had a
how high
misunderstanding
you're
about how
going?
that worked, and now I think you understand how it works maybe a little better. It's okay that you're going after it this way, but and it's not that you're not intelligent. You're a highly intelligent individual, but you're just taking you take so much out of context. You don't think things through the way because you're so hell bent on proving the world wrong and you being right. And I don't think you understand how it seems to people that actually have used these concepts in real life.
You should be more specific,
You're doing
Xanax. Come
exactly
on with
that.
the general attack.
No, I
That's
understand.
Xanax, come
exactly what
on, man.
Xanix's doing right now. That's exactly what you're doing,
They don't
Xanix.
disappoint us in the
Because
avionics.
you
They
cannot
don't disappoint us in
demonstrate
aviation.
how
They
rubbing
don't
a pill.
disappoint us in the
Listen,
wind tunnel. They don't disappoint us
listen. Rub
even in
your
looking at
barometric.
the simplest aspect of what I've combated you with, and that was effective. Great, electrostatics, forces,
You
bias,
didn't
blah blah blah.
demonstrate anything.
Why is it
You
that an
demonstrated
object
nothing.
falls
You
with
didn't
a rate of
demonstrate
Here
anything
we
about a
acceleration?
go.
ball.
We're going
No,
back to free fall. We're going back to this.
why? Yeah, exactly. Why is it in free fall?
Can you
What
stop
do you
talking
expect?
for a second,
If it's
Xanix?
electrostatics, every part of that body would be pulled at a different rate.
That's not how it works,
They
dude.
are.
It's been said so many times, man.
Hold up,
You can,
but what's it? Even his model agrees with that, and you're
got
fucking full of
Bro,
shit.
I got Johnny
That's what happens
backing
in
me. I got
reality, Xanax.
Mr. Brandon.
Everything is pulled
I
at a
can't
different
finish the
rate.
sentence.
Every piece of your body is a millimeter higher than the other piece. Therefore, the fucking rate of gravity is fucking different in your model, Xanax. You're a fucking
He
joke,
doesn't
dude.
have a model.
Look, man.
Don,
Look.
he doesn't have a model. He hasn't dropped his barometric little pill. His little pill, his
You
barometric
didn't hear
pill
anything
with
I said,
mercury in it.
Don.
He hasn't dropped it around the sphere for us, right? When does
I
he
just
drop
hear
it
him
around the sphere
misquote
and show us
Witsit,
how his
man.
elevation works or his barometric pressure around the sphere when he takes it from the top and rolls it around it for us?
Before we
Especially
attack
a
the whole
sphere that's
model,
real
though,
big.
and everything Zanuck has ever said and
There is no
everything,
model.
between Witsit, but between these two, Zanuck's to a point a little bit more of a concession. Oh, Witsit, you're intelligent now, but this and that. But then Zanuck, you'll sit there and be like, you say he doesn't understand reference frames because you're the one that can't hear him when he explains it
Did
to you.
hear him.
Have y'all saw that yet?
Don,
That's what
Witsit,
a
have you been able to
demonstration's
tell
for,
Zanuck
Don.
how he misquotes you
So we
yet?
stop imagining.
Don, can I explain what I meant by that when I talked? He doesn't understand the pendulum or reference frames. We talked about we talked about the focal pendulum not swinging.
all right, dude. Now
Because
I'm checking
saying
out.
that
I'm
you're
going to work on my logo.
Don,
See, Witsit, he gonna do this to you, man. I'm not trying
for a
to.
second, Don.
He gonna misquote you, man. Just clear this up with him.
Don, he made a statement.
Dude.
Within 5 seconds,
Yeah.
explain it to you, real quick, right?
No, we've explained it before. It needs to be explained to you, and you don't want to
Doesn't
hear. All that
Earth
needs
is
to be
rotate
explained to
underneath
you
the
is
pendulum,
what
even if it's not
you're
moving.
missing from
Okay, I
Witsit.
can't. This is what happened last time, and I got muted for 2 days because of you. I'm not going to fight with you anymore.
I'm just going to mute Zanuck while he talks. Okay. Yeah. I don't want to hear you talk about that, man. I don't want to hear you talk about it. right? Like, all I'm trying to say is you've done everything in the world other than addressing what I'm saying. The Globers still don't understand my position. If they were able to articulate something I felt actually refuted it, I would update my position. I actually welcome it. The problem is that all you do is strawman it. You think that we're talking about an electrostatic force that is an attractive force pulling things down, and there are varying strengths of attraction relative to altitude and all this bullshit. And I've corrected you a million times. There is not some like homogeneous attractive force. That's just what your paradigm has brainwashed you into thinking what's happening on the Earth. The truth is that there's just a downward electric bias. If I put an object on the scale and I weigh it, okay, it's going to give me a weight. Cool. Now, if I put a helium balloon on top of that scale, what's the weight? What's the scale going to weigh? What's the scale going to read? Obviously nothing. Obviously nothing. Okay, so the point is we need to define weight.
Less than
Because
nothing,
obviously to get it to go down and put downward pressure onto a scale, it has to go down. So what we have to do is address every variable that causes an object to go down and give it what we call weight.
Including the buoyant force of the air?
Yeah.
Oh, yeah. So a helium balloon in a vacuum might actually make the weight.
Right. You see how you're surprised by his answer there? That's the only point I was trying to make. I wasn't trying to rehash the old issue, but bring up the issue that Zanuck needs to pay better attention to Witset's side of it. Because Zanuck makes assumptions that Witset doesn't understand things that he does because he says it the way he says it or whatever, and Zanuck does his thing. That's it. And it's happening again right now, Zanuck. Listen to his side.
What he said, Don. It's what he said. I took it very clearly, argued a little bit. I gave him the rebuttal and the correction. He can take with it what he wants. But I fixed it. I understand what he was going with it. He didn't understand that the angular momentum
You
was
fixed it with why do things free fall weightless? That's your fix. That's it.
Maybe I can get Matthew. Maybe Matthew can help me out here. Matthew, do you agree that there's a downward electric current on the Earth?
No.
Okay. I'm going to read it one more time. Room, forgive me. This is Richard Feynman's lecture on atmospheric electricity. Another thing that can be measured in addition to the potential gradient is the current in the atmosphere. The current density is small, about 10 microamps crosses each square meter parallel to the Earth. The air is evidently not a perfect insulator, and because of this conductivity, a small current caused by the electric field we have just been describing passes from the sky down to the Earth.
But the electrons would be going up.
You got anything other than just like a blatant diversion and reification of particles? Is there a measurable downward current? Yes or no?
Does Matthew have a response to the Feynman thing?
I guess I would believe Feynman. I don't know much about this. If there's a tiny current, then if he said there's a tiny current, I'm inclined to believe that there is.
Well, you just said no. That was your initial response. You said no.
Yeah, my initial response was no, I don't think so. But
So now, since you read Richard Feynman, now you say yes? It's that quick?
Oh, yeah, I believe Feynman.
So you just believe people rather than the idea? The actual
Yeah, I certainly do. When I don't know something about something, I'll trust the experts.
Okay, so if Feynman said the Earth is flat, you would just say that's it, it's flat?
Oh, in that case, I wouldn't consider him an expert.
We can move on. You've changed your answer from no to yes, so I guess we can move to the next step.
Well, I've measured that voltage. It's there.
Hey, Matthew, will you ever believe something I say?
Yes, if you say true things, I'll believe it.
Okay. Thanks,
Oh my God! If you know it's true already, you can't. You're not believing him. You're not. But you're believing what you already know, not him.
Sure,
My friend Matthew. Yep.
Anyway, I'm sorry. Go ahead, Zanuck.
Oh, well, okay. So here's the point, man. So the question is, like, what causes things to go down, right? Or like, what gives them weight? I'm just like trying to take a scientific approach, right? Like, luckily, I have stepped outside of this like heliocentric paradigm where I'm forced to believe all things that are current science, even when we know they're not right, but well, they're good enough for now. I don't exist in that paradigm. So I don't need to explain all kinds of fairy tales that come with it, right? So I'm just trying to look at it from a scientific approach. Like, what can we actually verify is here? We can verify that downward electric current's here. We can verify that all objects go up and down relative to their density relationship, and that density is compactness of matter. And the way that a piece of matter has compactness is electrostatic intermolecular bonds or forces. So I know there's something called electrostatic induction that can cause objects to go up or down. And so this creates that downward bias. And then the relationship between the object and the medium causes it to go up or down via a buoyant force. Okay. And this is all intrinsically electrostatic. So really what I see based on all the observations and evidence is that weight is vector specific, medium specific, coherency specific, seemingly on the Earth even location specific. And so I would have to factor all these in, not just the idea of mg, which mass being volume times density. We come back to what gives the matter the compactness of matter and what holds it together within a certain volume. Well, we know what holds it together are intermolecular attractive forces that are electrostatic. So mass is intrinsically electrostatic, hence why we have mass to charge ratio with mass spectroscopy or spectrometry. So now when we see this, we're like, okay, we know that this is a prominent variable in the phenomena, right? So if we're claiming it's something else, because once I manipulate electrostatics, I can change its weight, I can change an object's weight, I can change how fast it falls, I can make things levitate, and I can make things go up in the air. And I didn't add a variable that wasn't previously there, because electrostatics is always there. I just manipulated what was there. And all objects that fall down fall within this downward current towards the Earth. So if there is something else there that's going on, like the globe Earth claims, then I need some actual scientific evidence I can also test before I just blindly believe that somehow all the stuff I can test isn't the actual answer. There's something else there that I can't test that is the answer. You see my point here?
Yeah, my impression is that electrostatics and electrical phenomena are well known. And so it seems like you should be able to calculate how much force that makes. But it also seems like there's not enough current if it's like micro amps or whatever you said to account for the forces we see. That'd be one question. I don't, again, I'm disclaimer, I don't know anything about this. I'm just guessing that we should be able to calculate how much force it would be. And then second, an interesting experiment would be if you put a helium balloon in a vacuum chamber, could you weigh it? Would it have weight?
Would a balloon have weight in a vacuum chamber?
Yes. Yes, it does have weight.
Yeah, why would it not? See, that doesn't rebut my position. My position is
a helium balloon would go down in a vacuum chamber. Right?
So what's that matter?
It would show that helium has weight to it.
Oh well, but what's that? Is that a rebuttal to me or what am I missing?
You were saying that helium always goes up, or did you say it always goes up, or would you say it would go down in a vacuum chamber?
It goes down in a vacuum.
Okay, then never mind. I was thinking that was something that might distinguish between the two positions, but you would have the same position about that.
And Jesse, you think you got me right here with the field is not vertically oriented near trees and stuff like that, like the diagram shows. That's right. If you have a mass that's on the Earth, then the field orientation changes relative to that object or matter or person or house or whatever that's on the Earth, right? So if I drop something and it slightly moves towards that object, you guys would claim that mass attracts mass, when in fact what science shows us is that there is a field orientation relative to whatever object is connected to the Earth. So that point actually allows me to just rip from your dying grasp any notion of mass attracting mass. So what I need is physical, scientific evidence verifying an alternative position, which currently is that it's the bending and warping of space-time.
But let's say I were to take up some chicken mesh wire, like metal screen, cover 100 square foot area of the ground, make that even 1,000 square feet of area. I put it 10 feet up, well, actually 3 meters. I put minus 300 volts on it. I'll have negative 100 volts per meter underneath this chicken screen roof I've strung up. Why would that not reverse the direction of gravity or whatever it is, if I've completely reversed the electrostatic field.
Yeah, I don't get why you people don't understand this. It's so crazy.
I mean,
So,
if that
like,
sets the bias,
yeah, it does. The Earth has an overall bias, and the fact that you
You
manipulated
people
a small
just
portion of it on the ground doesn't change anything. And what actually causes it to go down is the density of the object relative to the density of the medium, which is also intrinsically electrostatic. And it's going to seek its equilibrium going to the ground.
so is there a gradient of 100 volts per meter inside the ground also?
Why does
If
that?
I
What?
Is there also a 100 volts per meter gradient under the surface of the ground?
Why would there need to be?
Well, what I'm trying to understand is why if there's no gradient underneath the ground, and I can 100% reverse the gradient direction
You can't.
above the ground, well, every electrostatic voltmeter would tell me I had reversed it.
Yeah, but just in a small area. Did you reverse the field of the Earth?
What does it matter if I've reversed it inside my test area?
Because it's still going down to the ground. There's still an overall up and down set. All the downward current of the Earth does, which you can never flip entirely. You can never flip the polarity of it.
The net force.
Yeah, it just sets the up. Well, it just sets the up and down overall on the Earth. It's just like if I have a Van de Graaff generator. In order for me to make something go up, I have to flip the polarity of that entire region. As it applied to the Earth, the entire region is the Earth. Okay,
So-
you can't do that.
So the voltage gradient outside my Faraday cage sets the bias, the direction for my weight inside the cage?
Here's what a good test would be: is if you flip it with a strong enough polarity flip, because you're within this all-encompassing field of the Earth. Then weigh objects within that test area and see if they weigh slightly less. And once they do, you guys will come up with a bullshit excuse of how somehow, yeah, they do, and yeah, it does match your theory perfectly, but no, it's just a force overcoming the force that I get to beg the question of as I try to be super critical of your claim and don't substantiate mine at all. That's what would happen.
So how would I know if it did match your theory exactly?
Wait. Do you think that the object's weight would change slightly if you flip the polarity of the field around it?
I think electrostatic attraction would attract the weight to the ceiling, but it would add that amount of weight to the ceiling. So it's just an attractive force, just like a big rubber band or something. There's no actual reversal or loss of gravity or
So
weight.
you built a ceiling in your example here?
Now, I referred to earlier as a Faraday cage and a chicken mesh wire for chickens.
Okay. And so this is how you know gravity's here?
Well,
You not see the problem?
Well, I'm looking for ways to test your claim.
But you're not looking for ways to test your claim.
I tested my claim.
No, you
It
didn't.
seemed to hold up. I
You
eliminated.
just assumed your claim. You just assumed it. Because I've been asking for weeks now. Can any of you guys give me a test? You never say anything. Your rebuttal is always, well, yours can't be right. And the truth is, it can be right. You just admitted that if I flip the polarity of the field, it will change the weight. Okay.
Not
So
the
if I
total
flip
weight.
What?
No, I'm not saying that it would change the total weight. I'm saying that the sum of the weight of the test weight and the ceiling would still remain the same.
Oh, that's just this little squirmy way out of the fact that if I put something on a scale and I flip the polarity around it, that what the scale reads will be less. Because as it applies to the Earth, how do we know what weight is being added or isn't being added to the surface of the Earth or to whatever surface is above us?
So how would I test your claim, or is it untestable?
Well, how would I test your claim, or is it untestable?
I asked you first.
Yeah, see, because dude, we'll sit here for 5 years and you won't answer my question. See, the truth is, the way that you could test it is you would manipulate electrostatics and see if it can actually change the variable of vector. That's what you would do. The way that you test it is you physically manipulate the variable to see if it changes weight, downward accelerative rate, and direction. We can test that and prove that. Now, when I ask you, how can I test your claim? You won't say anything. And much less have you done it yourself.
I already explained to you. I told you how I did a little Cavendish, how I eliminated static electricity, and how I eliminated everything I could figure out how to eliminate, such as magnetic influence and electrostatic influence and winds and heat, and the attraction was still strangely there.
Yeah. So if there is potential field in your demonstration, even though you tried to control it the best you could, and then there's an object in that field, what will the object in the field do to the field? What will the field do relative to that object?
So, and here's the problem, is in reality, which I've tried to explain this to you before, but I think it slipped your mind. In reality, when we build a Faraday cage and we put an electrostatic voltmeter inside that Faraday cage, it reads 0. We can put enormous voltage fields outside that cage, and the meter still reads 0.
Actually, you can get much more sensitive meters that don't read 0. Do you want to bet on it?
But you can still put a large magnetic or electrostatic field outside, and the Faraday cage still shields that meter from that large outside change.
Wait. You're just going to skate past it? Do you see how every baller has a common theme? They make a claim. It gets directly refuted.
He didn't skip past it.
It gets directly refuted. And then the rebuttal is to skip past it. So when you said that you can take a meter and record 0, and then I corrected you and said, actually, if you get a more sensitive one, it won't be 0. Would you like to admit that you're going to stop saying it's 0 because you know it's not actually 0?
On average, it's 0, and that's what I told you before. If other than meter error itself, on average, it's 0.
You want to bet on this?
Yes.
Okay, so you want to bet that if I get a super sensitive meter, that I won't consistently read something on the meter? It'll be 0?
If you put it in a 100% coverage Faraday cage, that means no gaps, all metal, all the same metal, and you average the readings, and there's no error offset in the meter itself, then they will average to 0.
Average to 0 meaning that we're going to get negative readings?
Yeah, if you're shuffling it around in there, you could be creating static electricity inside there with the meter somehow, but it's going to be, sometimes it's going to be positive, sometimes it's going to be negative, and if you average it out, then it's going to go to 0.
We're going to get negative amount of electricity?
That just means reverse polarity. Have you ever hooked a voltmeter up to the battery back?
Oh, so we never eliminated electricity the entire situation, and you're just trying to say that you can get it neutral. You didn't actually eliminate the variable, because you can't. And then you're saying, oh, we'll just average it out and say it's close enough to neutral with my not sensitive enough equipment.
Well, the point is, it's very close to 0 at any instant, and over the average, it is 0. And even though it's so close to 0 at any instant and averaging out to 0, the effect of a mass outside the Faraday shield still affects the weights inside the Faraday shield equally.
But it sounded like you changed your answer though, man. Like you were like, no, there's none, and you're like, oh yeah, there's fluctuating. That to me sounded like a different answer. But okay.
Oh, he's gonna keep changing his answer. Hey, can different types of signals and waves go through the Faraday cage?
DC magnetic fields can go through the cage, and like X-rays might be able to, depending on the kind. But it blocks electrostatic fields very well, and it blocks high-frequency magnetic and waves or signals as well.
Well, it doesn't block them entirely. It just, and of course, inside the actual Faraday cage itself, there already exists an electric constant, and you have all kinds of different frequencies penetrating the Faraday cage, right? You have all kinds of different frequencies.
But see, here's the thing. I can take a voltmeter, and I can measure an electrostatic field with it. If I put that voltmeter inside a Faraday cage, then it no longer measures the electrostatic fields outside the cage. Now, if I take an accelerometer and put it inside the Faraday cage, it still measures the pull of a large mass nearby. Okay? I could also put a super sensitive magnetic sensor in that cage, and it would not detect the mass outside the cage. So there's 3 different things here, all of which can exist at the same time, but also each of which can be created and detected completely independently, and different things stop the different ones. So
Oh boy.
there's something, if we've got an electrostatic field, we can block it with a Faraday cage. If we've got
No,
a
you can't.
magnetic,
Stop saying that.
Oh, wait. Sounds like a slam dunk, man. Strike one, strike
Trust
two,
me, I
strike
get it
three.
that you're both religious, but it's not.
No, he basically isolated all these things like you
No,
do
he didn't.
scientifically.
Hey, can
found that
radio
you don't
frequencies go through the radio? Can it go through the Faraday cage?
not a good one.
Really?
Correct. What do you think was called a
You
Faraday
think
cage
that
for?
high frequency radio frequencies don't go through a Faraday cage?
Not a good one.
So it seems like you're maybe not as experienced as you led on to believe, because first you told us all that you'll measure zero, and then of course we corrected that, and I was willing to put thousands of dollars on it. I know that's objectively not true. You're laughing, but you're objectively wrong. You don't attain zero, and if you can build a Faraday cage to attain zero, please go become a billionaire and get your Nobel Prize. So secondly, we know that high frequency, really, really high frequency, actually penetrates a Faraday cage pretty effectively.
You mean like X-rays?
Sure, if you want to call it X-rays.
What
So,
frequency is that?
Hey, are radio frequencies electromagnetic?
Yep.
So how is it that you're completely blocking out electromagnetic effects?
Well, you would need to make it cover that frequency. You would need like a lot of lead or something.
You didn't answer my question, I don't think. But yeah, I mean, it's to be expected, right? So if you have really short high frequency wavelengths like an X-ray or something, that's electromagnetic radiation, right? And that does penetrate Faraday cages very effectively. And of course, we already have the intrinsic electric constant inside of that. And we have the electrostatic induction with the electrostatic constant and the electrostatic molecular bonds of the objects inside of it.
Well,
and we have all kinds of frequencies going in and out of it.
Hey,
And it
Winston?
can't attain zero with electrostatics anyway. I mean, we have all kinds of problems. So basically, we have a phenomena that's, even though it's
Hey, Winston?
smaller. Yeah, see, this.
You say you shoot a whole bunch of different angles, and you won't let me respond to the first one, because then I'll forget. Our discussion, the reason I didn't mention X-rays to begin with was because our discussion was about static fields, things that are slow enough changing that they could arguably influence a weight hanging on a string. So if the context was to build a Faraday cage which was good for, or did stop X-rays, then you would build it out of lead or whatever. So there are ways to build cages that stop that frequency of electromagnetic radiation. That's just not what we were talking about, so I didn't go there. But if I were hired to build a Faraday cage that blocked X-rays, I would certainly use the right materials to do that. Okay,
And
go ahead.
so it would block. You got to make sure you block all high frequency electromagnetic waves. And this is the problem that you guys don't understand. You're talking about now that the vertical gradient. You're talking about something that isn't vertical, right? And like an effect that isn't vertical. And then you're trying to ignore electromagnetic waves. Electromagnetic waves that are known to be astronomically stronger than your claimed effect of gravity. So basically, what you're saying is you've never actually done the test to account for the electromagnetic variable sufficiently. And you know that the electromagnetic variable is significantly stronger than claimed gravity, but yet you know gravity's real. And now this has been about 20 minutes of you guys pretend you're going to grill me for my position. I can effortlessly always rebut you guys, but you'll never actually substantiate your claim. Your attempt to do that is to just try to attack whatever I say, and then we're just you think once you do that. Wait, I'm almost done. You think that once you create enough doubt about whatever my position is, that automatically by default yours becomes the correct answer. That's what you think.
So you just now mentioned something about our inability to substantiate our claims. It wasn't long ago that you literally stated that your claim of the electrostatic bias effect on weight, if we actually calculated it or whatever, would come out exactly as you predicted. Could you substantiate that?
But why? Why? Hold up, but Wits, I agree. I back this dude up, man. What happened to the you first, Jesse? You were like you first. You remember that?
No.
Doesn't that back up what he said? You never took your turn. Am I missing when your turn is coming?
It'll never come, Don. They never take their turn. Their whole game is to try to find out what's wrong with mine, because this is how groupthink works. They're like, Woodson came up with his own idea. He has to be wrong. Just the mere idea that some college dropout flat earther might come up with a better explanation for the phenomena, just the mere slight possibility infuriates them. There's no way. It's whatever you think is true based on consensus. And I've given you all kinds of answers. I've entertained your entire line of questioning. I've explained to you your own flaws, so maybe you can go develop a better test because you've admittedly not done it yet. And now I'm asking you to substantiate your position, man. And you expect we're just supposed to grant it to you by default if you can show some type of, doubt regarding what I say. Do you not see the problem with that?
Well, I told you, and others have, Big Blue did it even better, but we separate out the different influences the best we can, and it really appears that there's 3 different effects at play here. If you think you can show how yours is better, I'm all ears.
Better than what?
Better than our analysis that there's 3 different things at play.
Wait. Better than what?
Well, I find that there's a magnetic field, which can be blocked certain ways and measured with certain things. There's an electrostatic field, which can be blocked with different things and measured with different things. And then there's the gravitational field, which I haven't found anything that blocks it yet, except the things that block the first 2 don't block the gravitational pull. So
You have found
when
some
you
that
said,
blocks
is there
it.
anything
You
we can do
actually
to
have
test?
found some that blocks it. The distance is what blocks it.
Wait, no.
You don't
Whenever you
even know-
said, can we see anything that can test your claim? Can we actually test your claim? You've now reluctantly stumbled your way over to basically admitting your claim can't be tested. Your claim can't even be substantiated initially. We're supposed to grant it to your assumption that you think you've efficiently accounted for all the other variables, yet you haven't even established this one's here. And I've actually poked a hole at each time you've attempted to do that. And dude, if even the slightest bit gets out, the slightest bit gets through your little Faraday cage, the slightest bit, then it's going to completely nullify your claim that there's something else that's there that's much weaker.
not necessarily.
Holy sh!
Yeah, I mean, Jesse, are you trying to say that the Faraday cage is blocking the magnetic field of the Earth?
Goodness, no.
Okay. Well, then it's pretty limited in its what you're using it for.
I think his pattern of we blocked it out. Oh wait, we didn't block gravity out. Like that was hilarious. But you say that you do manipulate it by varying your distance and your mass. So that's blocking it by having less.
They don't get gravity. That's the point. They don't just magically get gravity. They think that because they're regurgitating the mainstream consensus, they automatically get it. That's not how it works. That's not how actual logic works. You're making a positive claim. So you're trying to critique my position, which I can actually verify in real life that what I'm saying is there. We can measure it. We can manipulate it. We can literally physically manipulate it and measure it. Okay? You can't do any of that. And you admit that just the smallest amount of the effects that I'm talking about are way stronger than what you think is there. And then you admit you can't fully get rid of what I'm saying is there. Anything electromagnetic. So how do you know that what you think is there? Then we can, of course, tack on the fact that the Cavendish is extremely inconsistent. You don't get the exact amount of attraction every time if you even get what's expected at all. That's reality.
And that's a fallacy.
What's a fallacy?
To say that because a measurement has a margin of error, therefore it's invalid.
Really, what fallacy am I using?
I don't know what it's called, but flat earthers use it all the time.
Oh, so you don't even know what you just made it up.
It's called the margin of error fallacy. Yeah.
Oh yeah. So if I said because measurements have a margin of error, then they're wrong. That's what I said?
That's basically what you said.
No, it's not basically what I said. What I said was that you don't get your predicted value. It fluctuates. Half the time you don't even get the effect that you need. You use a Texas sharpshooter fallacy and a cherry picking fallacy by just selecting the ones. You guys can't handle the truth, man. That's what it is, right? Like It's sad though, because the truth is that when you do Cavendish, the effect constantly fluctuates, and you can't even eliminate the variable that we know would give us that, literally give us that effect. You can't even deny that part. You would
Hey,
admit.
Winston.
Oh my God.
Yeah. When you step on the bathroom scale one day to the next, you get a variation in reading simply because the scale has a margin of error.
You just want to say your script. You interrupted me to say your disingenuous script.
No,
Seriously?
you said
You
that
told me.
you said that we don't even get the measurements where we don't even get the right measurements or whatever.
Or whatever.
But we do
I don't think you're in a
just with a
position to
margin of
critique the
error.
logical consistency of my position if you can't even accurately say what it was. So what I said was, it's not like you have a predictive value for gravity, some variable that you've substantiated is actually there, and then you go make the observation and it consistently matches that. That's not what happens. Sometimes it goes the wrong way. Sometimes it doesn't go near as far, doesn't go near as strong. Sometimes it's hard to barely detect any motion at all. Okay? And then once you get it to start moving in a direction you like, so that's based on all your variables, on how much you try to control for electromagnetism, whatever it is. Once you start to see it moving a certain amount, you say, bam, got it. And then you consider the test a success, which is a textbook Texas sharpshooter fallacy. And the problem with that is that electromagnetism will give us the exact same effect that you're claiming for gravity. Admittedly so. So then we need to look at it. Well, we really need to make sure we fully control this variable if it's going to give us the same effect. We can't fully control it. Well, maybe we can get it close enough to where it wouldn't matter. No, we can't, because the smallest amount of electromagnetic effect is significantly stronger than the claimed gravitational effect.
How could you say that? First of all, I like the way you use that Texas sharpshooter fallacy with Jesse as well as with me earlier today. And you said the same thing when we were talking about statistics. Yes, we can throw out outliers that are not significant because it's based on statistics. Realize that all these data we are replicating, even though it varies about a center line, the outliers are outliers. They don't happen that often. It doesn't mean that that's actually happening. It means that the measuring equipment or the situation has changed slightly. But overall, when we make measurements, we have something that has a high R square value relationship with the statistical data, that how it represents the actual line.
I want the whole room to notice that they'll never address the actual point, which is that the electromagnetic effect that they admittedly cannot fully control will give us the exact same effect that they're hijacking and claiming
You say that,
is
but it's not
gravity,
true.
and the weakest or the smallest amount of electromagnetic effect is stronger than gravity is claimed to be.
Because of one test, you got paint chips to float up. See, what you don't realize is that.
No, it has
So
nothing
what
to
is
do with
the definition?
that.
Hold on. Let me ask you a question, Winston. If I
See what I'm
said
saying? You
something
won't
had,
respond. Why don't you
hold on,
respond to what I said? It's
I
disrespectful
will.
to just
If
skate right past what I.
something has a billion pounds of force, a billion pound force of force, would you say that's a lot? Is that a lot more than, a couple, whatever the units of measure for your static electricity
This
would
is
be?
really not responding to what he said, though.
Yeah.
Hey,
That's all.
Well,
just a second.
Jesse's done it the same thing for 10 minutes. This is all they ever
as
do.
strong as the mass is.
If you start
The
off
force
with
will work.
imagine this, and that, you're starting to take
Well,
us
I'm
in.
just trying to get that imagined, like it's imaginary. I'm saying just get in your head, realize that gravity is proportional in Newtonian terms, proportional to mass. It means the bigger the mass, the greater the gravity, and it doesn't work that way with electrostatics at all.
Let me try to reiterate this for you. You can't fully control for the variable of electromagnetic effect, whatever type it is. Now you can try, and you can do a good job of really narrowing it down. I concede that you can significantly control for it and decrease a lot of it, okay? And that would be great if it were not for the fact that the smallest amount is significantly stronger than the claimed effect of gravity. Being as that is the case, good enough isn't good enough. Right? You understand?
Wish I knew the name of that fallacy.
Yeah, you guys never know names of fallacies because You don't
Because we
actually
don't.
understand logic.
I do. We do understand them. I understand.
I'm not using a
Construction.
fallacy.
God, it is a fallacy.
Name it.
You're just like when you said the paint chips could levitate. I use electrostatics to levitate. They are inherently electrostatics. That's what holds the atoms together, the molecules together as well. Yet, if I can make them go up with electrostatics, that means they are electrostatic. That means they also are falling downward because of electrostatics. That's
You
a
see what I'm
fallacy.
saying? Gio, do you see what they do, bro? Anything under the sun other than addressing what I'm saying. Like,
Jesse,
they'll
do you
go as
agree with
far
me?
as, like, Jesse just left the room. And, like, Zenik will do anything. He'll talk to me for 7 hours, but he will never address what I just said.
You know, I've forgotten what you said.
Yep.
Guys, what'd you say again?
And he forgot, he says.
Yeah,
Oh, yeah,
dude,
my
I
brain-
formulated this argument to where you don't have rebuttals, Zenik, so just accept
I
it.
do. You said no one's responded to you for 7 years. I gave you a very accurate.
I got an idea, Zanuck. I got an idea. I mean this in all fairness. Let me, right, talk to Wisset, like, without trying to, knowing I'm not going to be adversarial, and I'll try to take your position. And then whenever you just be my little coach. You just like, no, do quick, not no monologue explaining. You know what I'm saying? Like, Wisset gonna sell me his part, and I'm gonna do what I think is honest. You know, communicate what you should be doing. And if I mess something up, then you just like, you be my coach. You know what I'm saying? We're gonna team up and be cooperative.
I'm on board. Go ahead. Perfect.
Okay. So my point is just that we know there's always like an electromagnetic variable, like a subshoot of that's electrostatics, whatever, right? And so if we're trying to determine, say, what happens in the Cavendish, let's pretend it actually works the right way every time, which it doesn't. Let's just say it does. If we're trying to determine if it's actually gravity and mass attracting mass, which is outdated, which is outdated, right? Let's just say we're going to try to determine that. Well, we have a problem because inside that experiment, there is electromagnetic variables. And even if we control for it, we can't fully control for that variable. And the problem with that is that the smallest amount of the electromagnetic effect, the smallest amount that we're not able to eliminate, just the smallest little bit, is significantly stronger than gravity claims to be, and it would give us that same exact effect that gravity is claiming to be the cause of in Cavendish.
Okay, I'll be honest. I appreciate your time. As an idiot of myself, the everything was awesome logically. The thing I missed right at the end was it sounded like electrostatics is stronger, but then it does the same.
Yeah, like as in the attractive force. So like the effect is allegedly that this ball goes towards the other ball, right? Like the electromagnetic effect, it does the same thing. Electromagnetism does the same thing.
I could see that part of it, but why would you say it's stronger then, but having the same? That was a little confusing. If you see where I'm coming from.
Well, it's like if we're playing tug of war and I pull the rope against you, right, a certain strength, and then I bring my NFL linebacker friend in and he pulls it against you. We're both doing the same effect. We're pulling the rope against you. He's just pulling it stronger.
It's easier for him though, but I mean, it's putting the same force on you. So I don't know how you would know that it's stronger, because that's I guess an interesting question. How do we know there's a skinny guy and a big guy? Like,
Well, that's my point. If the bigger guy was there pulling it, you would never be able to know that there's a weak guy. Now, that's not the best analogy because in a way, well, if you added them together, you would, right? But like say that there's like a really strong force. If you can't get rid of that, how can you find the really weak force inside of it? If the really strong force is overtaking what it's supposed to be doing, how could you ever find the weak one?
So does everybody kind of agree with what Whitset's saying, that the electrostatics can easily dominate gravity? Whitset, is that a fair summary?
Oh yeah.
Electrostatics can dominate gravity.
Yeah, an electromagnetic phenomenon.
Stronger than gravity anyway, in their own paradigm. So.
Okay. So Zanuck, what do you think was wrong with what Whitset said at all? Did I do? You know, I didn't hear. Is this something different than Zanik? Come, coach.
There's no rebuttal.
He's just gone. Zanik.
I think Zanik, he thinks if he concedes one part of it, he's conceding everything. It's like you don't have to concede the whole deal just to at least register some of these components. What's being said.
Yeah, you can still believe in supernovas, bro.
One crazy thing of this fallacy, there is one. When you start nitpicking like the statistics things, like, well, I don't see that much, or you can't measure it perfectly, so therefore throwing everything out. I mean, we can measure these things. We do measure these things, and statistically, it's very significant. That's why there's a term called statistical significance, because it is statistically significant. It doesn't matter whether there's outliers, measurements can or not. We still can get enough information from measurements dictate and tell us that we have evidence that this particular phenomena exists and why it exists.
Okay, this is
I don't
called.
understand the whole electrostatics, electromagnetism.
Witsit, I have a question, Witsit.
But we shouldn't. It's just
because there's something that's known. There's something that's known that can be tested that's stronger than what you guys are claiming is the gravitational force, and you haven't eliminated that.
As far as not eliminating it, Gio, I do have one more, Quarry Witsit. As far as the Faraday cage argument, and okay, it doesn't eliminate all of it, and blah blah blah. Wouldn't just varying it, like eliminating some of it or 90% or whatever, and I get that the rebuttal of, let me prepare for the rebuttal of, okay, well, the Earth, you're still not eliminating the Earth, but wouldn't just changing some of it at all, caging it at all, wouldn't that change the weight somewhat?
Well, that's a good question. So what we would do to test it is we would set up the Cavendish, and we wouldn't account for electrostatics or electromagnetism, and we would measure the effects. And then we would put it in a Faraday cage, and we would try to control for it the best we can, and then we would measure the effects, and we would see if there's a difference.
That's a good one. I thought.
Guess what happens when you do that, Don?
Go ahead,
Guess what
sir.
happens when you do that?
Sir, go ahead.
Yeah, whenever the effect is significantly stronger before you build the Faraday cage.
That's
The
really
same
cool,
effect
guys.
happens.
If that's true, isn't that cool? But hold that for 1 second. Back to my idiot question. Wouldn't just a standard weight scale, wouldn't that kind of affect that too, though?
Where's the weight scale in Cavendish?
No, that's what I mean, though. But I'm saying if the down bias is the electrostatic, and then we cage it some, right? We're filtering it some, and the down bias gives us the weight on the scale. Am I missing a logical?
Yeah.
Maybe wouldn't it affect that a little bit?
Nah, like that's where the ballers get hicked up or whatever the word is, caught up on a lot, because they think it's like this attractive force they think I'm claiming that electrostatics is an attractive force pulling things down to the ground. So then if you were to like weaken that force, then the weight should change. But that's not what I'm saying, right? I'm saying no, it just sets the bias, it sets the up and down. And
can I analogy?
Oh my God.
No, well, Zanik, I'm not needing the coaching yet. Could you write it down?
It sets the up and down, and the density of the object relative to the density of the medium is going to result in downward pressure. Now, in theory, you could change the weight of an object, right, with electrostatics, but you're going to have to introduce a lot. And by the way, we can do that, and when we introduce a lot, because it's so weak overall, although way stronger than gravity, which is hilarious.
Right, but doesn't the cage eliminate a lot? And could you help me make a distinction between the flowing down of the current and setting the bias, but then it not being the thing that's whatever term making you go down, right? How is it? What is there? So it's setting the bias, but there's something else making you like.
Yeah, like, okay, so it sets the up and down, so there's a slight downward bias, but the density of the object relative to the density of the medium is going to have a buoyant force, and it's way stronger, way stronger than that downward bias. In order to flip the direction, you'd have to flip the entire field.
Okay.
Hey, Wissett, do you mind if I ask, Wissett, how you came to this conclusion?
You can actually do an experiment. I looked at.
I mean, I can do an experiment, but
yeah, I have a Van de Graaff
I
generator.
literally asked, Would you mind if I ask how you came to the conclusion?
Yeah, I messed with the Van de Graaff generator and proved it to myself.
Okay, I mean, could you break that down a little bit and tell us
Yeah.
exactly how the Van de Graaff generator helped you come to this conclusion?
Yeah. So you can put many different types of objects. You can
Holy.
put like a paint chip, styrofoam, a piece of wood, right? I've done it with like styrofoam and a little piece of wood. And when you turn the wheel on the Van de Graaff generator, right, it introduces electrostatic charge, and it can flip the polarity of the fill between the plates. You can use 2 styrofoam pieces to set your like up and down. And once you spin the wheel, what'll happen to that little styrofoam or wood or paint chip is it'll go from the bottom, it'll fly up to the top. You can flip which way it goes based on the electrostatic field.
Hey, what's it? I get what you're saying, but regardless of whether it makes sense or not, why did your level of anxiety go up so high while you were saying that? Like, that shit we can all feel, right? You were so anxious while you was talking right then.
Are you serious?
Even when you said
attempts are
seriously,
just
even when
getting
you said
weaker, bro.
seriously, right? There was like you didn't just say the word seriously. There was a slight, the way you said it, you could feel even the anxiousness in that.
That is
You think
completely irrelevant, whatever that even is, whatever you're making up.
I mean, I'm not making shit up. Let's play that shit. You can play it back, and then keep in mind trying to hear Witz's anxiety, and you hear it.
So are you implying that because Wilson might be anxious about what he's saying, that he's somehow not sure about what he's
People
saying?
get when do people get anxious?
This is such a derail.
Yeah, I mean,
It is, Gio, and I will shut the fuck up.
it wasn't that I was anxious. I was just trying to remember, like, put it in the simplest way for you to understand it.
Oh, see, now you're talking normally.
I'm being honest. I was just trying to think of like the
When you're
simplest
talking
way.
right now, I don't feel anxiety because you fixed it.
Look, I'll drop a video so you'll be able to understand. I was trying to remember what we use as the plates.
You know, what's it? Was I wrong?
Yeah, I wasn't anxious about anything. This is super easy to demonstrate.
Why are you mumbling?
Man, you're taking it to a weird psychoanalysis level up in here, man.
Just wondering why he's mumbling now.
All right, so play that video. If you look at that little piece of paper, you'll see the little piece of paper going up and down. That's as I turn the wheel. Very simple.
That's what's up. What's it?
It flips the.
What's it? I didn't appreciate it. When you
Field,
trying
yeah.
to call me out in the other room today.
It flips the polarity of the field, Joe. It's
So
dope
with
because
on
when you
Earth,
apply it to the
how
Earth.
much does it change with altitude? This electrostatic force or whatever.
Okay, so it goes up 100 volts per meter.
You're
and
mumbling
then
again.
They claim that like over 50 miles or whatever, something happens. Who cares what they say? Goes up 100 volts per meter measurably.
So how come things aren't heavier or lighter with altitude? Like you take a bowling ball, it's going to weigh the same 100 feet in the air as it is on the ground, right?
Does it?
Yes.
So weight of objects don't change the higher you get in the air?
No.
Are you sure?
What's it? Why are
Yes.
you so defensive right now?
Because I don't think he knows his own model.
No, it's because I put you in a defensive position, and you haven't been able to rid it.
No, I'm not sensing defensiveness. I'm just saying, like if you drop a bowling ball from 100 meters and watch it fall, you can determine the forces on it, and it's constant the whole way down.
No, first of all, it's not constant. Secondly, even in your own paradigm,
wait. First of all,
decreases.
you didn't
Let me just
finish what
read
the
this
first of all
off.
is.
French, please calm down. Let me
Yeah, but
read
you
this
said
off for you,
first of
Matthew.
all
This is
it's-
your paradigm. Weight decreases as the acceleration due to gravity decreases. Thus, weight decreases with increasing altitude.
Yeah, but the decrease is relative to 3959 radius, so it's not much from. That's why I chose something like 100 meters. Between 100 meters and 0 meters altitude, it's around
Yeah,
them.
it wouldn't change much with this either, right? Because the downward electric current is incredibly weak. In order to change it, like in that demonstration where it goes up, that little piece of paper is like equivalent to Mount Everest, right? Like you would need a ton of electrostatics introduced, and you would have to flip the Earth's entire field to change it, or you'd have to introduce a ton of electrostatics to change its weight. That's why whenever there say lightning struck you, then if you were able to weigh yourself when lightning struck you, then yeah, it would change. You would also
Well, so
die.
wait, I thought you were saying something like 100 volts per how high?
100 volts per meter potential.
Oh, I see. Okay, but a bowling ball 100 meters in elevation versus right near the ground, the difference in weight is minuscule, like less than 0.1%, say. But it seems like electrostatics might predict it would be more than 0.1%.
No, it wouldn't
No?
though, because it's so weak overall. We would have to introduce a ton to
So even though
change
it's
it.
like hundreds or thousands of volts different, the weight doesn't change.
Oh yeah, or like millions, depending on the object. You said a bowling ball, like a 10-pound bowling ball. Yeah, like a lot. And like this is, of course, we can do that. Like MIT has recently designed an electrostatic drone with no moving parts.
But okay, so I'm saying like a bowling ball at 100 a 10-pound bowling ball at 100 meters weighs 10 pounds, and a 10-pound bowling ball on the ground weighs 10 pounds. So I'm not seeing where the electrostatics is changing anything.
Okay.
With altitude.
Okay. So the weight of an object in your own paradigm slightly changes with altitude.
Sure, I'd say less than 0.1%. That's why I picked that.
That's perfect. That makes perfect sense within what I'm saying is happening, which can actually be tested, of course. This is where we go on for hours with everyone wanting to critique my claim, but the ballers never, ever, 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 ever substantiate their claim. But anyway, it works perfect because electrostatics is super weak, man. You would have to introduce a ton of electrostatics to change it. Just because you're going higher up in the air, you're just going higher up in potential. Okay? The downward current isn't changing. The downward current is super, super weak.
Is that measure worth digging deeper on? Like when you do your Van de Graaff thing, how much you can move, how much weight, and blah blah blah. Like, are these numbers something where, like, because you did make the claim right about something, Matt? You were saying by happenstance it matches, or it must be a replacement match, or you've measured it to match some other corresponding way, or
the
what
change
is it?
in weight with altitude.
Well, the saying where we're stating that your alternative idea, moves things the same rate as what gravity would move things. Are you saying that by like some side experimental measurement, or you're saying, well, it just has to replace it, so we would assume it would be the same rate?
Why does it have to replace something that's bullshit and never been proven?
I don't mean it like that, man. I mean, I just come
you see
on
my
with
point,
it.
bro? Like we
But come on, Witsit, you stated about just the rate or whatever being the same. I'm not trying to attack you at all, man.
I'm trying to make a point to you. I'm not coming at you. I'm saying we have an agreed upon average of 9.8 meters per second squared. Everything doesn't fall that rate. It's not constant. It changes with location. It changes at the same location based on rain, thunderstorms, lightning storms, wind. Inside a vacuum chamber, it changes, right? So it's like it isn't actually this perfect 9 point. That's just an agreed upon average. And you know how we got that number? We measured it. It wasn't like someone came up with gravity, did the math, and then was like, this is what we predict things will fall at. And then they went and looked and like, oh my God, gravity's predictions match how fast things fall. No, we measured it. And then people came up with the idea of gravity on a ball and integrated that number to get that number. That's what actually happened. So it's like, yeah, we have an agreed upon average of how fast things fall. You can use a kinematic equation to solve for that, right? Like height, time, and initial velocity. So yeah, that's just how fast things fall. And it's not constant. It changes. Actually, when we dropped them in a tower, we dropped different elements in a tower. They dropped at different rates. Right. And they have, and of course, they ironically, they dropped at different rates proportionate to their electric conductivity.
I mean, I agree with your ordering, right? That they measured the rate first, and then they use Cavendish to, okay, now we know this rate and this thing, and so now we can figure out the whole fucking density of the Earth or whatever. You know what I'm saying? And weight by volume and all this, and. But regardless, I didn't mean to attack you by saying you're replacing it. I was just asking, have you done side measurements with anything else to recreate your version of the phenomenon to that can say, look, we can get a rate with this, with this much, whatever is we assume causing the effect, the mass also, or the electric current or whatever, and then amount of electric current, the baby amps that you said, versus amount of material, and then, is there any deeper dive gone on that?
Well, I'm trying to work on different things to do, but it's like me versus the world, right? I mean, you just see how the conversation goes in here. But yeah, we have done some tests where we get different weights manipulating electrostatics. Now, if we're talking about like looking at the Earth and taking objects at different heights and measuring it and stuff like that, I haven't done that. That's one thing I want to do. I need like a group of people I can trust, and they need to get very precise measurement tools. They need to go to different elevations, and they need to measure during different increment. And truth be told, see, the Globers have such an advantage, but they're in such a stupid paradigm that they're just wasting it because they get stuff like gravimeters, which the cheapest gravimeter you can get that's any good is like 20 grand. And it's almost only universities that have it, and universities get grants from the government. So it's like I can't afford to spend 100 grand on gravimeters, give them to 4 of my friends, and then go make the measurements. I mean, that would be cool. I'm limited to like really small demonstrations showing that it changes the weight. Now I can use the university's data, and it supports me. It shows that the weight or how fast something changes whenever there's a lightning storm or whenever there's strong wind. Even though it's not like the wind is blowing what's falling, right? It's in a vacuum chamber.
Right.
Yeah, it's because it's ionic wind, right? There's something called ionic wind where there's electrostatics in the wind, and you can actually run a generator off of this. You can repel gas with electrostatics. Now, gravity doesn't have an
I
explanation.
appreciate you, and I know you're trying to get a unifying thing. To me, the cake and eat it too with gravity. You know what I mean? Like it's a force, it's not a force. Things only move with a force, but this thing moves without a force. So now we're gonna say it's a special thing, force, not force thing. Like that's cake and eat it too equals red flag to me always. So that's simple as that. So I, back up your exploration, man. Like I do.
This is Gleam dropped this right here. This is what's funny is I'm not claiming to be some like savant or something. It's just like I'm just like freed of the confinement and restriction of that paradigm. So I'm just like,
dude, don't take this. You seem like a messenger to me. Just even to say the least, they should respect you as a messenger. You share a lot of information, man. A lot of times that you have to drop to where the guy says, "Listen, guys, you see it all the time. Y'all got to give Wesley his props." People will change their answer. They'll be like, "Well, you agree this?" They say no. He goes, "Here's the citation." Okay, I changed my answer. So Witsa is a qualified messenger. Sorry for the coughing, but Witsa is a qualified messenger. Just based on that, no, you Witsa here an hour ago.
Well, this is why I don't want to. Yeah, I almost don't want to do these debates too much. I mean, I enjoy them. Like, I look at the people in this room like my fam, like just the people that are kind of like honest and stuff like that. But it's kind of like disrespectful, where you saw me talking to him, and every time that I refuted his point, he just changed his point. And then Zang did the same thing. And it's really, in the real world, that's like considered really disrespectful in intellectual form. Right. So like, yeah, it's kind of annoying, honestly.
It's female-ish.
Yeah.
Sorry,
Gravity
lady.
is
Sorry, lady.
Resistance. Risanic.
Even
that fiber optic gyroscope, like if you wanted to buy one, that'd be about 20 grand as well. Didn't Bob have to hire one?
So we had someone, a flat earther, out of his own pocket spend like 20 grand on one. And what's interesting is, see, that's what I'm saying. It sucks. It's almost like we need to raise flat earthers up, and they need to infiltrate covertly into universities and do tests or something. You know what I'm saying? But I will just want to read this while it's up here. Gleam dropped. Here's a direct measurement of electrostatics resolving dark matter. Like, how hilarious is that? It says the electrostatic model of gravity is based on the study of the classical forces of electrostatic attraction and of the spatial disposition of positive and negative charges at the atomic level for the orbiting electron and proton. The researchers on spatial arrangement and size of the electron and proton electrostatic fields have demonstrated theoretically using the magnetism analogy that the negative charge of the electron and the positive charge of the proton, although mathematically can be considered equal and module, physically they interfere partially but do not annul each other completely. So there are people, right, that are like all in the weeds of academia, like creeping towards this position, and it's pretty funny. Like, and that's not why it's my position. I didn't even know that existed. It's a
You
reoccurring
found
theme.
it. What's the summary of that? Say a summary, and then I have something to share with you.
Basically, someone just coming up with a theory to explain away the discrepancy of dark matter by reinterpreting the phenomena of gravity all the way to the smallest scale, replacing it with electrostatics.
Okay, nice. Okay, I have something to share with you. I'll give you first shot, man. Because I know stupid things. I'm sorry with the pendulum, change the subject, stuff like that. If you ever want to help me, be the clarified diplomat, whatever later. But this one there was something sent to me with it about a DFE
Video.
DFE schooling with it in relativity. I haven't watched it yet. It's here. It's sent to me here. Watch how this guy smashes with it.
Yeah.
Do you want to say anything before I watch it?
Yeah, sure. Okay, so I'll try to do it like concisely. So like what started it off was I was trying to teach the glowers about relativity, and I debated FDFE on it. And DFE, he's a former professor in physics. That's Brian Myers. I've debated him a couple times. He heard my argument about how relativity claims that the apparatus in Michelson-Morley contracted, and they took Lorentz contraction and applied it in relativity, but throughout the ether, blah, blah, blah. They said that I was wrong about that, and then what DFE did was he did the math for Lorentz contraction, applied it to the size of the arms in Michelson-Morley, and said, "You're such an idiot, Austin. This would only contract like 1/1000th the width of a human hair, and that would not make up for the amount you need it to. You don't even know how to do the math. You're so dumb." So then he gave it to FDFE right before our debate. Of course, FDFE just took it and ran with it. They kept on saying it over and over. And I was telling him, dude, that is the exact math. That's exactly how much it needed to contract. It's a really small amount. You guys look stupid. You're such an idiot, Austin. You don't understand relativity, blah, blah, blah. You know the deal. Now they've had to admit they're wrong about that. So now they're like putting all their effort into show that I'm wrong about relativity to kind of hide that and brush that under the rug. And what I'm explaining is that, of course, that it actually contracts according to relativity. So this is his video explaining how I don't understand relativity again, and kind of use sophistry about I don't know how to do the math and hide the fact that he was wrong earlier, where what they're saying is that relativity doesn't claim that the apparatus actually contracts. It doesn't contract for the observer in the reference frame, which I know that, but that it's not a real physical contraction. And it just appears to shorten from outside, but then it'll contradict himself and say it is a real one, but it's not a real one. So anyway, basically the point is that I explain it accurately, which is I have Einstein backing me up, which is that it's a real physical contraction, and you can't detect it in your reference frame because everything's contracting around you. And they're basically just doubling down on me being wrong, just like they did with the math earlier. And it'll probably take a few weeks before they end up having to admit they're wrong, or they may never, but that's basically all it is. It's 45 minutes of just like baselessly asserting what he doesn't understand.
I appreciate it. I can see clearly those situations, especially when it comes to the relativity, the contraction, and I'm gonna just simply put it at this: where the math boys don't understand the logic boys.
Yeah,
Simple as that.
Yeah, that contraction math is a perfect example of that, where they're like, "You're such a dumbass with it. You don't even know the formula. It's this small, blah blah blah." But I didn't have to do the math. I read Einstein and understood the concept, which is that it contracts. That's where the math came from.
See, you got to get the logic first, and then they get to make a math diagram of the logic.
Yep.
Right? But if they don't get the logic, they can't make a diagram of it. That's what it is, dude. It's a logic first and then math, guys. Okay, wake up. What's it? Just a good messenger. Thank you for. I'll watch. I'm sure it says what you said, but yeah, and I'll be able to rebut the guy that sent it to me now. Thank you.
Yeah, we'll save this meme. That this is the meme that pretty concisely refutes. I found where Einstein says it's Says it physically contracts. Someone came out and
Okay, I'll
said,
save it.
yeah, basically someone came out and said, so Einstein claims that that Lorentz contraction, unlike Lorentz who said it was physically contracting, Einstein claims it's just subjective and apparent. And then Einstein came out and corrected him and said, no, that's not what I'm saying. Like, this author unjustifiably stated a difference in mine and Lorentz's view concerning the physical facts, right? And he says that according to him, it does really exist in such a way that it can be demonstrated in principle by physical means by a non-co-moving observer. So yeah, I mean, yeah, it's more of a higher level subject, to be honest, but it's not that complicated to me, right? Like, it's like the idea is that if the Earth is moving, then everything is contracting because everything contracts in motion. They think it doesn't contract in motion if you're in that frame, and it only contracts from the outside, right? So it's like, it's kind of weird. They don't understand. No, it just says you an observer. It doesn't contract for the observer because they can't detect it because everything in that frame is contracting. So you wouldn't be able to measure it or anything, right? I mean, yeah, it's a bunch of crazy pseudoscience. The reason I bring it up is because that's how stupid you have to be to believe in their model, right? You have to believe that
Yeah.
matter contracts, but you could never measure it. Just believe it, or the Earth is not moving. So
It's pretty wild. I'd love if they'd have more cooperative discussions.
The problem is you guys know that they can't have those logical conversations because you guys know that you're gonna be able to make them look stupid. That's why they go to the absurdity not to have a logical conversation.
is like Gleam's like coming at DFE with all the citations, and he always just deletes Gleam's comments and blocks him, which goes to show you he's like intentionally dishonest. Like, I have emails from that dude. This is a former professor in physics, dude. I have emails. He like obsessively emails me, and he's like updated his website to have 3 sections dedicated to me, and he's made like 12 videos about me, all this shit, right? And it's like in the emails, I keep asking him if Einstein said that Lorentz proposed a solution to the problem which claims that there's a contraction in the direction of motion and it contracts just a sufficient amount to compensate for the missing time difference that should be there, and that according to special relativity, this is also or according to general, or just, it actually says according to the theory of relativity, this solution is the right one. Then why are you claiming that he doesn't think it's the right one? And I've asked him this question like 5 emails in a row, and all he does is send me like novels not answering the question. So it's like, I don't know. It's really weird. It's like they don't really deserve that much energy, I think. It's like they get me. It's a bit of ego.
Well, I
where
do.
I'm
I
like, gotta
appreciate
correct
it, buddy.
Yeah.
I do.
It's like people like you, I
Stay
like you, or
true.
like they come to me all day today in the last 2 days, like asking me about it. I've had all kinds of ballers be like, oh, he schooled you. You know what I'm saying? So it's like I end up getting dragged back into it, but it's whatever.
Is it weird how everybody that rebuts you just kind of gives you the mainstream media rhetoric? It's like they never have like an independent source outside of whatever mainstream media decides to approve.
Well, that would make sense if it's true.
What? No, like they're actually getting the mainstream position wrong. That's the funny. They're actually getting Einstein's position wrong. That's the funny part.
Problem is, like, at least personally, me, I don't even know what the claim is anymore because it doesn't seem that the Globers that frequent these debates that they even agree with the mainstream anymore. They seem to have their own version of the globe Earth that they starting to defend.
Yeah, that's what's so funny. That's what's cool though, because once the lid pops off of this thing, and it gets out to the masses, like fully gets out, like the real discussion, they're screwed because the Globers in the trenches have had to redefine the entire model to try to keep up with the flat Earth argument. You're never going to hear Neil deGrasse Tyson say the stuff that people in this room do. The people in this room have the luxury of just making stuff up. They have no accountability. 90% of them are anonymous on the internet, right? So it's like we're going toe to toe with people that are just like blatantly contradicting the model.
Which is for the layman and for the people that are new, like for the people that are new to your concept, which part of the electrostatics that sets the bias kills the globe? So does it remove mass attracting mass? Which is the main killer?
Yeah, well, the way that it kills the globe is if the globe tried to take this and apply it to their model, it wouldn't work because it would be way too weak to pull planets around each other at big scales because it's too weak. So they had to invent something else, right? Because electrostatics doesn't work for their model. So like that's why it kills it, because it answers every question they have about what was density of force, what causes the up and down, what gives weight. It answers every question and scientifically, but they can't just take it and incorporate it into the globe because it wouldn't make the gigantic planets move around each other at vast distances, which is why they ignored it in the first place. So honestly, if this is the case, if this is the truth for gravity, the heliocentric model is immediately falsified.
Yeah, I'm finding the not the academics, the credentialed academics, but the Globers down here, below McToon and those guys. They're moving the goalpost on 8 inches per mile squared. They're moving the goalpost on Nicholson Morley, and they're moving the goalpost on refraction. For bendy light, and so they're doing whatever they can down here at the proletariat masses to keep their ball alive.
Well, when Rumpus first started, he didn't even know anything about refraction. Never mentioned it.
All Rumpus knew at the beginning was the body of science. That's the only thing Rumpus used to say at the beginning. Everything was the body of science.
Everybody's following two-time dropout Dave, not Professor Dave, on the Chicago skyline. Everybody is following him. They say that Chicago and certain times during the summer, the sun behind Chicago, moving away from Chicago, they're down below the ball. They're below the bend, and some this bendy light, mysteriously brings everything up into perfect view, like we live on a level plane. But because of refraction, they can get away with their ball, even though we're seeing 9 times further than we're supposed to. And then if you have the sun moving away, on the other side of Chicago, then you're seeing a lot further away. They're so disingenuous. I hate to use the word liars, but they're so disingenuous on the Chicago skyline, because the Chicago skyline from Benton Harbor blows the Glober narrative out that they live on a ball.
But what you're seeing is a mirage, though.
Yeah.
Yeah, the Chicago skyline doesn't bother me.
I don't think some people are allowed to see. I genuinely believe that.
I mean, I fell for the seeing too far shit, man. Like, I thought it would be like a lot more of it, but then I just think about like, light bending down or light bending, period.
No, it doesn't work though. It doesn't work. They claim
Total
that the vertical
internal
gradient would
reflection,
Don, think
opaque.
about this.
I mean, I think about it all, man. I'm just
Just
saying.
think about this real simple, bro. I got you. Trust me. They say that there's a vertical gradient, density gradient, and that causes light to bend and let us see further than we should. So they have math for it. Therefore, there should be this much refraction with this density gradient, which means every time we go out and we look over a large body of water and there's that vertical density gradient, then we should see the same thing. That isn't what happens in reality, though. If you have a certain vertical density gradient, you can go out on different days and see different things with the same vertical density gradient. So that right there debunks them. what they've done is claim that anything under, well, what Ruif will tell you is anything under 300 feet it's impossible to debunk the globe because it could just infinitely refract all the way around the ball. So let's be real here. I mean, if something's refracting, why does it exactly where it's supposed to be? Why does it look exactly like it's supposed to? If Chicago is a mirage, how come it's not inverted or displaced? How come can we really videotape it and go towards it and then it never change? If we're seeing Chicago and it's a mirage and I videotape it, as I go towards it, eventually there's a moment where it should switch over from mirage to real city. But it doesn't. It just stays there. The truth is that you're just seeing what's there. I went around the country and tried it myself. The Earth is not what they told us. You can debunk it with your naked eyes. So, yeah, I mean, they've made their position unfalsifiable. But for me, the globe is so shaky that just any semblance of plausibility in theory doesn't cut it. You got to substantiate it. And, it just doesn't work. It doesn't work. Like when you go out and have the same conditions, you get different observations, which means that what they're accounting for and their predictions are wrong. But yeah,
Okay.
I saw
That's
a lighthouse
bold.
in Key
That's
West
bold,
from
buddy.
like 50 miles away, Don. A lighthouse, bro. Like 40 miles away. Like, are you kidding me? A lighthouse, bro.
Yeah, but Austin, that lighthouse was behind the ball, behind the bend, and refraction miraculously brought it up so you could see it as if you lived on a stationary topographical plane. Yes.
Yeah, to be
and
clear,
then
we're
stopped
talking
it right
about
where
a
it
path
needed to
of light
be.
bending 0.03 degrees per mile.
Stopped it right where it needed to be, right? But then the light that comes from the lighthouse bent at a different rate to bend around the ball. The light that is the depiction of the lighthouse refracted at and bent at one rate, while the light coming from the lighthouse in the same conditions refracted at a different rate.
All you have to do is go back to to the Roman Catholic Church and the Jesuits and the conversation. I believe his name was Augustus or Ignatius in 1539 when he talked to the Pope. He came in and said, "We're going to take over education, lawyers, everything." And the Pope stood up and applauded. And that person who talked to the Pope became the first black Pope. And in 1543, the Jesuits with the black Pope took over everything, took over the Catholic Church, promoted everything with heliocentrism, and it's been that way ever since. And Lamette took it off in 1927, and a guy by the name of Pinsent basically said in 2000 sometime that the Big Bang was invented. Lamette invented the Big Bang, and so if you invent the Big Bang, you destroy heliocentrism and the whole thing.
George Dimitri, something like that. George Dimitri, the ordained Catholic Church guy.
Yeah, I've been told it's pronounced Lamette, but some people call it Lemaitre and stuff like that. And it's easy for me, Lamette. And so, the picture you've seen with Einstein when he's been standing with Einstein. And so it's interesting that that one of the leading Catholic priests today said Lamette, invented it. And so it's like if you invent the Big Bang, you invent heliocentrism. And it's all a hoax, and it's all a Catholic and Jesuit hoax.
Yeah, but I'm a Protestant. I believe in the globe. Most Protestants believe in the globe.
That's
the irony that George Dimitri created pretty much the story of the Big Bang, right? And we're talking about somebody that was heavily involved with church. So more than likely, where did he get all the information for him to come up with his hypothesis, if not for church information?
Yeah, I love Matthew. I consider Matthew a friend, but Matthew likes his appeal to authority, consensus, regurgitation, piece of paper, and diploma. It's okay, Matthew. Merry Christmas.
I make that point because the Globers want to pretend like their knowledge is beyond religious or beyond fucking dogmatic, but the same knowledge and information that led George Dimitri to come up with the conclusion that we might have come from a Big Bang. I mean, where would the information come from? Because the church is always that is always the institution to collect information. So more than likely, it all came from some sort of religious base from its origin.
Listen, all you got to do to debunk it is say, Zanuck said gravity, right? Which supposedly causes the Big Bang, like everything going to a center focal point, right? And then expansion from that point, like, what is it? I mean, so it disproves itself. If gravity pulls everything to that point, why would gravity stop?
In
What energy would make gravity stop if gravity overcame all that energy to put everything into that dot in the first place? And if gravity is downity down center, how the fuck is it how is it uppity up too away from the center? So it's debunked right there in itself, right there.
In 1609, the Jesuits came out with their first Bible, and it changed Isaiah 40:22 to sphere of the earth. First time a Bible ever mentioned, or anything really mentioned, sphere of the earth when it came to biblical, and it was a Jesuit Bible, 1609, and I believe in 1611 the King James version was brought out. So within those 2 years, you had sphere of the Bible, and then you had the best-selling Bible in all time, the King James version in 1611. So it's all very interesting. It's interesting what the Catholic Church has done, what the popes have done, and what the Jesuits have done to heliocentrism, because heliocentrism is a Jesuit invention. I'm convinced.
A Jesuit cult.
Yeah, but most Protestants now believe in the globe. So, despite the origins of Protestants, I don't think Jesuits or Catholics have a monopoly on the Big Bang idea or globe ideas.
And they're global Protestants.
Say that again, Snacks?
Wouldn't be global Protestants.
I'm sorry, you're too low. I didn't hear you. Did anybody else hear what he said?
No, Snacks, your mic is muffled or something.
That sucks.
Matthew, would you agree with me that most people, young people, by the time they're age 5 or 6, have seen a round thing tilted that spins by their teacher's desk by the time they're 5 or 6 years old?
Yes, most classrooms have globes in them.
Yeah. So, you got to understand, of course, I think Matthew, how propaganda works. You get them young, you repeat the lie often, and you ridicule the opposition. That's exactly what they've done with the ball.
I think too, Matthew, with the Jesuit connection, I don't think you might be thinking of like more the surface level, because there's like Jesuit high schools and like, the Jesuit order. But I think in terms of their connection to some of these deeper, like black magic type of black alchemy that they're doing on these larger sort of deceptions, sort of like in Freemasonry, there's like the idea of like sort of like secret society components of Freemasonry, that it's not necessarily just sort of the mainstream Freemasonry, but that there's kind of cults within it that may have kind of controlling agendas and things. So I would say it's the same with the Jesuits. Like I don't think it's the same sort of surface level, civilian level Jesuit that I'm referring to, and I don't think that Jim was referring to that either. In terms of like these kind of darker type wellsprings of, well, maybe wellspring's not the best word, but like a reservoir of individuals that are having more of a controlling influence upon politics and the church, and then of course these kind of cosmology component and the sort of cult driven control mechanisms of the globe that have been kind of put out into the world. So it's like more of a clandestine level of it, I would say.
Yeah, I
Yeah.
don't know much about the Jesuits or like the deep level Jesuits, as you were saying. I was just saying among Protestants, non-Catholics, it's a fairly prominent idea.
What I'm finding interesting, I'm trying to do a deep dive into this, what Copernicus 1473 up until present, when he was born, up to present times, and there's this Cardinal Wolsey that was a cardinal in the Roman Catholic Church, and he said he's famous for saying, I believe it's learning against learning, and it's basically the second learning is learning of the Bible, of the biblical scriptures. So he said learning against learning. So that first learning, he meant science. So science against the Bible, learning against learning, science against the Bible, and that's why it's so hideous that the church and the Jesuits went after biblical scriptures. And of course, you got Luther that came out in 1517 that did his 95 Theses, and then Calvin came along, and you really had a race in Europe who was going to win. The Protestants started, getting the Bible out, and they started making the Bible a lot cheaper. Once the printing presses came out, they started making the Bible a lot cheaper, and people could start to read it. And then the Catholics said no, 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 no. And so there's been this huge war going on in Europe and now around the world, Catholicism versus people who actually want to read the Bible. And sadly, the people, there's fewer and fewer people reading the Bible, because if you had more people reading the Bible, you'd have a lot more, I don't want to use the word flat earthers, but you'd have a lot more true earthers out there.
Yet most people who read the Bible are not true earthers.
Yeah, and the thing is, Matthew, what's really, really fascinating is, even if you look at Job 26:7, and God hangs it on nothing. Well, that's not spinning around and moving around the universe at ever expanding insane speeds. And obviously the Jesuits came up with sphere of the earth, and in Isaiah 40:22, but the rest of the Bible, when it talks about foundations, pillars, all those things, four corners, all of that is nothing to do with a ball. There is no ball earth, no globe earth anywhere in the Bible. Nowhere in the Bible.
That's true.
Would it kind of wig you out in a way, Matthew, if you found out that indeed the heliocentrism really is like a specific, like a religious cult, or like a sect of a cult that's been pushed as reality? Like if you kind of came to that eventually, would you be like, ah, shit, would it kind of wig you out a little bit that you?
Yeah, that'd be weird. But on the other hand, like blaming an idea based solely on its source is the genetic fallacy. So I don't care who invented an idea. If it's true, it's true. If it's false, it's false.
Yeah, I think heliocentrism is a psyop. I think it's a complete psyop. There's no evidence for a ball earth in the Bible, and there's so much evidence that we live on some sort of stationary topographical plane. So much evidence. No evidence for a ball. None. Zero whatsoever. And Christians go, I was brainwashed at 5, 6. I don't care. I want to go to Christmas. I want to go to Christmas dinner. I want to be accepted. I don't want to be considered a nutcase. So onward, Christian cowards, marching off to Christmas dinner. I don't want to be ridiculed. I just want to be accepted. Amen.
reminds me of that saying, you know, that the ones who win the wars write the history. This whole historical narrative of heliocentrism and the roots of it, written by the ones who have won essentially World War I, World War II.
There is absolutely no science behind the globe being a real thing. There is no science. It is all mathematical formulas, all calculations, and all hypotheses.
Isn't that part of science?
There is no empirical and physical evidence. There's no experiments that back up heliocentrism. None, zero. So when Austin does his thing about gravity to acceleration, that 9.5 minute video that he did, and somebody gets on the gets on a chat or something, it goes, "It's in the math, Witzik," and it's just like, yeah, that's the only place it is. It's in the math. Or when somebody over on Tartaria does a little gift where you have this monster on the top half of the gift, and it's a math monster, and the math monster is chasing all the little flat earthers, down in front, and the flat earthers are running away from the math monster. It's just like, that's all you got. You got math. You got nothing else. And there were some protocols that came out a long time ago that said we're going to replace the Godhead or the God, God, with mathematical formulas and materialism. And that is exactly what has happened.
Dude, Bryant, like, Gleam jumped on there and started correcting him, showing him that I was right. And this professor, right? He just deleted all the comments once Gleam exposed him. How crazy is it? Weird. Like, that's just blatantly dishonest, right? I think so.
They're blatantly embarrassed.
Well, there's something to be said for moderation, but it doesn't sound like that's moderation. It sounds like he's actually just suppressing the ideas. They're suppressing the rebuttals.
He put a comment that said, "Attention, everyone." And it says, "What's it still thinks even after watching my video, blah, 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 blah. You fundamentally don't get it, what's it, And then Gleam replied with just like specific arguments refuting him. And once he typed them all out, he deleted the comment he had typed. And this is after he blocked Gleam's account for posting the evidence before that. He's like literally like trying to prevent anyone from reading it. Like Gleam is super respectful, Like he just drops like information overload.
There's something about this ball, and I'm going to be respectful to the server, Geo. And there's something about tiny invisible microbes that cause illness, disease, and death that is just really weird. And I know it's a lot about money, it's a lot about control, but I think it's a lot about Genesis 1. Because in Genesis 1, it debunks evolution by saying after its kind 7 times, which means, dogs make puppies and cats make kittens, but, no adaptation and no evolution. And then it talks about, Genesis 1, 6 through 10, and Genesis 1, 14 and 19, which debunks the globe. And then at the end of the first 5 days, God saw that it was good. At the end of the 6th day, God saw that it was very good. And God, making something after the 6th day and saying it was very good, wouldn't have created tiny invisible microbes that can cause illness, disease, and death. And so that's why we've been told not to read Genesis 1. And Satan doesn't want us to read Genesis 1 because the truth is right there, and the truth is in plain sight. and Satan doesn't want us to know the truth. Thanks.
Tell him.
I mean, that Brian guy was he was doing that in that initial debate you guys did with him, with you and Jaron and David Weiss. And he was, yeah, remember when he was saying, like, I don't want to talk to Austin? Like, he already was kind of trying to compartmentalize and shut out the discussion and to kind of control it, basically.
Yeah, for sure. Yeah, Dave made it a shirt, bro. I actually have the shirt. It's pretty funny.
Oh, the way they're acting now is ridiculous. Going back and like running through and trying to pick out things that are technically wrong with something you said that have nothing to do with winning their argument. It's really sad.
Well, yeah, I said like time, or I said T and T whatever instead of T prime, and they're like, oh, he doesn't even get the myth. This is just because he's like obsessively tried to figure out a way to like refute my argument for 3 weeks straight. Like, admittedly, so he said he's invested like almost time around the clock studying relativity for 3 weeks to rebut this stupid flat Earth college dropouts argument. You would know.
Makes them obsessed.
It's weird though, right? I mean, it's crazy, bro.
It makes sense. I mean, his whole career and everything he's built his pride on, is gonna be in question, now, unless he can just build himself up from the, knowing what he knows, regardless of what the system says. But he's built himself on the system. Although he's doing the alternative thing though a little bit with his machine that he's making, or his book that he's making.
Electromagnetic pulse therapy.
Yeah.
So like, this is what's weird. I guess it's the lack of self-awareness that's kind of crazy. So it's like, I was explaining the same thing I've been explaining since day one. I didn't make it up. It's not my opinion. It's not, I don't believe in it. I think it's stupid, right? I just went and read what Einstein and relativity in the current model says. I learned it, and then I went to facilitate the information. That's all I did. It's not, if this wasn't what it said, I wouldn't care. It's not my theory, right? It's just objectively what it says. So I go facilitate it. So then they realize, like, oh, Austin's got this new argument he's bringing up, because I go through cycles. I go through like waves. So then DFE, this professor, he like tries to help FTFE out before our debate, because FTFE jumped in Discord and he didn't know I was going to jump in. I didn't even know it. And I just destroyed him on relativity. Like, it was like embarrassing.
Was this the Machian principle that you're talking about?
That was part of it. So like the real showdown, that was the second one. Technically we had another, and it was so bad. Like, it was so bad. So he knew I was probably going to bring that up again, right? Because he got so destroyed in the first one. So we set an official debate for like 5 days later. He was supposed to bring evidence for all this stuff. He never brought it anyway. So we go into the debate. So DFE knew what I was going to probably bring up. So he went and tried to help him, the professor dude, DFE. So he did the math for Lorentz contraction, and then he applied it to the size of the apparatus. And he's like, what's it so stupid? This would barely change the size of it at all. So then he gives the math to FTFE, tries to explain the formula to him so he can pretend like he knew what it was and knew the math, so they could make fun of how stupid I was because they knew the math or whatever. And they're like, yeah, they're like, you're so stupid. This would only change the size of the apparatus by 1/5000th the width of a human hair, and that would not do what you need to do. Now, FTFE was super confident because this professor gave it to him as a slam dunk. And then I was watching the chat. He was in the chat just like, dude, just like ragging on me, bro. Like, what's it, such an idiot? He's so stupid. Haha, he doesn't understand relativity. He did, blah, blah, blah. So anyway, I end the debate. I'm like, dude, you're wrong. That's the exact amount. He's like, I guarantee you it's the exact amount. I'm like, you need to go do the math. And then you know what I bet you won't do? You won't make a video and publicly admit to your audience and say you were wrong about it. And so anyway, long story short, they keep ridiculing me, calling me stupid, super arrogant, blah, blah, blah. And then come to find out I was exactly correct, right? So why would you go do it again? Like, why would you be equally as arrogant? Crazy.
Right? That's Brian calling you stupid. He's like lowered himself to their standards.
Yeah, oh yeah.
FGFE style. Oh,
Yeah, I
that's
mean,
too bad.
he won't point blank say Witsit is stupid. He'll just say like he doesn't have a basic fundamental understanding of math or relativity. He just can't do math. He doesn't understand the concepts of relativity. He just isn't capable of understanding it. Is that why
Yeah,
you
but
don't
he's
talk
not
about
calling
it?
you like directly stupid. He's not saying you're stupid, right? Okay. I
Yeah,
wouldn't
just I
think for
mean,
him. Yeah.
yeah,
But
might as
totally,
well.
yeah, like insulting your ability to do things, right?
Yeah.
Or
Yeah.
or assuming your ability to do things and then wrongly assuming and then doubling down on that assumption afterwards.
Well, then if you go to his comment section, so he has all the typical anti-flat earthers that, to be fair, like they're not actually very bright, you know, but they talk so much trash. You're like, what's it such an idiot, so stupid, he's a grifter, blah, blah. And no matter what crazy unfounded insult they say, he goes and hearts the comment and then like agrees with it in a reply. So it's like he
The only
might as
way you
well
can
be
sleep
saying
tonight.
it.
So what do they do when you prove them wrong by doing the math?
They literally just hoped that everyone would forget it happened and then tried to change it to me being wrong about something else. This is a freaking professor of physics, dude. So then I wouldn't let it go. I kept on being like, you need to show some integrity, admit you were wrong. Like, so then in his video, he like half-assed does, and he blames it on me. He basically says like it was because he didn't understand what I was saying because what I was saying was so confusing. It has nothing to do with that. It has to do with his misunderstanding of how the math applies. So he like pretended to admit he was wrong. And that was only after like 3 weeks of ignoring it and me telling him to admit it. And now it's just shrouded in like this whole Witsit doesn't understand relativity nonsense again. I think it's crazy. It's just a lack of self-awareness, I guess, because I know that I am correct. I know I'm correct, just like I knew I was correct the first time. I had not done the math the first time. You know why I knew I was correct? Because I read Einstein and actually interpreted what he said. So I didn't need to go do the math. I knew the history of it, and I knew that that's where the math came from in the first place. I knew that that's where that formula came from. So whatever the amount was that the math does, that is how much it needed to do. That's why it was proposed in the first place, right? Like I went and read Einstein. I went and read Lorentz. I went and read Albert Michelson. So he's like, Einstein explains, Lorentz and Fitzgerald saved the difficulty of the fact that there should have been a difference in time, but it wasn't there, by proposing a mechanism of contraction, claiming that the matter contracted in the direction of motion just the sufficient amount as to compensate. So just the sufficient amount as to compensate for the missing time mentioned above, right? For the difference in time mentioned above. So that if anyone has reading comprehension skills at all, then he explains it to you there. Which, I mean, I already knew that from Lorentz, but I mean, Einstein just explains it also. He's like, Lorentz came up with an idea to say, well, oh, look, it contracted just the right amount to compensate for the difference in time that wasn't detected. So whatever the amount of contraction was when you do the math, that's equivalent to the amount of time or distance that was missing. It's very simple. So they're like, it's like they're talking about how small it is, you know, that they thought there's no way this makes sense because it's so small. But I already knew it was small. Like Einstein explains, it's like exceedingly small. But since they came up with such a precise mechanism with interference of interferometry, that it was going to be decisive in detecting it, even though it was exceedingly small. So when they were talking about how small it was, I didn't need to know the exact numbers. They were just blown away how small it was. I'm like, yeah, that's what exceedingly small means, you know? I'm like, yeah, I know that's how much it is. Whatever it is, that's how much it is. So anyway, it's just weird because it's the same situation here. It's where I fundamentally understand what it says. They still do not. So they're like just fighting it. And then, I don't know. It's just weird. It's weird because I get dragged into it because I feel like I kind of have to. I guess it's like my
irksome.
job. I guess everyone has a part of their job that they don't really want to do, you know?
Well, Matthew, do you still have the interpretation of Michelson Morley as as getting rid of the ether as proving there is no ether? Is that your interpretation still?
I don't really have an interpretation because I don't understand their experiment very well. I just go with whatever the mainstream science says about what they said. So I don't have anything beyond that, unfortunately.
Well, if you knew how important it was, right? Because which will explain to you, it was crucial, you know, in the way we respected the movement of the globe, or supposedly proved that there was no ether. And if there, you know, that's like a big deal, because if they got rid of the ether through that one experiment, or through what is it, Gail Pearson?
Yeah, that's the second
Also,
one.
Yeah, so you don't need the ether. They got rid of the ether, and everything works without it, right?
No.
Well,
no. When they got rid of the ether, they still had to fix the problem, even without the ether. That's what people don't understand. They read Wikipedia, they hear the other Globers say that, and then they just repeat it. If you throw the ether out, you still had to fix the problem, even without the ether.
Yeah, so that's about all I know about that experiment. I haven't read much about it. I mean, but basically, I would say no matter what that experiment was, it wouldn't change my opinion about whether there's a globe or not.
Well, don't speak too fast. Think about it. This is what it says, just so you know what your belief is, right? Okay? It's that we shot a light beam with the motion of the Earth. We shot another light beam perpendicular to that one, so like an L, right? Perpendicular to the motion of the Earth. So the light beam that's going perpendicular to the motion of the Earth should have to catch up to the Earth to then get back with the other light beam and then to the receiver. Meaning the light beam going with the motion of the Earth should get there faster than the light beam going against it, right? Because the Earth's moving away from it. And so they did the math, and there should be a certain amount that was missing. When they did the test, it wasn't there. So they threw the ether out eventually, and then what they said was, actually, that light did have to travel further, and it did take longer. But what happened was the apparatus physically shrank in the direction of motion. So it shrank just the perfect amount to make it look like it didn't have to travel further because of the motion of the Earth. And you could just never actually measure that it contracted.
The speed of light, right?
So how much is the percentage of the Earth is actually accelerating?
100%.
Well, in their paradigm, if what you're saying the part that's accelerating is what contracts, right?
Well, it doesn't even, I mean, it's just like linear velocity. Even doesn't even have to be acceleration. Just any motion at all contracts. But
So
you
the
can never
whole Earth.
tell. You can never prove it or measure it. It contracts, but you can't tell. That's what it says.
But I just don't get why they're talking about just the apparatus when it would happen to the whole Earth.
Yeah. Oh, it happened to the whole Earth. It happens to all the space around the Earth and everything. But it's just in the direction of motion. Right. So.
Hey, Austin, in Schooling Globers 2, I thought I saw a quick little sheet that you put up there that had all the experiments that have been done since Michelson-Morley in 1887 that confirmed Michelson-Morley. Do you happen to have that? Could you drop that in Could you possibly drop that in
Yeah.
voice text?
Yeah. So do you want like the PDFs or do you want like the sheet? I'll drop a bunch of PDFs and I'll drop a sheet that has all of them.
Yeah, because I saw it. I was watching it. It's like, it was on a white sheet and it had all the experiments that you had on there. It was on one sheet of the experiments that confirmed Michelson-Morley from 1887. And I went back to find it. And maybe I wasn't patient enough to look through because it was a 3-hour live stream you did. And so I didn't know exactly where it was. So thank you for doing that.
Yeah. There are the PDFs, and I'll drop the screenshots that say the name of all of them. So there are some that aren't on this list that are in those PDFs, and then some that are.
Thank you.
There you go.
Thank you.
Yes, sir.
Oh, Matthew, did you get that? Did you understand what he meant by that? Like
Yeah,
reason
that sounds familiar. I mean, I've seen sort of or heard those kinds of descriptions of what relativity says. That it shrinks just the right amount, and all these things that kind of like happen to preserve the idea that light only moves at one speed and never faster, never slower, and time goes slower or faster, that kind of thing.
I mean,
But-
even with the speed not changing, right? Like, yeah, that's just totally. I mean, that's kind of independent. I mean, yeah, but yeah, I guess you're not completely wrong. It conserves the idea that light is constant because it has to be because.
Yeah, I mean, my impression was that in order to say that light is constant speed, you end up having to say these things that you mentioned, that things contract in the direction of motion and that time slows down. I mean, those are all, at significant fractions of the speed of light or something. It probably doesn't make a huge difference just driving around in your car.
No, it doesn't. You have to go to relativistic speeds for it to really be noticeable or like anything, but that doesn't really matter. Like in Michelson-Morley, it showed us that the Earth's not moving. They had to come up with a new explanation. And it's not really about the constant speed of light in Michelson-Morley specifically because, yeah, like even with the constant speed of light, which is like testable, so you couldn't just say it's a variable speed of light because in Michelson-Morley, you can test that no matter which direction on the Earth you send light, it goes the same speed. Right, so it doesn't really matter. Like you can't just change the speed of light to fix it because you can test it, and the speed of light is the same in all directions on the Earth, quote unquote speed, of course. But I'm not getting into all that. But
Are you saying but they did the Sagnac thing, and that does what it's supposed to, and they want it to do that on the Earth, and it won't do that on the Earth? Is it, or what? What am I? I know you talk about Sagnac thing a lot, right? Isn't that analogous to this?
Yeah, it's similar. Yeah, it uses interferometry. It's called Michelson-Gell-Pearson. It uses the Sagnac effect, which was discovered by Sagnac, who said it was a vortex in the ether, and that's what we use to calibrate and engineer ring laser gyros. And they claim it detects the rotation of the Earth. Yeah, it's a similar setup, and according to the results of that, which do detect the sidereal rotation within 98% accuracy, then it should have also detected the orbit, but it doesn't. So we got a problem. The problem is apparently that matter contracts as it moves, but so do you, so you can't measure it. Like if it what it says is if you're on a train, right? And the train is in motion. So okay, let's say you want to measure the window in a train and you have a ruler. All right, as the train goes in motion, the window contracts. The whole train contracts and the window contracts. You go to measure the window to see, oh, is it contracting, right? Is it shorter than it was before we were moving? As you go to measure it with your ruler, since your ruler is moving with the train, your ruler also contracts, as does all the space around you. So it's going to look like the window didn't contract, even though it got shorter. That's what it says.
And then if you try to measure it with the light, your time is slowed down a little bit, so the light takes just as long as it used to.
Yeah, exactly. Like, because like if you look at speed equals distance over time, so you have speed being the constant speed of light, so that's not going to change. So speed equals distance over time. If the distance changes, then time has to change as well. So if you're going to travel a shorter distance, right, then time has to slow down.
But they try to say the longer distance in the same time, like when with the fucking bouncing fucking photon up and down on the train, and it's like that doesn't equate to more distance. You know what I mean? Like it just to me, it's just a lie. That
Well, they
that
just had to
fucking
say.
angled fucking bouncing fucking ball is a fucking lie. It's not more distance. Period.
Well, they just had to say that. Like, if you're gonna say that the distance
Yeah.
shortened, then you have to claim time changed because of the speed of light. And this is what's funny, that the lie is so brilliant. It's so brilliant because they say they present it like relativity made these claims that time slows down and distances change. And then way after the fact, we went and tested it with stuff like atomic clocks and we proved it right. So it's like it's presented like this genius idea that they came up with and then just happened to prove it right. But that is not what really happens, right? I mean, they doctor and fudge the actual data to try to explain it within relativity, who made that idea up out of necessity to save the heliocentric model. That's actually what happened. So it's a very good trick. It's very well done, right? I mean, it's not even like you had to get everyone in on some trick or anything. People really think that they're trying to verify relativity. So it's just crazy. And then you talk to the people in here and they're like, "Oh man, stupid first denying relativity. We've confirmed relativity like 20 times." Then you go talk to an astrophysicist or a real physicist or a quantum physicist, they say, "We all know that relativity could be completely wrong. Most of us disagree on Lorentz contraction. None of us really agree on time dilation. And we know there has to be some new theory that replaces it." But you talk to the people in here, and oh, they're freaking experts and relativity is true, and we're stupid for not believing it. And the way I know this is because I actually talk to them. I actually talk to these people. So yeah, it's a crazy world we live in. And then they'll call you a few names, throw a few insults in there, use a few obfuscation fallacies. Whatever.
Yeah, and you'll hear them repeat over and over again that it proved that there was no ether, when really it was the Earth moving through the ether that they were trying to prove, right?
Yeah.
So because they couldn't prove that the Earth moved through the ether, they decided to interpret it as the ether doesn't exist. That just
Right.
seems like totally bold-faced, completely misinterpreted, and repeated over and over again as if that's the obvious conclusion they must have reached, when it wasn't even what they were trying to test for.
Well, technically, they weren't trying to test for either one of those. Like, they assumed both of them. They were trying to see if the speed of light was variable or constant in all directions, right? The velocity of light. But this is one thing that gets left out that's very important, right? So, ether was a given, right? And it's because it was what was accepted at the time with Newtonian absolute ether postulation, right? Like Newtonian absolute ether framework was what everyone accepted at the time. And to go against Newtonian physics, like, was insane. You got ridiculed. You know how the ballers will ridicule us now. Well, that's like people ridiculed anyone that went against Newtonian physics with an ether back then. Like, so much so that even Einstein was ridiculed and laughed at the first time he went to the Royal Society to propose space-time. He was ridiculed because he tried to challenge Newtonian mechanics with an absolute ether frame. This is what actually happened. So it was like ether and Newtonian mechanics were just the accepted framework, and you were ridiculed for suggesting anything other than that. Plus, you had on top of it, you had all the electrical field theory fatherheads making huge strides in electrical field theory, making huge discoveries, new technologies, like crazy discoveries of electricity using ether. So it's like people were like, "You're insane. We have these people like changing the world, making earth-shattering discoveries in physics with electricity using the ether." Right? And you're going to come try to challenge it? So it was way accepted at the time. They were trying to figure out, well, how exactly does the ether interact with light relative to us assuming the Earth is flying through the ether? That's the actual setting in reality. Let the people in here say it. They'll just say it debunk the ether. And what's funny is after you correct them and you spend like all this time talking like I have, they'll come back tomorrow and still say
Yeah.
it.
They have to.
Like 100%. If you ask one of these ballers in here tomorrow about Mickelson Morley, they will say, Mickelson Morley just debunked the ether. Like 100%.
Yeah. Now with quantum physics totally embracing the ether, they're fucked.
Well, yeah, but it's a slow process, and the people on Discord have the convenience of just like pretending that they're in the know and with science the whole time until it changes, and then when it changes, they'll just breeze right over like the previous 5 years they ridiculed people. They'll adopt the new framework and then start doing it again.
Right.
So it's a crazy. If they say relativistic ether, they'll be like, "Oh yeah, see, it wasn't the ether like you guys were talking about. It's actually a relativistic ether." And
Right. Relativistic ether. Right.
Yeah.
Yep.
Yeah, it's like you got to
They'll do the
understand
same
there's
for
no
flat Earth.
way to
They
have
ever
a
have to
fruitful.
say it. They ever have to say it's stationary. They'll do the same thing, and they'll start saying that it's relatively stationary or something.
Which they can already say technically, right? Like there's no fruitful conversation to be had with people like that. I mean, I'm just being honest.
Yeah.
Like they've made up their mind, and they may not be consciously dishonest. A lot of them are, but some of them they have cognitus, bro. So they kind of like check out, and like when I'm saying this or you're saying this, like their head gets fuzzy. This is my opinion. Like they're like it gets kind of fuzzy and it doesn't make sense to them. And sometimes they can't even follow the principles that we're talking about. So it's like they just kind of check out. It doesn't register with them at all. So then they come back to, and it's like Mickelson Morley debunked the ether. You see what I'm saying? Like they just come back into reality, and it's like nothing changed because they completely check out during the moments that like go against their cognitus. So it's like crazy, bro. It's like there's no way if they're not going to fight their cognitus and be like, I want to know what the truth is. I want to understand my position. Let me really focus and try to understand it. That's not, no, they just want to be able to like get along with their other Glober buddies, kind of bond over the fact that we all agree on our talking points and we present them like the stupid flurfs don't understand them and they're so easy to get. They're so simple and so easy to understand. That's why they're here. They get this like feeling of importance out of that moment where they pretend to be bonding over the fact that the flat earthers are so stupid they can't understand how simple it is, and we have to correct them like school children on basic ideas. And I hate to fully psychoanalyze them like that, but that's just what it is. I mean, we can call it like it is, or we can play buddy buddy and pretend that's not what it is, but it clearly is the case. So.
Yeah. It's crucial. It's crucial that interpretation.
Yeah.
And the fact, and when you put it to them that they have to believe that time slows down and that this mechanism is contracting to accept the whole model. I mean, it requires that if you think that you're on a ball spinning and going around through space, you have to, it's a package deal, like you say. They have to believe that as well, because that's what it hinges on currently.
Yeah.
It's not even heliocentrism anymore. I think somebody was making the comment in her this morning about that. Like if we're going around the great attractor, and it's not even a heliocentric system that we're talking about. Attractor centered, or whatever.
It is what it is. It's kind of like, you know, it just passed the point. It's like these people in 2023, I predict that there's going to be a major shift. It's not that it's going to be like all over in 2023 or anything, but it's going to start to get really uncomfortable for ballers in these rooms. Like really uncomfortable, right? Where they're just going to be in full damage control, where they're going to be like trying to nervously laugh it off and be like, oh, you built Theo Vaughn, some comedian. Oh, yay, Kanye West. Right? They're going to start getting nervous. Like, oh, oh, Dave Weiss was on CNN. Oh, no, maybe not that extreme, right? But like, oh, Witsit was on like, Witsit was talking to Theo Vaughn and Kanye West about flat Earth. Who cares? Oh, that's so stupid. Like it's gonna get like really awkward, and they're gonna be faced with this moment where like they always have the option to kind of step back and be like, whoa, like was I maybe wrong? And I don't think they can do it. I don't think the people in this room can do it. And like, if we're being honest, it'd be hard to do it the other way around, right? It'd be hard to come in Discord and talk to these ballers and tell them like they were right about the ball this whole time. That's kind of how they see it, right?
Yeah. Well, if they can make the moon be within our atmosphere, then there's no holds barred.
Yeah, they just need some explanation to be given to them. As long as something, the only thing that they're worried about is if like nothing's given to them. As long as something is given to them, or as long as they've come up with something they think is decent, then they're good. They're like, they don't even notice it. They don't even like miss a beat. Like they don't even glitch out of the matrix for a second, as long as they got an answer made for them. So
yeah,
I know this because I just Google whatever the response to stuff is, and then I just go read comments sections, and that they're all saying it. Or if McToon says something, they all repeat it. So they just need someone to give them an answer. This is the fundamental problem, is they need someone to think for them. That's why when I'm talking to Jesse and I'm talking to Zanuck, it's so painful. It takes so long because I'm sitting here thinking for myself, and they can't even compute that. They think that automatically means that I'm dumb and that I'm wrong. Like me thinking for myself, like why would this college dropout in Discord in any way have anything enlightening to say regarding physics? There's no way he can be right. They don't understand the idea of thinking for yourself. I mean, I'm being pretty blunt because I'm about to get off here. I guess I'm kind of tired, but that is kind of the truth, Like that's honestly the truth. It's like they can't think for themselves. So it is what it is.
Yeah, I just wanted to piggyback on that gentleman before just a few minutes ago. He was talking about the great attractor. You had Copernicus, who I think didn't live, but the Catholic Church brought it out, and it's called the dedication of the revolutions of the heavenly bodies. Some people call it the heavenly spheres, and it basically stayed that way until about the 1970s. We added some planets and stuff like that, but it stayed that way to about the 1970s. In the 1970s, they realized the sun wasn't the center of the universe. It was called this great attractor that, I don't know, was a black hole somewhere that the universe revolves around. But yeah, so even Wikipedia will recognize that the sun isn't the center anymore. So it's all very interesting that the whole idea behind heliocentrism, it's a cult of the sun. You had these heavenly bodies or heavenly spheres, revolving around the sun, and it was all about the sun. It was sun worship. It was pagan worship, and so heliocentrism got its beginnings on pagan worship of the sun. So it is a religion and it is a philosophy. It has nothing to do with science. Thanks.
Yes, sir. All right, I love you guys. Sorry I talk so much. I'm about to crash.
Check your DMs.
All right, we'll do, bro. Much love.
Later. Well, Matthew, it's almost over. Doesn't it seem like it?
I think we're past the halfway point.
Yeah, I think it's getting there. I thought it'd be over a couple months after I found out in 2017. So it seems like it's dragged on longer than I thought.
Yeah. Yeah, if it only lasted for like a couple months, it would have just been like, I don't know, like planking or like a fad. You know what I mean?
Right? Yeah, exactly.
It had to be at
You
least
got
a decade.
hot too quick. Planking. Was that really a fad? Was that just a couple goofballs doing it? Made it seem like a fad.
Maybe both. Maybe a couple goofballs trying to make it into a fad.
Right? They really tried. Or what was the other one that was going on? Mob. The what they call it when people start dancing out of nowhere? I forget what the name of it was. They even had a show.
It's like a flat earth flash mob.
Flash mob, that's what it was. Yeah. Flat earth flash mob. We should have a flat earth flash mob skit.
Well, looking at how things kind of evolve and change, like I often think about like the legalization of cannabis. It's like when you think about that, I mean, I'm just going to give some general kind of thing, but you think about like the 70s, 80s, 90s, illegal everywhere, you're going to prison if you're caught with a little joint or whatever, you're going to jail, just crazy, crazy levels of, and just all the propaganda, everybody, treating it as if it's some horrible drug and all that. And the idea of the medical benefits of it were pretty minimal, really. I mean, in the 90s, there probably was a little bit here and there, but pretty minimal. And then how long did it take? I mean, it was, about 10 years, maybe 10, 15 years total. When you think about like the whole process of like, it's, doing more research on it in terms of the medicinal benefits and all these different components and how it helps, people that have seizure disorders like the CBD and then slowly sort of legalization happening in different ways. And then now to the point to where, in most states in the United States, you could have a joint and more or less be smoking it down the street and you're not going to even end up with any problems. I only bring that up, not to go into a whole discussion on that, although it's an interesting topic. I'm just saying that just the way that things change, and I'm just bringing it like with the shape of the earth discussion, like it might seem like that it's not necessarily hitting some mainstream level yet, but it may be much closer to a tipping point than some people may think.
Yeah. For anyone paying attention, it's way past due.
It could happen pretty quickly. I mean, I know like my mom, for example, like she always was like with the cannabis thing, like just believe the mainstream thing. And she went from thinking that it was probably, whatever the mainstream, that it was some harmful thing into like, oh, it's medicinal, now. Yeah. So it's like
doctor approved, right?
Yeah.
Mainstream has stamped it. Must be good. They wouldn't steer us wrong.
Yeah, although the shape of the earth one's going to be bigger than cannabis, though, for sure. It's going to, it's a much bigger piece of the puzzle in that way. Yeah.
Fuck yeah.
Because they can just integrate the cannabis thing and, okay, now Conan O'Brien and, these late night shows, they all talk about it, joke about it, and that's it. But the earth not being a globe one, like, that's going to be, it might take, it's going to be a bigger shift, I think. And it's going to be more foundationally paradigm destroying, and it's going to be interesting to see how it plays out, because I do think the truth can spread very quickly and there can be tipping points and there could be many things that could happen quite swiftly.
I think they're just going to use it, or I don't know. There's just too many chess pieces still on the board to be like, oh yeah, it's flat. We fucked up. We're a space agency still though. And Elon Musk is still going to be launching rockets because that's what we do. I don't know.
I know.
It's like,
Yeah, like the mainstream was able to do the cannabis thing, like, okay, yeah, it's not as bad as we said, or whatever. Yeah, maybe it's medicinal. Yeah, your brain on drugs. Yeah, that was bullshit. So, or the frying the egg or whatever.
Right. But that took from like the 70s to like the mid 2000s before we really had traction on legalization, right? Or 2000 ish. It just took a while, like to normalize it, to integrate it into to make it something that can be mainstream. Because like I'm sure at some point, no one could have envisioned that it would have been, but they can just use it now, like because I would say a lot of people are either going to be super believers or they'll be like, oh wait, nothing's real, I'm questioning everything now, in that way, like, and with that, like, your only tool to like explore this is like some kind of HTTP shit, you know what I mean? So like your preferences, your curiosities can all kind of be like examined. I mean, why not just run that as a program for the next 50 years while they like loosely or slowly let the air out of the balloon here, and just to have taps on everybody and moderate it. I don't know. But yeah, like things can change like pretty quickly too. Like people's attitudes about things can change like really quickly, like in the case of what you're saying with cannabis.
I think it's already changed with the shape of the earth discussion. I mean, I feel like back in 2015, 16, 17, to bring it up to someone, usually out in the public, it was like, for some of them, it was like first time they heard it. They still were in that mindset of like, oh, that's just some crazy idea or theory, or they just wrote it off as some quirky, whatever it may be, or just like something totally
they would
off.
At least be the moon landing sure put that to bed or something like that. Or
yeah. Just
we
that
got
kind
a Hubble Space Telescope. We got radio controlled cars on Mars. It's great.
Yeah, the instant rejection and that feeling of like, oh, well, it's maybe just a few people. It went from like, oh, there's a few people that still think that, to, oh God, there's actually a lot of people that think that, to, oh yeah, I know several people that think that. Someone in my family, my friend, my whoever. It's gotten to that point. And then now when you bring it up to people, instead of them thinking it that same way, and I'm just making, these are all generalizations, obviously. There's a whole spectrum of different viewpoints, but it seems like now when you bring it up, people, especially young kids and younger people, are like, they know that this is actually like it's like an option more, like it wasn't really an option back then. It was just something that was so, now it's like, oh yeah, I know people think that it could be that, that's more people.
That's just but they can presume it like that because they're in their generation. It's like you might just presume to question like whether you might be the wrong sex or not or something like that. Maybe you might want to correct that. So like why wouldn't you just, it seems like that generation just has like they're very much about what they want and what they should have. They're like really entitled. So like they're like, oh well, it should just be a choice. If we were like a glober or a flat earther, it should just be a choice,
Yeah,
like,
I remember a shifting point. I noticed it even more, like on the 24/7 flat earth server, the 1.0, the first one. Back then, like we had like 9,000 members, and then there was this video by this guy Memulus. He did this video. He had like 2 or 3 million subs on YouTube, but he did a video about flat earth discords, and we got like, it was like 20,000 new members. Then this was the 1.0 server, not the current one. But anyways, it was like 25,000 new people within like 3 weeks. So all these people, mostly younger kids, like teenagers, were coming in. And it was just interesting because we had like hundreds of people in the voice check-in. Like it was overwhelming, all these new people. And it was just kind of interesting talking with them. And just, it was just the way that it was such an influx of people at the time. And it was just, like I noticed a shifting point there to where a lot of that younger generation, they were more like, oh yeah, I know this is a viable option. Like I'm not sure yet. I need to hear more information. I want to, but I'm just saying it was a shifting point between like, in a way, just the vibe of like, oh, pointing your finger, there's some small group of people that think it, more to, oh yeah, I know there's a significant amount of people that think this. And so I haven't come to my conclusion yet. And it could be, it's like viable, like it could be possible way more than previously. And that was just in 2000, whatever that was, 16 or 17, 18, well, I mean, like in those years.
At the same time, like a lot of like the dystopian films that had come out, I guess you could you could say like there's a grouping of them, and they kind of all show that like whoever is like running the joint, the elders, they're twisted, and it's their job like to like bust their shit up and like break through or something like that. That's what the thematic content in a lot of these movies that these kids are growing up watching. It's, you know what I mean? And I think you're gonna have a huge, much higher conversion rate in this next, like for the younger generation, and just based on what their input is, Minecraft, dystopian films. Like, if you're trying to be like on a more edgy and unique and like individualistic trip, like why wouldn't you like take a look at it? You know, so whether you get strong like I don't know, adoption from that. I don't know.
Oh, definitely. Yeah, there's definitely a
We're looking at.
generational. Absolutely, there's a generational thing. I mean, you know, boomers, and even even the like even after the boomers, but it's like
it's like some people have like a really hard ass like 1950s type vibe to them, and they're very inflexible usually.
Yeah, totally, exactly, because they went through the moon landing and all that stuff. They went through the picture of the globe, and so yeah, it's like foundationally in their program. Whereas these younger kids, like the moon landing to them is like a thing they heard about, and that's about it. They don't have the same emotional attachment to it. And then all of the other just crazy stuff going on just in politics and the scamdemics thing and all of that. I think that in general, the younger generations are just way more questioning of a lot of things. It's not hard to question things even more than some of our generations did.
Is a kid being anti-patriotic when I show him a picture of the moon landing, the rover on the moon, stuff like that, and they say like that looks so fake, and Star Wars looks so much more real? And is that kid being anti-patriotic or nothing, or is it just that this is like a shit show and a kid can see it? You know what I mean? I don't know.
It's funny the way you worded that, Gio. You said it went from people saying, "Oh, people still believe it's flat," because that's the way it always irks me, the way they would word that, like as if there were people still believing it from way back then. Now they're still believing it's flat, like it's not a new thing. It was just something that's been dragged on from the ancient archaic times that people still think it's flat. They never found out it was a globe, almost, the way they worded things. They continue to word things in that way. Like, people believe it's flat rather than they just stop believing
new perspective.
it's a globe.
I don't think the Asian people actually thought it was flat.
What are you talking about? They didn't have any reason to think it was anything other than what it
thousands of years
seemed like.
they thought it was flat.
The belief comes in when they start thinking it's the opposite of what it seems like in every way.
They have
That's
3
where the belief
separate flat models.
I mean, I guess I'm a little bit biased because I'm talking about Hinduism, right?
What do you think they thought it was?
A cosmos.
No, what do you think they thought the Earth was? Do you think they assumed that they were moving without having any indication?
They definitely didn't think it was that turtle crap that people think Indians thought it was. That was more
that was just a symbol to represent it. They definitely literally thought it was a turtle. That's another misinterpretation that gets pushed forward. You must think we're on a turtle. No one ever thought that.
Like, there's no Hindu in
all of these things. You might as well talk about like different sects of Christianity because they're so varied. Like as far as primary sourcing of like all these things. So like throughout, that whole region. I mean, there's just like different divisions of like what people might have thought.
Bro, what I actually find interesting is you would assume that progression of religions would equate to progression of understanding, right? So, for example, let's say the Hindus thought that we live in a cosmos, right? Why doesn't that information get shared to the Christians or the Muslims? That's the problem, isn't it? If these motherfuckers were sitting around for fucking 5,000 years and they figured out, you know what? Not only is the Earth not flat, but we live in a cosmos, and not even that. The crazy shit about Hindus, man. They believe in shit that I
don't know,
find hard
like,
to believe it.
yeah, Hindus as like an ethnic section, or as like, are you saying like anything that's Vedic? I like to see like the Vedic as like being a huge root to like things that are like Mitra and possibly even Yahweh is described in
I don't know the
those
weird
old
thing about being
texts.
a
So like,
Hindu, right? The
my
weird thing about
point is that
Hindus, the
before you
weird thing
cut
about
me off,
Hindus is
let me
Hindus are
just.
racist as fuck, right? And
Now you're
and the
making
reason
a
I say that,
generality about
the reason I say that is they.
broad swath of
You
people.
interrupt Max, bro. Let him finish first.
Yeah.
Man, you're just gonna cut in with racism next? That's your counter to whatever the hell I'm gonna say anyway. I mean, so anyway, there's a lot of roots that you can look from. There's a common knowledge, right? That moves, right? So like anyone talking about the same gods has the same understanding, but I've never encountered anything in any of my Vedic study where they're talking about sphericity and a helio model. No. That's for me. I would have noticed it and at least be like, oh, I'll address that. But no, I haven't. But anyway, onto your broad generalizations. I don't mean to be long-winded.
Back to the wide brush. Go ahead, Branch.
Well, yeah, I'll unmute Brent. But just real quick, I was gonna just say, just to respond to what you were saying, Dave. Like, yeah, with the people saying that, people still think that. It's interesting because that's kind of the programming of like, like, when we were all in school being brought up, it's like, they used to think the Earth was flat. Oh yeah, they were wrong. Right. And Copernicus and the Copernican revolution, and now look at modern science, and we're probing space, and all this advancement. So they've kind of built this like go team kind of thing with it. We discovered it was a globe. Wow,
we've evolved.
Yeah, we're standing on the shoulders of these giants and this brilliant modern day. It's like building up this whole like hubris with the modern system, and then people still think that as if we're just like stuck in the
their subtle way of tying it to the archaic belief.
Yeah,
like it's so ridiculous. Like people still think that. Like, how old are these people that they would grow up ever thinking that, right?
It'd be funny with the cannabis thing if they said, people still think cannabis is medicinal. Like, no.
Right.
Was this proven hundreds of years ago?
It's like, no, how about somebody came along and said it was dangerous? Who said that?
It's so consistent, though. It's like they all have that script. And when they write their article, it's almost like they're told, you must start this out with some kind of straw man, put down of flat earthers. How do you get flat earth believers? Flat earth believers, they have to make sure you put it in that context right away, so no one thinks it's a serious thing. And we still have people in the conversation 7 years that'll do that.
In that way, it is kind of a clever psychological psyop. In that way, it's like
they needed to corner it as one belief versus another. If we keep it on the idea that it's just one belief versus another belief, and it's just a matter of belief, then we can have both, and we can just have a happy discord forever about it. Can't prove it one way or another. Go ahead. Sorry to cut you off.
Yeah, no, I was just thinking how it's just interesting how it's like if you wanted to build it reminds me of like a football team, and they get the whole like our team is the best, and then they get people cheering. It's amazing how much people get into the sports teams just because it's in their local city. But in a way, I think they tapped into that kind of psychology with the globe, with the whole globe model. It's like to try to get everybody rooting for the globe. And then it was also like the same brilliant people, as they try to claim, that brought the globe and discovered this great thing. And then NASA plays right into NASA. Oh, they're the one that's out there exploring it and probing it and putting satellites out there and all these other components. And then SpaceX. It's like all this stuff is built up to get everybody like supporting this like sports team, if you view it that way, almost.
Mhm.
And getting everybody to root for it, and then trying to say like, oh, modern technology, oh, that's what brought you your computers and cell phones and the internet. So they've linked the idea of the globe Earth somehow being linked to this whole lineage that brought, your cell phone. So wow, I mean, what a thing to get people attached to it and rooting for it.
Yeah, and baseball.
Yeah, and they had
Baseball
the
with
flat Earth.
its rotations and all that stuff. It's like baseball is very comparative.
And the way that people, some people saw it as team flat Earth versus team ball, in a way that, in the same way, kind of like the team mentality, it's perfect, because they're like, great, it's just going to be like a back and forth thing that keep people arguing about it. And as long as we keep it plausible, then, we have nothing to worry about. That's how I think they thought that, at least when they first went into it, with maybe a contention plan that if there's some, actual real people taking interest, beyond just, the straw man that we can make of them, right? Then they might have a contention plan. Like I always say, outer ponder psyop, here we come. They're going to use it.
Well, we knew the outer ponders had something to do with this.
I'm not saying it was outer ponders, but it was outer ponders.
Somehow I knew you were going to say that. The aliens are outer ponders.
Yeah. It's the only thing that makes sense. I was racking my brain. I'm like, well, if this is intentional, if they're allowing this to happen, then they must have a reason. They must have like a, some secret plan that they're gonna use it for. The only thing that makes sense is if they're thinking about, okay, now we're gonna reveal the aliens, but we're gonna make the aliens believable because it's just ancient ancestors.
Yeah, no, it is interesting to think, like, because there's obviously like a couple main routes, just to be totally like objective and just to not trying to say what my viewpoint is, but just in general. Like one route, okay, let's just say it always stays fairly small the way that it is, even though it's not as small as it was in terms of the people that know the Earth's not a globe, but it is still, you could still call it like a niche in a sense, like it's a certain category, even though it is growing quite a bit. And there's a lot that's changed in the kind of public view of it and all that. But let's just say, okay, it just remains that way. But then what? It remains that way forever or just for our lifetimes? What, the truth never comes out? Like there's that idea. There's another idea that it does start to come out to the point to where the people just rise up, like the truth comes out and the people in power are slowly kind of disassembled from their positions or whatever. I'm not saying violently, but in some way, like the people kind of, we get our sovereignty back in that way, and the people in power just sort of either fall apart in their own corruption or whatever happens with that. And there's some kind of a shift in that way. But then there's like another just general possibility where people do start to realize it, but then the people in power come back with, like you said, kind of like some backup plan where it's like, where they do have to like admit it in a sense, or like they throw NASA under the bus, they kind of try to restructure things, and then they have some other narrative, which makes me think of the one you're talking about, where it's like they'd start to say, well, yeah, it's not a globe, but we were just telling you that because there's these, outer ponder aliens that are aggressive, and so we were trying to build up the military so we could protect you from them, and
Yeah.
So I mean that's like
you see their UFOs. We had to get into a space program because look, their UFOs are right there. We had to build this technology to be able to fight them. No, we weren't going to Mars, but now you know why. It was all about protecting you, and people will accept it, especially if they see the UFOs with directed energy weapons zapping their neighbor for not doing whatever they're told. Then it's like, shit. Well, I guess you were protecting us.
Oh man, that you're saying that they kind of turned Project Bluebeam into an outer ponder kind of, outer terrestrial kind of war or something.
Exactly. They got the technology to fake it.
If that happened, like that would be
energy weapons to make it real.
Right. Well, that's what's freaky too. The directed energy. Exactly. They could use those. They've already seemed to be testing them. They could use that as the proof that these,
Yeah.
Because I noticed that when we talk
It's
about that
perfect
topic, like
plan.
that's one that people are really resistant to. Like I just noticed the globe earthers, they're really like resistant to that one. Like they don't want that
Yep.
out.
Even some flat earthers.
Yeah. It's like one of the more, it's kind of one of the, because it's pretty crazy to think that they have like literally crazy laser weapons that they could just toast your whole house within a
right. And they need an enemy that would have that. That's not the United States, because otherwise it's us. We're the bad guys doing that, right? So they have to make it, I mean, not that they wouldn't want to have that as like some new development that they could have. I mean, it'd be the opposite of the atomic bomb, really. Then, right? It would be a weapon they actually have that they're using as a way of like threatening people, rather than one they're just faking they have to threaten people with.
I mean, I could definitely see him doing the Project Bluebeam thing while the globe is still dominant. Now, because there's also an idea that if this truth started coming out, that they might accelerate their NWO, World War III, God knows what, to really just be like, all right, that's it. We got to start doing this, or maybe even earlier than they wanted or were planning to, but that they have Project Bluebeam like ready to go. And if enough people still believe in the globe, they might have like a limited time window by which they feel like they could pull off Project Bluebeam, that enough people are going to believe it. Like the whole scamdemic thing, they got enough people to believe that, at least to some degree, although it seems like a lot more have seen through it. But with the Project Bluebeam thing, they would need enough people to be like, oh yeah, space is real, and NASA and SpaceX and all this shit, to the point to where they would believe it, that there really are aliens coming to do that.
Yep.
So it's like they could accelerate that while people are still believing the globe. I think it'd be wild for them to like admit it and try to do an outer ponder thing. I've always told you, I think that would be like the most sci-fi kind of outcome or something for them to. I feel like they might just try to pull off a Project Bluebeam while enough people still believe in the globe. It seems to me like that would be maybe their backup plan.
They could just make it up to everybody's interpretation too. They could just be like, well, we're not sure what it is exactly, but here's what we saw, and just let people fight over their own interpretation still. Some people think it's outer ponder, some people think it's from aliens from space, as long as it keeps people divided about what it really is or isn't. As long as you don't think it's the government doing it.
Yeah, as long as you don't think, as long as you don't know it's them. Yeah.
Right.
As long as you don't know it's just them doing it. Yeah.
Yeah, like I was going to say earlier, like that they also made a false dichotomy to begin with when they started down this heliocentric road. They had geocentrism versus heliocentrism, right? Either way, it's a ball, right? So it's like a win-win situation for them. As long as we're on a ball, we don't care if it's stationary or not. As long as you think you're on a ball, and there's nowhere else to go.
Or that the only other place to go, they're controlling the narrative of it. Yeah.
Right.
The outer space. Yeah, I mean, to me,
the dome idea is the same kind of thing, right? If it's a dome, then there's nowhere else to go either.
By putting coal down a tube.
Yeah, in a basket. Yep, coal dust in a basket, then you ignite it.
I think I Heart Science, you're hot micing, unless you were talking to us. Yeah, he might have been hot micing. But don't you agree that something definitive will be needed though to really finalize this? Like, just beyond the sort of debates and discussions. Like, it seems like the debates are good and interesting in a way, but also pretty limited in terms of. And there's a lot of people out in the world that even if they got involved in the debate part of all this, like they may or may not have enough interest to go through all the information and deal with all of it. So it seems like to me, like the tipping point is going to require. I've always said, like, a physical measurement of the surface that is definitive. And I know some globe earthers will claim they have it with geodetic, surveying different things, but those of us that know what they have know that they don't have that. So it seems like if there was like a physical validation, or even the thing RC Micey's talked about of the distances being validated, there's a lot of things. There's not really just one. I mean, there's, I think, at least 5 or 10 main kind of definitive type things that could be done. But it seems like it's going to take until that, you know, until there would be a tipping point, because otherwise it's a little bit more in the category of almost philosophy and, in those realms, and until there's something physical. And like I said, I know people are going to claim that NASA has whatever, physical things, or, satellites or whatever, but they really don't have anything definitive.
Well, they'll just turn it around and say that, whoever did the test is, it's doubtful, or throw shade on it in some way. Like, they already say that the give of railroad tracks in between the sections is enough to account for a globe Earth. So how do you ever measure anything then definitively, as far as the curvature goes?
Yeah, it's definitely tough. It's definitely not easy as one would think. Yeah,
and they knew it. They knew they probably ran so many ways. They're like, okay, here's our assignment for the next couple years. You guys are going to come up with every single possible way of proving that it's flat against these measurements that, are the exact same as flat, but slightly different, over a long distance, right? That's how they made sure that it would be like next to impossible to prove it, other than that obvious common sense that you're not frickin' spinning.
Yeah, it's interesting to think of when they were doing all this, whether how much they thought about, like, well, what would it take for people to actually prove it? Are they,
right? It must have, they did.
To really validate it. Yeah.
Yeah. Whether it was for pushing the psyop at the beginning, pushing the idea that we're on a globe to begin with, or even in preparation for people finding out it's not a globe, what could they possibly come up with that would prove it? And I think that if it was a rollout, they must have been like, okay, we've got all the plausible deniability we need. It's on the table, green light on that. The information age is here. We're not going to be able to avoid it anyway. Just let it be on the table.
I don't know, dude. I am willing to accept any and all other suppositions, or let go of any of them, if someone, as Geo says, gives me what are the measurements of the surface. I don't need to know jack shit about relativity, anything else. Tell me what the surface measurements are. I don't need to know anything past really 7th grade geometry to figure out if the points are coplanar or not.
Yeah, but would you need to do it yourself? Because, I brought up the distance one that you've measured. So let's just say that 5 of your favorite, beloved flat Earth heroes that you love so much, what if they were the ones that did it? Would you just say, yep, all good, just watch a video on YouTube, the way that a lot of people make fun of people for watching our videos on YouTube? Would that be it for you, just a video? Or do you need to go out? Because you're talking about measuring distances like that, like doing it somehow independently from Google Earth and GPS. What is it, just video of someone doing it? Or
listen, dude, it's actually a really simple one. I don't quote unquote trust or believe the distances because somebody tells them to me. I trust and know the distances because I use them all the time. I use them when I fly. I use them when I drive. We use them when we're surveying things, like to know property lines. This is so incredibly ingrained in our pragmatic, I need to get from A to B every damn day, that I can constantly check this against my experience. And so I have very little need to quote unquote trust a video, just like I don't feel like I'm quote unquote trusting what they're telling me. I get to test it every day. Now, if you want to say, but you don't go far enough, you don't do it, like, fine, that's whatever. But I can't deny these data points, which are, I use them every day. They work every single time without fail.
Hey, RC Micey, when you're flying, would you say that it's very crucial that when the plane lands, that there can't be any motion of the Earth at all the plane would have to deal with when it's landing? Like that Earth needs to be completely stationary in respect to the plane's movement for a safe landing. Would you say that's true?
Have you ever heard of an aircraft carrier?
Yeah, and those are hard to land on. It takes special training.
Sure.
You know that,
But
right? You don't.
no,
It's not
like
the same.
I want you to think about your
It's
question and then think about an aircraft carrier and ask yourself, is it absolutely crucial?
Well, no, it's very hard to land in an aircraft carrier that's
I
drifting.
didn't
That's
say
not
it was.
what
It's hard to
experience.
land in a crosswind too. Like my point is
Crosswinds
not.
are another thing. Yeah, you already got a crosswind to
So
deal with. Think about if the Earth were
perspective.
moving.
It's not like the appeals to I think it's moving and the argument about the air moving with the Earth completely irrelevant to what my point was.
No, but no, this is my point though.
I know.
Do you think that the Earth is moving when you land on it?
Yes.
I mean, at a different pace than your tangential, right?
No,
Because if you're landing and your tangential velocity isn't perfectly in sync with the Earth, you're fucked. Would you agree?
If
you could claim that it's perfectly in sync, but otherwise you would agree that you'd be fucked. If it was moving at a different speed sideways as you're landing south, right? And if it's moving sideways as you're trying to land, it's going to fuck your wheels up. You understand that?
I've been flying for a long time, my guy, and yes, I
So then
understand.
I'm just asking.
Oh my gosh!
Does the
And
Earth
I'm
move
answering you
as you're
perspective.
landing? Okay, I just want to know.
And I'm answering you.
Okay, go ahead.
The answer is no. If you have a atmosphere that is spinning while the Earth is spinning, then you're fine.
Oh, is that all you need? Because when you fly from one tangential speed to another, you don't have the same conserved momentum. If you're starting out with a sideways, an assumed sideways motion of 500 miles per hour. Wait a minute, don't interrupt me.
This has been gone over 7,000 times.
Then your velocity relative to the ground is 0 miles per hour sideways, right? Because you're moving completely with it, right? You're assuming that from your start. Now, if you're flying to the equator where you're having to pick up 500 miles per hour of conserved momentum, you're fucked because you can't add conserved momentum. You can bank left, you can aim left, you can aim right, but that's not going to add to your conserved momentum of being in sync with the Earth to keep that illusion that you're landing on a stationary Earth. You wouldn't be, because if you were just a little bit out of sync, your wheels would break off and you'd crash. And that's a fact.
Yeah, perspective, the way that you're representing it is completely untrue. It is not.
Okay, tell me what was untrue about it. Tell me how it gains momentum.
Because when you're gaining momentum because you're traveling through a medium that is also rotating. Thus, if you are in a medium that is also rotating, you are in the you have the momentum that medium also has. It's that simple.
But no, it's not that simple because it's a different velocity than your original speed.
And if you are in the medium, three-dimensionally, that is also rotating, you will have the momentum that medium has.
Okay, then walk us through it. Are you saying that atmosphere acts like a wind and carries the plane like a river? Is that what you're saying?
No, I'm saying that if you are traveling inside of a medium, like the airplane traveling in the atmosphere, then you are going to have the momentum of that medium.
Oh, so it gains a conserved momentum. You can't gain conserved momentum. It's what you started. It's
perspective. I want to show your straw man right here. I want to show your straw man right here.
But you can't gain that from aiming left to right.
You just said the word
aiming left
conserved
makes you gain momentum. You can't.
All right, if you're just going to talk over me, perspective, you can have a conversation with yourself. You cut me off in the middle of what I was saying.
You were going to depict. Okay,
all right,
you were going to take
new
apart
perspective.
The idea
you have fun
said,
having a conversation.
You're going to run away
now.
I'm sure you want to run away. You really do.
No, I don't want to be cut off every single time I say something.
Sorry.
Okay.
Okay, go ahead. But
no,
I
not you're sorry. You can have a conversation.
I wanted to make sure you weren't going to straw man me because I'm not saying you could gain. I'm saying you can't gain conserved momentum. And I'm sure you'd agree with that, right? See, they're fucked on this because you're never going to be in sync with the Earth with a new tangential speed. And if banking left is supposed to increase that tangential speed sideways, which it wouldn't, right? But I have to pretend it does just by aiming in that direction. Then aiming the other direction would make you lose conserved momentum, and you'd still be fucked because if you have to turn to go towards the airport, then you're going to lose conserved momentum and you're going to be out of sync with the Earth. Once you're out of sync with the Earth, you're never going to be able to time. You're never going to be able to get back to it. It's like they traded off the idea that because a hot air balloon goes up in the air, well, we don't see the Earth moving below that. So, it's because of conserved momentum. It's already moving at 1,000 miles per hour with the Earth, right? So if we accept that, then it fucks them on the idea that there's this gradient of tangential speeds that they have to be in sync with when they're landing at a different spot without that same illusion, quote unquote, of a stationary Earth. If the Earth is moving at all out of sync with the plane, their whole model is fucked, and it's over right there. That should be the end of the discussion. And RC Meisty is very good at cutting people off, and he was cutting me off, so I don't really feel bad because he knows he's fucked. And he comes in with all these like proofs that, oh yeah, they totally teach about Coriolis. Or something here that says that Coriolis is taught in plane school. They never teach that. Every simulator is a stationary level plane, and it would not be the same over a spinning ball Earth. And that is just the most common sense thing you could ever. And plus, even if the atmosphere is going with it, right? It doesn't work for you because then it's going to be flowing you out of the area. You'd have to fight it if you're going against it. You're
Right.
cutting against that atmosphere.
The simulators aren't built for simulating a reality.
Yeah.
A ball.
The pilots aren't trained on those simulators that are using stationary level Earth and then put into a sky over a spinning ball Earth. That would be really wise. Don't even train them on the obstacle that they would have to fly over. Not that it would be possible anyway. It would be literally impossible to fly and land a plane. And this pilot is on here trying to tell us that he knows it's a ball. He needs a 7th grade education to know that it's a spinning ball. And he flies planes. When literally planes prove it's not a ball, Meisty, if you're still listening. He's always irked me. I'm sorry.
I see that you just talked over me for 10 minutes, so I can see.
Oh, I thought you left.
No, I was just waiting till you were done.
Okay, I'll let you go.
No, the whole. Oh my gosh. So the entire point of what I was trying to say is that if you're traveling through a medium, you're going to have the momentum of that medium. Can you counteract the momentum of that medium with your directional control? Absolutely, right? But the point is that you are going to have the momentum of that medium, and the idea of that gradient three-dimensionally is not a weird idea. We can see this gradient. If you go in really fast airplanes, you can actually see directional and speed corrections. I've shown that page out of the navigation handbook probably 1,000 times in these servers. Everyone yells deny, deny, deny when I show them to them. The reality is yeah, that is.
Hey, I see, Meisty. I think a lot of people get this shit twisted though, bro. Like, light always moves at the speed of light, regardless of the medium. Now, to say that light bends because of mediums,
who's light?
That's
talk
not
about
light itself changing speed.
When did we talk about? We're not talking about light, Branch.
Light, like a zero mass particle such as light.
Branch. We're not talking about light. Branch, we're not talking about light.
He's trying to bail you out. He's trying to bail you out, Meisty, because what you said
perspective.
doesn't work. It doesn't work. Right. You're not going to automatically have the new momentum of the new tangential speed.
Oh my gosh!
Are you saying that it's carried by the air? That it pushes the plane sideways? Is that what you're saying? It increases sideways?
When you were traveling through a medium in an airplane or in a submarine, you were going to have the momentum of that medium. I'm not talking about light. I'm not talking about light. I'm not talking about relativity. I'm simply talking about an airplane in the air.
Right. How does it do it? describe the physicality of how it increases its sideways tangential velocity. How does it happen?
Yeah.
You can't just say it has the new momentum of the
didn't say
new
it has-
tangential speed because it's in that atmosphere. You can't say that. You have to describe it as a floating effect, as a pushing effect, as something, because we know winds go in all directions, so you can't call it a wind. You're
Yes,
fucked.
Coriolis is what explains that.
Coriolis is just the interpretation from an outside point of view.
Not when you're actually in a three-dimensional medium now.
Well, you know that the Coriolis winds, is that what you're calling them now? You want to go with Coriolis winds?
Did you
How are
hear
you
me say
describing
that? Hey, perspective. I never said the word Coriolis wind. I don't
How does it
believe in a
Coriolis do it
Coriolis
then?
wind. And so, because it's actually exerting a force on the aircraft when you are traveling
What
in a
is?
medium,
What's exerting a force?
the differences in the tangential speeds, the gradient that exists.
The difference in tangential speeds of what?
Oh my gosh, dude.
No, don't act like I'm stupid. You're the one
No,
that's
you
fucked here.
really are.
You're not even you're trying to describe it as a wind without saying it's a wind.
No,
You're saying it's pushing on the planes.
I never said the word wind. And
Just
like you
you're
trying to
literally
put it
saying
in.
it because there's no
he
other
just
way to
wants an
describe it.
explanation, my
And it
Steve.
wouldn't work anyway. Even if it was a prevailing wind, it wouldn't work because you'd be fighting it if you're cutting against it. And if it was a wind and you're flying from a 500-mile tangential speed at an angle, right, west, and you're flying into that atmosphere, it would act like a headwind.
I don't think it would, but
Yeah, it'd have to. Because the
again, I wasn't
atmosphere is
paying too
moving
much
with the Earth,
attention.
right? And if you're not matching that
In
tangential speed,
order for me to
it would
carry
act
on
as
this
a wind.
conversation, I would actually need to understand from the start where you was coming from.
Well, because if you took off, Branch, at 500 miles per hour, we're automatically assuming that the plane's moving sideways, right? Even though
I take off,
we have
I'm
no
chilling,
measurement of that, right?
I'm
It's
chilling, and
zero
I get in a
velocity
rocket.
sideways.
I get in a rocket and
as-
take off 500 miles per hour.
It's going 500 miles per hour sideways as a whole, right? The whole plane's moving sideways at 500 miles per hour, supposedly, when it takes off. And that's not even, that's irregardless of the other motions it does. It can aim left, aim right, go forward, right? All of those have nothing to do with the conserved momentum that we assume it has, right? All the other stuff is just like on top of that, right? We just have to assume it's already moving in that direction. But that's what fucks the globe, because then if it moves into a different tangential speed, it can't gain that new pretend conserved momentum. It can aim left and it can aim right, but aiming left's not going to make it speed up sideways in the same way the conserved momentum's thought to. And if you say the atmosphere is pushing it, then you're saying, okay, well, then that's a wind, or that, and then they say that the wind goes in all directions. We know the wind goes in all directions.
Right, but
so how are you saying that there's one wind that's always going to be consistently keeping you in that illusion of a stationary Earth?
Right, but have you ever taken the poop in
You
the
cannot
airplane?
have a
Have you ever
difference
taken the
between
poop on the airplane?
the plane's tangential velocity and the ground's when you're landing. That's a fact, right? And that's what would happen if you're flying through a gradient of tangential speeds.
Exactly.
I'm sorry,
But what I'm talking about is, did the poop?
Meisty has no. All he's saying is as simple as you just it would work. That's all he's
But
saying. He's
the
saying
poop,
it's just that simple.
when you
It
took
would
the
work.
poop in
I
the
fly
airplane,
planes. I should know.
did they
No,
hit the
you don't.
side of the airplane?
Your
or did it
argument
go
is
down?
lame and not at all descriptive of what you're saying is happening. You're avoiding everything you can to not say winds, but you want to have a force that carries the plane into this new tangential speed and magically makes it sync up with the Earth again. Not only that, but the atmosphere is not even claimed to be in sync with the Earth anyway. It's already out of sync, right? So you're already fucked. Even if it is the atmosphere that's somehow magically making the plane speed up sideways as a whole and move forward, regardless of that speed, even if it's just a little bit out of sync, it's going to fuck you when you land. And the atmosphere is not supposed to be in lockstep. So you're fucked no matter what, Steve.
I mean, new perspective. Here's the other question, though, right? Like, let's assume the Earth is flat.
I've gotten used to.
How does
Gotten
this
used to
help
that.
you?
Huh?
How does all these statements you're talking help if the Earth actually is flat?
Well, then you would be landing on a stationary level Earth, just like all flight simulators that train the pilots to fly indicate that you would be landing on, right? You're not ever having to time your landing with a moving runway ever in flight
You know
training.
what? New
And if that was
perspective.
a possibility,
I'm
once you got in
sorry,
the
bro.
air,
I'm sorry, but like
you would have a lawsuit on your hands.
I hate to say this
right?
shit, man, but
But you'd
there's
be dead,
so much
so it
more
didn't matter.
anxiety in the way you're delivering your message. Why do you have so much more anxiety in it right now?
You know what it is? Because I've been DMing with with Jesse about this as we speak. And it's like the frustration that he's not understanding what I'm saying. I'm like exerting a little bit in this conversation, probably more than you'd expect. But it's one of those things I've been talking about and harping about for ever since I figured this out, that it's not a spinning ball, and this plane travel proves it more so than any kind of curvature measurement ever could. That's where my frustration comes out. We can go over refraction and hidden values and till the cows come home. They've got it figured out. They've got it so slightly curved in their measurements that if you ever tried to do a test like we're talking about with force to line, and train tracks are enough give to show that it could still be curved, then there's no other way to get there other than just coming to some of these common sense conclusions that it just doesn't work. You can't gain sideways momentum unless Meisty has some other way he hasn't explained, other than you just move into an atmosphere and you're automatically in sync with the Earth, even though it's 500 miles difference over 4 hours period. No, you wouldn't work. It wouldn't work. Literally, anybody can walk through the logic of it and see that it's definitely not a ball if planes are flying and landing just like they do in a simulator.
You're talking about common sense logic, right? Basically, because it looks flat, it is flat. Is that what you mean?
No, it's because you couldn't land a plane on a spinning ball, bro. If the runway's moving, and irrespective of your plane's movement, then you're going to land on a moving runway. And that never happens. And we all know it.
Well, it's like they kind of need something like, imagine like you have a little golf ball and then you cover it in Jello. So you get all the Jello to stick to it, and then you spin it, and then the Jello spins with the ball. I don't know. They would need something like that, I guess.
Yeah, you know what, Gio? That's exactly
would never
what we're
be in
talking
sync with the
about.
ball.
That's exactly what me and New Perspective are talking about, Gio. Thank you.
Jello balls.
Branch is always on the winning side.
But it's not, the Jello only partially goes with it because you got Coriolis. So
you have fluid dynamics. Yeah. They already claimed the atmosphere is not in sync with that's not in perfect lockstep, right? And you would need the planes to be in lockstep.
Right. I know. They should have stuck with lockstep. They should have just grabbed onto lockstep and been like, yes, it's lockstep. Because it's the only thing
They tried, but they got fucked with that because people were like, no, wait, we have fluid dynamics. There's no way it's in lockstep. You're saying that somehow it's Velcroed? And if the plane's automatically in lockstep with the Earth, it would never be able to fly against the spin, which it must do to go anywhere.
Yeah, and then add Coriolis on top of it. Yeah.
Yeah, it doesn't work. Literally, any third grader could understand this if they were just shown the visual of how, oh, okay, now when I land, my runway's moving. Mommy, my runway's moving. How am I going to land? It's the most nonsensical thing when you think about it, that people can actually fly planes and think that they're on a spinning ball. The ramifications would be deadly. Glad you're still here with us, Parsi Meisty. There's a good reason for that. They're not on a spinning ball. It's the most hilarious thing when you think about it.
RC Micey, I was just thinking, he kind of went from like hardcore anti flat Earth dude, like I feel like a couple years ago, and now he's kind of like very open to it. Let's just put it that way.
Really? I didn't know that.
Geo, I have an incredibly straightforward view on this, and I've told it to you, and it's been the same damn view since I got here. I'm happy to accept if the Earth is flat. I need this very practical, measurable, applicable thing, which is what
I
are the
just gave it
distances?
to you.
I mean, I'll give you something. I'll give you something very measurable. How about this, RC Maisty? Is there any flat earther in this room that can tell me why a gallon of water, let's say distilled water, in Texas, where I live, will weigh less than that same type of distilled water being in a gallon, let's say in, I don't know, Scotland? Why? Why does a gallon of water in Texas weigh less than, I'm sorry, I meant less than a gallon of water in Scotland?
Well, there's all kinds of anomalies with what they say this gravitational thing does. You know, there's could be electromagnetic differences with the toroidal field exerting a varying amount of pressure in certain areas.
Whoever was just laughing probably knows the answer.
Is it a joke, or are you talking about the difference in weight of like things that are?
Well, I mean,
closer to the
what I was
equator?
asking is why does a gallon of water in Texas weigh like a lot less? I'm talking about over 1% less
Oh,
than a gallon of water in Scotland.
Oh, because of evaporation. It's so hot there.
Yeah, you got it. You got it.
Yeah.
Because of motherfucker, how the fuck can you explain this with evaporation? I'm sorry, bro. I didn't mean to be so. You know why
Must
I
be a
am.
globe. Evaporation proves it's a globe.
No, that's not why.
I'm just kidding.
I mean, it's not really a trick question, but it kind of is a trick question.
I got it. Yeah, I just thought about the heat. I thought you might have been saying. I thought maybe you were going to say that people are so thirsty there because it's so hot that people drank some of it.
Nah, it's a lot simpler than that.
Yeah, evaporation. But there is a whole claim for the globe about this weight being different, and it's like the percentage, the amount is so negligible. Not to deny that it could be some anomaly with it weighing a little different areas, right? But it's very, very little.
Nah, bro, it's because an imperial gallon is like a lot bigger than a metric gallon. It's just about fucking units. In Scotland, a gallon is like what is it? I don't know. In America, a gallon is 128 ounces. In Scotland, I think it's 160.
That was your whole point?
Yep, that was my point. It's interesting though. Like, you all went to fucking gravity and shit, but in reality, it was just fucking metrics.
Well, there is an argument based around that, so I thought that's what you were going for. Because
And that's why I phrased the question the way I did.
The centrifugal force. It's another thing that doesn't fit with the idea that the atmosphere is lockstep clung to the globe the way they need it to be, so that you can land on an airstrip and all that on a runway without, with everything just seeming like it's just stationary and everything's together. But then somehow there's a centrifugal force that causes weight change. is what they're going to claim, in addition to the Coriolis difference. So it's just another contradiction. Like, everybody knows what happens. If you were a little ant on a basketball and you start spinning the ball all over the place, the ant is going to be so disoriented, and it's going to be all
11 different vectors constantly with speed changes, momentum changes, acceleration changes.
right. But they need to make that just be absolutely stationary, like a stationary Earth, to where a leaf falls to the ground and it's just just a nice sunny day. So everything's just in place and stationary.
When they made this up, they must have just been laughing their asses off at the first people that actually believed it. Okay, so it totally seems like it's stationary. We know, but you're going like upside down all the time, and you're zooming around the space. And if we can get them, they must have had some bets on how many people they could get a day to actually accept this.
Yeah, they probably did some test runs too. Like, all right, let's do this little market over here. We'll come into this town and start pushing it, see how people react, take some reports.
By the end of this, we'll have people saying they believe in science. Perfect. They had to make it ridiculous. They had to make it completely insane. Otherwise, it wouldn't be a belief. They had to make science into a belief. That was the reason. That was part of it. I think why they made it a faith-based idea. These things are so completely ridiculous and extreme. The claims are so extreme, almost intentionally, so that it would make scientism the religion, the one world religion, which it is. And if we're going to get them to believe we landed a rover on Mars, we better lower their standards a lot by then. If that was actually happening, that's what I always like to say. If that was actually happening, we would all be glued to our TVs. We'd be like, that's fucking amazing. Did you see what they just fucking did? They landed on fucking Mars. Holy shit. Look at that. And look at that. And look at that. They went to space. We'd be, like you say, Geo, there'd be so many different angles and so many different depictions of our real-time footage of the Earth spinning and going away from it and, coming into the atmosphere, and the camera got blown out, but they were able to save the film and, or save the video right before it got blown out and transfer it back. And real footage, real footage. None of this
I don't think you guys understand the exponential growth of technology that's been occurring for the last, 300 years?
Yes, there has been. And they want to conflate that with space travel. They want to make it like, because we had advancements in technology, then space travel must be real because it's all in one bucket, right? Is that what you're trying to say?
No, what I mean is, 300 years ago.
Yeah, it's crazy.
The fuck were people doing?
Even 100 years ago.
Yeah, even 100 years ago. 50. At that point, considering the Earth being flat was very plausible, wasn't it?
So then people were taught, supposedly, not much, more than 100 years ago, though.
Fast forward 100 years, and now I can show you a picture of the Earth.
But it's not. It's not a picture. It's a cartoon.
Yeah,
and that's where the divide lies. I
don't even claim it.
The people that believe it's a cartoon and the people that don't.
Well, they don't have to believe.
No, it's not about all this other bullshit. It's whether or not we believe that picture is fake.
There's only two. There's only two pictures or something that they even claim is a real picture, and those are very questionable.
Right. I mean, the ultimate proof
of
the shape of the Earth is a picture of it. And if you don't believe it, then that's got to be the common denominator.
But you think the cartoon's actually the ball, and when they tell you it's a cartoon, you think it's real Earth. Why would you believe
we've got multiple pictures of Earth from multiple different fucking satellites?
Show me a real one. Put a real picture of Earth in the chat right now. Post one.
Yeah, you see, do I seem that type of person that would
post one that they don't
Honestly,
say is
even
the
if I
artist.
had a real picture right now, but you asking me to
got so
post
many.
it right now, do you think I would?
No, I know you can't, so it wouldn't matter.
It's not that
They don't exist.
you don't tell me what the fuck to do, my man.
All right, I
One
won't.
of these days, Branch is going to go online and he's going to just type in "picture of Earth" on Google.
Wait, they're right. They're all fake. Wait, but they even say they're fake, so it's okay. They admitted it, so that means that the fake ones are real.
You've seen the one with
They're
the
real.
Photoshop clouds, Branch, where they took the clone tool and just stamped a bunch of clouds on it. It's just brutal.
Sex in the sky.
I mean, again,
it's just brutal.
If you've got one picture, you're gonna fucking tear apart. That's fine, right? You can do that.
So they're all
you can
like
do
that.
that all fucking day, all night long. But the fact of the matter is that we're not talking about one picture of the Earth looking like a globe. We're talking about millions of pictures.
There
Maybe
are
not millions, thousands.
Millions, right? Millions, right? There should be. You're right.
Possibly
there should be
millions. If you look at the shutter rate of that camera, we're talking about millions of pictures.
Mm-hmm. Right. Millions.
No, that's what we should have, dude. If it was real,
yeah.
With all the satellites and everything, we should have every angle, upside down cities, airplanes. There should be zoom in, zoom out. You should be able to see the Earth, Sun, and Moon all in a line. I mean, they claim they're sending probes to Mars and Jupiter and stuff. You're telling me we don't have any shots of the solar system? None?
Yeah, they do. They got shots of the solar system.
Where?
Go look for them.
Go show me one. A real picture.
No, you asked for a picture. Here's the thing, Gio.
You know how they say
you
you
ask for a
gotta
picture of the
show
solar
us a
system, and I say go look for it. You
know how
expect me to have a fucking picture of the solar system just sitting up my fucking ass? Can I pull it out and show you?
Well, dude, you know how people say, like, you guys should have a picture of the whole flat Earth. Well, how about a picture of the solar system? Where is it, guys? Whip it out.
I actually don't know if we have one, but honestly, if we did have one, the only thing you will see is the sun.
It's bad.
I mean, that's just because the sun's bright as fuck. And it's gonna fucking sway to bright. How's a little fucking bitch like Earth gonna be shown when you got this big motherfucker like the sun just shitting out all this light?
I mean, what we're given are hacked up, jacked up, framed, partial, like no fourth wall. It's all fractured. If it was real, there would be so many high def images of the whole thing. It would be like a wonder.
That's very true, Gio. You know what? Maybe the Earth is flat. Fuck it. Why not?
Yeah, I mean, I think that term flat Earth, you know, I don't know. That's not really the. I don't think that's really the. It's like that term.
That's what you was just arguing about, though, right?
Well, that term, I'm just saying that term was like linked with the globe thing, and so it's like to make that the comparison, like, oh, maybe it's flat. I mean, I'm not saying it isn't because the term flat means horizontally level and so on. So I'm not like, but like, just let's just say a plane of existence, a plane in terms of a surface, like a platform, a foundation.
All right, then if Earth was a plane of existence, why do we have pictures of the Earth looking like a globe?
Because there's a group that are lying. they're selling a cult cosmology psyop story to control humanity, and was many other reasons, but one is to control people's minds in multiple ways.
Okay, and
limit their intelligence.
And we actually then live on some place that we have no idea how it works.
Well, we live on Earth.
And throughout all these years, I mean, we've got to a point where fucking We have cell phones in our fucking hands, computers in our fucking hands, and we can't figure out the shape of the fucking Earth.
They know the shape of the Earth. They know we're on a stationary plane. Obviously, this wasn't just like they actually thought it was a ball and they were wrong. I think Gio agrees with me on this one. That they had to devise it to make us think it was a ball. They didn't actually ever believe it themselves. It's the only way this could have been done.
Why would they give everyone a computer in their hand that could basically those computers in everybody's hand in a fucking heartbeat could disprove the shape of the Earth? Why would they give everybody a computer in their hand?
Branch, the paradigm shift already happened.
With geolocating possibilities.
Just that most people don't know it yet. The paradigm shift already happened. It's not like we're gonna find out something, or if we find out it's flat. We already know it's not a spinning ball. We know this.
Well,
Enough people already know.
The fundamental difference between me and you,
happened.
the fundamental difference between a globe and a flat earther is whether or not you believe the pictures of the Earth are fake or not.
But they already tell you they're fake, Branch. We just told you that. They admit that they're fake.
Okay, so you got one picture.
No.
Right? And this motherfucker said, you know what? Fuck it.
They're all fake, bro.
We had to Photoshop it to make it look cool.
They're telling you that
picture. How many
They're all
pictures? How many pictures do we have?